Et 1, 2, 1, 2, voilà. On est présent ici dans 15 minutes. On va pouvoir commencer. J'espère qu'on m'entend bien dans le stream. Est-ce que ça part bien? Est-ce que ça part bien? Hop, hop, hop. Voilà, voilà, voilà. Ouais. Et. Voilà, 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 voilà. Du coup, voilà, voilà. Euh... T'entends rien? Non, attends, c'est parce que j'ai mute ici. C'est bon? Ouais, 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 ouais. C'est juste que j'ai mute pour la salle. Ouais, ok, d'accord. Donc voilà, comme je disais, nous sommes ici pour ce temps. Ok. C'est bon, ça part? Ok, cool. Voilà, voilà, c'est bon. Et on est bon.
Hello? Oh, right. Hey, hey. So, thanks everyone. Wow, getting up this early and then, wow. Hey, Mervin. Do you wanna, so we have food and drinks all day, so grab whatever you want and then have a seat and then we will start our food day event now. So yeah, please find yourself a seat and if you don't want to sit, you can hang around as well. It's fine. Cool. So basically, thank you everyone for coming to our event. As you probably heard, the event is called RenAIssance. Yeah, we made up the term for Real Not Bluffing AI Summit. The purpose of this event is to gather together all the projects who are actually building, who are actually delivering the products in decentralized AI, like all our co-hosts, our organizers, especially. Shout out to Akash, DCG, Space and Time, Masa, Theoric, Vana, Agent Coin, and lots of others like Faction as well, Ritual, After Party, Exhibits, Foundry, Giza, Gnosis, and our friends Getting X, Exolabs, Wisdom, C3, and Aspa Network. So yeah, these are all the projects that basically in the community, and then I see their products, I see their very featuring functions that we are trying to deliver to the audiences here. And this whole session for today is going to be live streamed. So if your company, your team trying to spread the news, that would be great. If someone who can't make it today or who can't make it to the Brussels, right? So, okay, without further ado, let's welcome our very oh, everyone know him, right? Greg from Akash. Yes, that's our co-organizer for the event today. And then, yeah, of course, they've been in this industry for like 9 years. In the early beginnings, when nobody talks about decentralized AI, they've been thinking about this already, and then have this decentralized compute, decentralized GPU idea, and actually made it into a product that actually works. So, yeah. Hey, Greg.
Product that actually works is a pretty low bar, but welcome to crypto, you know. Hi, my name is Greg. If you don't mind taking seats, we can start off. Quick show of hands, how many of you here know what Akash is? Awesome, great. How many of them use Akash? Not too bad, but I think we can do much better. So today's talk is about how crypto is saving AI. I know it's a little misnomer, but I hope by the time I'm done, you'll be convinced. Let's see. Oops. Let's get this done. Quick background about me. My name is Greg Osuri. I'm the founder for Akash Network and the CEO for Overclock Labs. Been a programmer all my life, but last, I would say like 10 years or so, or 15 years or so, I've been primarily focused on infrastructure. I've written some libraries that are gained some popularity, you know, on the GitHubs. You can see here me trending in the Golang category above the Golang project for my code. I'm the only human being here out of 10. And also that on the right hand is the trending across all languages. My libraries are power some of the most, some of the biggest companies that use Kubernetes, NVIDIA being a big one. NVIDIA actually uses the code we wrote for Akash for their Kubernetes driver. So any network that uses Kubernetes to do GPUs uses Akash software. So even though you haven't used Akash, if you use Kubernetes, you probably use Akash indirectly. See several others, including our very good friends from Department of Defense as well. So Docker and a few others. So there was an article in Semaphore last year that talked about the first time you're seeing a positive spin for crypto, right? So this is in 2023. This is with just coming down from the FTX of the world. And for a whole year, if you open any major newspaper, the sentiment of crypto was interesting, especially working in the crypto area, crypto field. But for the first time, we actually had a positive article that said something about, you know, AI's chip boom is great, but look, it's a problem. You can't get chips because the demand is so high and the supply chain hasn't quite caught up. It goes into a little deeper about a story about a student, a Cornell student, trying to get an A100, which is a NVIDIA GPUs, to do some training, and they couldn't, but he could go to this weird network, a crypto network, and find a GPU from a company called Foundry, and people there that represent the company. So using a peer-to-peer network called Akash. So that first time we talked about crypto as a utility, as actually saving someone or like providing a way for someone to actually train an AI model, right? So, and this is a scenario where you can't really go to a traditional cloud provider and expect to get GPUs, right? And GPUs today are nearly impossible to get on demand. You may get lucky once in a while if you keep scrolling on the page and you might see a GPU and just like hoard on the GPUs. I know people that the moment they see GPUs, they just like keep, book them out, but it is impossible to go to a cloud provider and get a high density GPU on demand. Why? Because the demand is so high, and the hyperscalers that we're all used to, Amazon, Google's, and Microsoft's, are typically where we go find compute, are completely booked out, right? Like they recently announced H100, which is the a most advanced GPU from NVIDIA. And in order to get to that, you need to spend millions of dollars, and it's almost like trying to buy a fancy Ferrari or a expensive watch, where you can't get the expensive watch unless you buy something cheaper. So it's similar to get GPUs now because the demand is so high, right? So AWSs of the world are acting like luxury watch traders now to get to the good stuff, right? And unless you're OpenAI, where they invest in you and then you have the special deal of getting some H100s, that's typically how to get GPUs from the hyperscalers. And then you go to the smaller guys, right? Be it Lambda Labs or be it CoreWeaves of the world, which are the tier 2 providers, where NVIDIA actually has investments. In order to get them, you need to place large orders and wait for a few months before you can get access to the first set of chips. So if you're a university student or a startup company, it's nearly impossible to get to a point where you can actually go raise money, right? That presents a big problem. And what about directly from NVIDIA? NVIDIA is hyper selective. It's the most valuable company in the world, and they're very hyper selective on who they even choose to give the GPUs to, right? It's impossible to buy from them. It takes about 2 years now, I think, of wait time to get a A100 or H100. And by the time you even get the H100, there's a new chip that comes out, and you're already behind in your technology. So it's like the supply chain is so bad, and if you really have to ask why, I think the reasons is because the supply chain is very complex. NVIDIA depends on this company called TSMC, which is based in Taiwan, and that company depends on another company called ASML, which is based in Amsterdam, and this is a whole complex supply chain. And every time, and NVIDIA is just popping out chips like left and right? And every 18 months they come out with a new chip. And every time there's a new chip, you got to retool and repurpose the fabs to suit, and it takes about $10 billion to repurpose a fab, right? Because the technology is very different from different chips. So it's a very complex supply chain to get to these chips, and there's no single solution to it, and there's a lot of investment going to making these things faster, but it doesn't seem to be very promising. So yeah, that contributes to the long wait times from NVIDIA, and what that means for challenges, right? And it's impossible for new companies to even enter the space. And you see quite a lot where you have startup companies who try to raise money from VCs. They ask you, if you're an AI company, they ask you where are you getting chips from, right? If you don't have an answer, you don't get funding, right? And a lot of companies are failing now, AI companies, because they can get funding or they can get the chips. There's a company called Banana Dev. It's a serverless on AI, which is a very popular tool that had to shut down because they couldn't get chips, and it's so sad. It's a beautiful tool, right? There's just one of the many examples today we see of companies going down out of business because they cannot get access to compute. We never saw this kind of phenomenon before, right? And also, you can raise a bunch of money and convince the VCs if you're good at it, and even if you raise a bunch of money, if you go and try to get chips from these, tier 2 providers, the long wait times are bad because the models and the technology is evolving at such a rapid pace. By the time you get access to the chips that you ordered, your needs may change. And in a startup company, time is your most valuable resource. And if you lose time, that means you lose iteration capability. If you lose iteration capability, the chances of you succeeding gets lower and lower, right? So it is antithesis to the situation is so pattern to what startup companies are used to, and that's a big problem today for these companies to succeed. But on the other hand, GPUs are everywhere. I mean, GPUs are not exclusive to cloud providers or NVIDIAs of the world, but people that actually do AI and have been doing AI for a while own a lot of GPUs, or even people like foundries of the world that are doing crypto mining, that are primarily Bitcoin miners, have a lot of GPUs, right? So there's GPUs everywhere, but people that have GPUs are not cloud companies, right? So that is where the biggest challenge in how do you really bring these GPUs to the people that need them, right? And also other areas you look at, GPUs when you upgrade, right? OpenAI has trained GPT 2.5 on, I think, V100s, and GPT-3 on the A100s, and GPT-4 with H100s, right? So what happens to the V100s and A100s, right? So those GPUs are everywhere as well. So there's an incredible opportunity to bring those older GPUs, which are still pretty good for most use cases, to the market, and that's really where that's really where where we and all of us here are playing, right? And also look at GPUs between training cycles. If you train a model, you're not usually or immediately training the next model, right? You're taking advantage of what you train. You're probably doing some inference on top of it or some fine tuning and offering a product. But what happens between training cycles? So there's that opportunity as well that we had to look into seriously. Akash is a radical way of sharing GPUs or sharing compute in general. I mean, we introduced a notion of a supercloud in 2018. In fact, our white paper, if you read through, had a whole section on what GPUs or a machine learning cloud could look like. We kind of anticipated the problem because machine learning has been around for a long time, right? I mean, transformers came in 2020 and radically changed how we think about it, but machine learning has been around for a long time, and cost has always been a problem for machine learning because of the computational complexity. So we took that problem set and figured out, wrote a solution, proposed a solution, in fact, in our white paper. And the way it works is very simple. Providers, people with compute register to the network, and users, we call them tenants, specify what they need in this format called SDL, and they specify the price they're willing to pay for the compute, and place an order on the marketplace where the providers then bid for this compute using a reverse auction mechanism. So you set the price, and providers, that are willing to serve your workload at that price, bid, and you, ultimately a tenant, choose which provider you want to go with, right? So then a lease is created, and then it gets into a peer-to-peer mechanism, right? And the advantage of this model is just availability. Like Akash has incredible compute H100s, A100s, and amazing price. And sometimes you see, it's a marketplace, so you get a mid price, but on average, the H100s and Akash are sub $1.50. For comparison, if you're lucky to get an H100 on Amazon, it costs about $9 an hour, right? So Akash can give you for $1.50, A100s for under 80 cents, right? So it's this wide range of compute, but it's the first time, the only place in the world right now that can get on-demand compute for general purpose use cases, right? There are other special purpose use cases. You may get some compute, but if you were to write, do anything you want to do, like train or fine tune or infer, Akash is the only place to get A100s or H100s on demand. And that's something, right? It's permissionless. It's no one can stop you, and I can't stop you as a creator of the network, right? And that adds it to a new level, because today in the world where we have heavy gatekeeping by the hyperscalers and a lot of other factors, I think permissionless becomes an incredible property, and it's peer-to-peer, right? So that gives it scalability to beyond your imagination. Peer-to-peerness removes these bottlenecks that you get with specific scheduling and whatnot. and it makes it extremely reliable, right? And is radically open source. I mean, there is no aspect of Akash that's closed source. I mean, of course, the source code has been open for a long time, but a few years ago, we made a conscious decision to do the process of creating the source code and process of setting the roadmap itself fully open, right? So it's organized in something called by something called special interest groups that are in charge of different areas of the network. The steering committee that sort of like governs these special interest groups. There are working groups that are ephemeral in nature, where if there's a project, there's a working group that gets created. And there are special like user groups that for every some special interests that get self-organized. About 500 contributors. There are about 30 proposals, funding proposals. There's an on-chain public goods fund that anyone can apply to. The process usually begins with making a proposal in the discussion forums, and then going to special interest groups that have interest in that proposal, and then placing an on-chain proposal to get funded. In fact, Akash website and a whole lot of things that are run on Akash are funded by the public. Now we have incredible interest from universities, right? So we have a professor from UT Austin that made a proposal for verifiable hardware. There's another proposal that's coming for runtime verification by University of Illinois Urbana. There's an MIT professor working on quantum computing for Akash. So we're able to tap into this incredible talent pool that we normally can't tap into as a typical company by having this open source and public goods model, and that's just getting higher and higher. Now you're seeing quite a lot of published papers in the recent past that are talking about Akash, because some of these students are able to leverage this pool to get grants and actually do research, right? So Akash is going places where we never thought we never really planned for such an outcome, but having that radically open source approach opens doors that goes beyond our imagination. Oops. Did that totally. Okay. And it's a growing ecosystem. Our users are amazing. I mean, Flock is a big user. Flock community has been extremely great. We have, Flock is not here yet because this slide was done before Flock was integrated, because you can see how fast we move. Vana AI, which is Eric Voorhees' new project, uses Akash. He's very proud and he loves Akash, and someone that prominence talking about Akash is a good testament. We have Brev.dev, which is considered to be the Firebase of machine learning. It's really simple way to do fine tuning, use Akash. We have quite a lot of really good products that are now built completely on Akash, and that's growing rapidly by the day, right? And today, so far, we served about 58 million gigabyte hours of memory. That's a good measure of success, even though Akash has multiple variables that indicate different aspects of the system. I think memory is one of those most scarce resource that is easy to measure. You can see the trend. I mean, last quarter we shot up quite a lot, and that is primarily because GPUs. About 186 applications have been deployed on Akash, live active applications. You can see the trend as well. That correlates with the memories, right? So now I want to do a live demo, and I love doing live demos. We got about 5 minutes, hopefully, and I'm so confident in the product that it always works. And that's the beauty of decentralized systems we don't talk much about, is the stability and the availability, right? So I'm going to do a demo, and it never failed on me, so I have no reason to think it's going to fail on me now. So let's do this. So to use Akash, I'm going to sit down here quick. To use Akash, you can go to console.akash.network and click deploy. It begins with something called an SDL file. I have a pre-configured SDL file here. I'm deploying OLlama, which is a inference router. Here I'm saying, deploy the container, the ports, pull Mistral, which is a model, and find me any GPU, and create the deployment. Put some money in the escrow. Approve the transaction. So this now is going on the blockchain, creating an order. You can see the transaction. It takes about 6 seconds to finalize. So this is going to come in a bit. Now I got a bunch of bids. As you can see, I got Foundry giving me a bid for V100s, and I have another provider giving me a bid for A100s. Similar pricing. I have an H100 as well here. You can see a bunch of chips from different providers, right? This is NVIDIA A100 for surprisingly low amount, but I don't think that's audited. So that gives you kind of confidence on the provider or whatnot. I'm going to check for A100 here, accept bid, and approve. And I can see a transaction here. Just to show you what's happening underneath the hood, the information that gets posted on chain is just the resource information and not identified information, right? So you have privacy guarantees there. Here it says I just want a GPU, 1 unit and a CPU and whatnot. And this is the owner. This is the depositor. You can also see the lease gets created here in a second. Wait for that. And we can see here events happening on the background. This container is being pulled. You can see the logs, what's happening here. It's pulling the weights now. And once this is done to 100%, you should be able to actually do the inference. So it took, 90 seconds to get a GPU on Akash, right? It's the fastest experience of any cloud, be it decentralized or not. Once this is ready, you can click on this and kind of see that Olama is running right in the same port here. I'm going to copy this and put it in a curl command. Give me a second. I need my 2 hands for this. Okay, so who is Greg Osuri? Doesn't know it. What's a good question to ask? I want some creative prompts. Anybody? What should I ask? Unfortunately, it's not trained in real time. What is federated learning? Okay. Okay, let's see. This is done 100%. What is federated learning? So this is a model. There you go. Oh, who is federated learning? Well, I believe there might be a confusion here. Federated learning is not a person, rather a machine learning approach for decentralized and collaborative training of AI models. It allows for multiple entrants to train model in the local data. So that's how fast it is. So I was able to deploy something in a country with, I have no idea what the situation of the internet is going to look like. Permissionlessly, no information was given, paired with crypto in a matter of seconds, or to deploy in a matter of minutes by the time I can make it usable. And this is the fastest experience you can ever get of any cloud. With that, I'll take questions. Question there.
Hello. It might be a naive question, but if how you described the current situation, you can wait for NVIDIA or other gatekeepers, or you can use Akash. It seems that you should have hundreds or thousands of clients and be multi-billion company already several days ago, at least.
Yeah. So biggest barrier for adoption is crypto for Akash. biggest reason for Akash success is crypto also a barrier, right? There's the best part and the worst part. Our big challenge right now, if your crypto is a beautiful experience, I mean, but also you need to have a wallet and you need to have this AKT in your wallet. You'll be surprised how hard it is for people to get a wallet installed that is not a crypto person. So if you go to a traditional machine learning engineer, the moment they have to install a wallet, the step, our conversion rate is less than 0.5%. So out of 200 people that come to Akash network, one person, if they're successful, might use Akash network. That is very low for any product, and the biggest drop-off is at the wallet install step and getting AKT, even though you can go to Coinbase and pretty well liquid token, it's just impossible to go through the process of KYC and all that stuff. So the way we have to fix that is two approaches. We can take the shortcut of like putting a UI and put credit cards and all that, or we can do a decentralized approach that we figured out a novel approach called trial wallets that's coming out in a couple of months. This approach lets you stay non-custodial and true to what crypto really is while removing the barriers of wallet install, right? And that's the big challenge. It's not like how, and another big challenge is people just don't know about Akash, right? So it's not been around for a long time. It's a brand new, GPUs are a brand new feature. As you can see, the last quarter, leases went up to significantly higher than what was the previous quarter, and that's because of AI chips, essentially, right? So people are finding out. We're starting to see quite a lot of awareness that's being spread and recognition in the space. So it is a time function, right? So as more people understand and learn about Akash, they're using it. But on the bright side, our stickiness is very high. Our churn is very low. So once you use Akash, you love it. They get it, right? It's just getting to that first crossing that big chasm is a challenge for us, right? But we're also hiring marketing folks. So if anyone of you are technical enough that like marketing, please come talk to me. So if you want to help spread the word, I think this is a great opportunity right now. Because you have a great product, but again, we need better growth and awareness efforts. Question there?
Hey, thanks for the demo. That was the first time I've seen Akash and looked very slick. I'm interested in the permissionless aspect. So if I have a GPU and I want to submit it to host it for people to use on Akash, what does that look like? How does that differ versus like a vast instance or Lambda Labs instance? And also interested about the auditing aspect of it. So is that also permissionless, or is there a kind of element of centralization?
Right. So the process to put a machine on Akash is pretty straightforward, but you do require Kubernetes knowledge, so which may be a barrier for folks. But if you go to akash.network/providers, you have all the instructions. It's pretty well documented on how to put machines on Akash. Akash is Kubernetes based, and there's also an app called Praetor. If you go to Akash's provider page, you'll see which has a UI and had an automatic. I think they're working on an automatic way to deploy Kubernetes as well. At least a standard Kubernetes that you can get up and running. So I haven't used Vast on the provider side. I don't know how different it is, but I believe Vast is more the hypervisor, and Akash is just containers, right? So it's relatively easy if you know Kubernetes, but that could be a barrier to people. And from the auditor's side of things, auditing is an optional aspect of Akash. There's a decentralized set of auditors, and each auditors have different level of quality. So you got to find an auditor. Again, finding an auditor is a challenge. I think there's a page that lists all the auditors. And Overclock Labs is our auditor as well. So more auditors you have auditing your infrastructure, the better it is, because that improves trust. And auditing is a web of trust mechanism. So if I trust an auditor, through that proxy, I'll be able to trust other folks. But also now we have verifiable computers coming very soon. Verifiable hardware, at least, not runtime verification. They're two separate problems. But using verifiable hardware, you'll be able to, if your machine has TEE, or trusted execution environments, we'll be able to verify the hardware using trusted execution enclave, So that makes auditing much simpler or removes the requirements from the auditing. But you still need auditing for the software aspect in terms of compliance, right? HIPAA compliance or SOC compliance. There's no way to verify on chain for the compliance. So the auditors play an important role in checking the off-chain compliance, right? Because there are healthcare users that want HIPAA compliance for a data center, and there's no way to do on-chain HIPAA compliance. Not yet. Hopefully that'll change, but yeah. Yeah, happy to show you around how to deploy. Oh, we have one more question.
Hey, since you are mentioning the joining the network, so I have a question. Is there any incentivize if I join the network, but I haven't received any real computation workload? And if there's incentivize, how does it make sure like I'm not faking my machine? Say I just have one server, but I can run 100 virtual machine to prevent, to like pretending I have 100 servers here.
So the question is, how do you prevent Sybil attacks when you have incentives, right? Which is seems to be a problem with a cloud we don't want to talk about. So Sybil attacks are very common in crypto, especially when you have incentives. So Akash is pre-incentives. We don't have incentives yet. That is public, right? So there's a pilot program running. There's a provide incentive pilot that is a little bit more centralized. It's not on-chain. It's off-chain incentives. And we are doing that to understand incentives, so you don't have Sybil attack problem because it's not on-chain. But when we go on-chain, we need verifiable hardware, right? So that verifiability is achieved using trusted execution environments. And we have Professor Sriram from University of Texas working on this proposal. It's on a discussions forum. I think this will be funded by today or tomorrow. But with that, we can verify what kind of hardware they have, and you cannot cheat, right? So without verification, you end up in a scenario where you get attacked left and right, and crypto is wild, right? Like, so don't do verification, don't do incentives without verification. That's the rules. Welcome. All right, so thank you so much. You've been a great crowd.
Thank you, Greg. Yeah, that's fascinating, and yeah, that's also a great pleasure for us to work with Akash. We actually, well, this is our schedule today. Yeah, we actually have your slides here. I'll just skim it, don't worry. Yeah, so, well, due to the schedule, we're a bit behind, so I'll leave Flock's session a bit later in 3 p.m. this afternoon. But generally, we will also talk about how Flock is working with, this is our paper early, talk about how Flock doing different, federal learning using blockchain to defend against poison attacks and lots of Sybil attacks that you just mentioned, and also a live demo that we can show here about how we work with Akash. Actually, that people can now easily just using Akash to spin up an instance and run Flock training and validation nodes, which I'll show later. We want to chase a bit about their schedule, so let's go with our next panel discussion with Anna, Mohammed, Arbion, and Ato. Welcome to stage.
Welcome everyone. Really excited to kick off today's panel discussions together with Mohammed, Arbion, and Aito. My name is Anna. I'm an investor at ETHCC, and I'm looking at early stage investments at the intersection of AI and crypto. And I've been chatting with these founders and many others as well. And I think in the last months, I haven't really seen DEX without mentioning AI to a certain extent. But it's really hard to filter and find like what's going to be really the next innovation. And that's what we are going to today discuss with these guys here. So maybe you guys can quickly introduce yourself, what you are building on, and then we can jump into the questions.
Awesome. This hold up? Great. Hi guys, my name is Ato. I studied computer science at Oxford and we're part of Gatling X. So what we're building at Gatling X is self-evolving AI through reinforcement learning, where the AI can kind of figure out how to do a task better than human beings on its own, and we've built this infrastructure called GPU EVM, which is the fastest EVM implementation in the world, so that the AI can sort of have a training ground for getting better and exceeding human capabilities when interacting with the EVM.
Me? Hello, my name is Arbian. I am the founder of Veracity Labs, which is basically what we call C3. And I prove that images are real using cryptography so that people don't get duped by deepfakes.
I'm Mohammed. I also studied at Oxford at a PhD in AI and robotics. I work on something called EXO. EXO is an edge AI protocol, how to run AI models on like your phones and laptops and networks with them.
Cool, thank you guys. I think we can all agree here that there are significant costs associated with training, tuning, inference. So what do you guys think? In what ways can each of these be decentralized, and in what ways is a centralized approach better? Maybe Aito, you can start and then.
Yeah, I think there's a lot of sort of fundamental difficulties in decentralizing training. One of them is really around sort of how GPUs work. I think one of the sort of most common misunderstanding is like a H100 is not equivalent to another H100. Or at least it sort of depends on lots of different things. One of them is, for example, how they are networked together. So NVIDIA has this technology called NVLink, which allows super fast communication between two GPUs. And so, two GPUs that are like co-located next to the same computer, connected with NVLink, acts very differently from, let's say, one GPU in China, one GPU in America, and these two GPUs perform many orders of magnitude worse than sort of ones that are co-located together, which obviously sort of brings this question of, is decentralized GPU networks and decentralized GPU training really possible, or is centralized the way to go? I mean, if you look at top-line LLMs, they are now sort of multiple hundreds of gigabytes to terabytes, and so is it really possible to shard it across? It's an open question, and I think the higher probability is that training will stay centralized for much longer than we expect.
Okay, so there is a massive difference between how AIs are run in practice when you need a result out of them and how they're trained. Running them is a lot easier to do in a decentralized way, because all you need to do is pay a node on a decentralized network to do the computation for you, right? That's pretty simple. And then you need a way of making sure that they don't lie to you. And there are quite a few ways of doing that. When you train an AI, you gotta, first of all, if you're trying to like do privacy on the data where you don't reveal what it's trained on, you're gonna have to do some cryptography, and cryptography runs tens of thousands of times slower than just like the normal way of doing it. And if you wanna like have multiple people collaborate on training the same model over a network, then you have to deal with the fact that networks are slow, which is really, really unfortunate. So I am a lot more bullish on like this idea of decentralized AI inference. I think that we're getting there. I think it will take a little while longer to get decentralized AI training working in a way that is efficient and competitive with decentralized solutions.
Mohammed?
Does it answer the question, or should I add something?
If you want to add something, then add. Otherwise, we can jump into another question.
Yeah, it's just the TLDR is if you need to network between multiple devices, if I have a big model, for example, I have a big workload like training, then communication overhead becomes an issue, right? And if these things are not in the same location, that's obviously hard. But training could work with small models, because it's just like on one GPU. If I'm training a very small model and I just need to go to one GPU and train on there, there's no problem. The problem comes up if I have a big model that needs to go on multiple GPUs and those are not in the same location. Yeah.
These are all great points. I would move to the data piece, as data is often a king maker in AI. And with centralized approaches, we see how data collectors are contributing biased data that can lead to biased models. Data contributors are not rewarded. So we have seen a couple of decentralized data marketplaces emerging. What do you guys think? Are these decentralized data markets feasible? And if yes, then what mechanisms need to be put in place in order to ensure quality and diverse data sets?
My sort of personal sentiment around AI data is we've saturated the entirety of the internet, which is around 0.2 petabytes according to OpenAI. It's this data set called OpenCrawl. And I think where sort of the next phase of AI data lies is really in nutritious, high IQ sort of, data. So these are data sets like Quora or Reddit, which is why sort of Google is paying them 100 mil a year to acquire this data. I'm personally sort of very pessimistic about these decentralized AI data marketplaces because sort of by construction, the IQ of the, like, let's say the average person isn't that high, and that is really the thing that's going to move the needle on current AI LLM progress. You know, like a terabyte of data is not equivalent to a terabyte of data. You really care about nutritiousness of the data rather than the quantity. And I think that these decentralized AI data marketplaces are only likely to contribute sort of low quality data. What we really need is stuff like, you know, a lawyer specialist curated data, or, you know, a scientist like research data where you don't actually like train on the research paper, which is like the complete product, but like sort of reasonings about why things didn't work, all of the things that doesn't get published. And so I'm personally quite pessimistic around data marketplaces.
Mohammed, do you agree with Aito, or?
I agree that the thing that moves the needle is like quality data, and we've scraped the open internet already. I think decentralized scrapers that can get around walled gardens and like scrape new data, that could be useful. But I don't have a good intuition for these things, like beyond like the skill data we already have.
Yeah, so with data marketplaces, there's a concern, as Aito said, that you might feed in a bunch of dumb stuff and pay people to create dumb content. And the reason that this is particularly bad is because with an AI, the way that it works is what goes in, training the model, right? It's going to produce things that look like what it was trained on. That's basically what it's meant for. If you don't have high quality data, you're screwed. The question is, how do you determine the quality of the data and pay people accordingly so that you can actually have efficient markets for this rather than paying people to just generate something in ChatGPT and feed it back in to another AI, which would be awful and just like diminish the quality of the model. There are no clear answers yet. Maybe for video there is, so long as you can verify the sources of the video and verify that the video is unique. But with like text content, we've basically screwed up. And all of our sources of text come from the internet, and that's all been used up, as Aito said. So yeah, that's where we're at.
Actually, I want to add just one more thing. There's a very nice blog post done, I think, by Meta, of like, they actually tried to calculate, okay, all of this data on the internet, you know, if you adjust it to the value they provide for these LLMs, then how much would they be worth? And so they sort of did this like ROI calculation of like, if you actually fairly rewarded these data providers, then would the economics of LLMs make sense? And the conclusion was basically it doesn't make sense at all, right? The LLMs only make sense because they acquired all of this data for free, and acquiring sort of like paying fair value for these is just not economically feasible with the ROI of LLMs today. And so there's sort of a economics question of, you know, is this actually sustainable, or does the ROI make sense? I think this is like an open question with no definite answer, but it suddenly points towards the infeasibility of data marketplaces and revenue share.
On that point as well, like selling your data is unlikely to be like high enough in terms of economics that you care about it. But like personalizing your own models on your personal data is very valuable. So like much more interesting than like just like getting people to create their personal data to train a slightly better model. Just like if your data just makes your model personalized to you, that's like a much better improvement in user experience compared to like making $3 a year by scraping data for a year or something.
Yeah. Yeah, definitely seen a couple of these marketplaces popping up. Besides data, I think the other question that we keep asking ourselves, especially with like a lot of investors I talk with, are around agents. We have seen many agent players, and our main question is defensibility and go-to-market, especially in the long term. So how do you guys see how defensible are these AI agent models, and what do you think in general how this space will take off, especially for smart contract automation? Maybe you can start, Arbion.
For AI agents, all right, there are kind of like two camps, right? You got the agents that are supposed to be good because they go do the thing on their own, right? And you don't have people intervening. And then you got the agents that are like useful because they interact with each other, and like supposedly that makes them more intelligent or more capable at getting the work done. The first kind of thing might make sense so long as it's highly reliable and you have railguards. But the building of those railguards is actually the bottleneck, making sure that it doesn't go rogue and create really terrible answers or just, you know, kind of screw up working products. In terms of putting together a bunch of different AIs in an agent framework and hoping that if they like work together that they'll become smarter, there's no clear evidence that that actually helps, especially because bigger models are cheaper to run and also tend to be disproportionately more intelligent. So I'm kind of bearish on that interpretation of the agent dream.
I think with like agent type models for like on-chain transaction, you know, like intent-based or like chain abstraction, that kind of stuff, I think it's really interesting. I think it's really good. One like challenge that I assume will happen is like no one wants to be aggregated. Everyone wants to be the aggregator. So like the chains don't have really an incentive to work with you, for you to build like an abstraction layer that like abstracts them away and basically commoditizes all of them. So like a big problem, I think, like some of these like agent intent-based approaches will have to face is like the go-to-market. Is like the chains would now want to be aggregated. They want to be the aggregator. Yes, that would assume would be a big problem there as well.
I think AI agent is this very like nebulous term, and it has sort of multiple different types of interpretations. I think one of the important things with agents will be what application it's for, and then another thing is there a simulator that can ground the hallucinations of the LLMs? So I think a lot of people tend to think that LLM hallucinations are a bug. I would actually argue that it's a feature, not a bug. And the right kind of mental framework to have is that, like, at any inference step, an LLM has a probability P of it going wrong, right? And so you have to sort of treat these as probabilistic systems rather than deterministic systems. And, you know, if you have sort of multi-agent systems, then what ends up happening is, let's say on average, you know, you have an error of P. So like with, you know, n steps of like the agent thinking step, for example, you have an exponential increase in the error rate, which means the quality of the things or the sophistication of the things that the AI agents can do just decreases exponentially. So what is really important is that you ground these LLMs along with simulators, which can give fully deterministic and fully reliable feedback, so that the probability P of failure can sort of be diminished over and over and over again. And I think this is sort of how we unlock the next phase of AI agents. And this is sort of why we came up with GPU EVM as a way for the AI to be able to fail like lots and lots of times, but it can learn from the mistakes, from all of the failures, from, you know, running 100x execution and just, yeah, the AI to self-learn from its mistakes.
As I asked you guys regarding defensibility and go-to-market, this definitely applies also for all of you. And I would like to ask you, like, what do you guys recommend to other early-stage founders, especially now in these times when OpenAI, XD just keep getting more and more funding and having new innovations, how to build companies with strong defensible moats?
I think you have to go very deeply verticalized. I think that sort of LLMs will continue to have this hallucination problem that I talked about before. And so I think the differentiation is always going to be in how like verticalized is your AI agent stack, and also like simultaneously assume that LLM intelligence will increase and build your system in such a way where, you know, you are thrilled about a 5x intelligence boost in the base LLM, and you also assume a commoditization of these LLMs. And I think that's the way you build a moat, which is like, you just assume LLMs get better, and then you ask, how can you build a architecture that's specific to the sort of user needs that you're servicing, and yeah, just to really ride that wave and build all of this vertical infrastructure, such as GPU VM, for example, so that you have this multi-layer moat that is harder to disrupt. I think Devin is like a really good example of, yeah, an AI system that benefits from LLM intelligence increase.
So what I would say is, don't bet on LLMs getting better. Now, they will get better. That's not what I'm saying. I'm saying don't bet on them getting better. Why? Because although they will improve in some capacities, we don't know which dimensions they will improve in, right? Like, we thought that we would get to kind of like reliable self-driving cars before we got to AI that could write good poetry. But here we are with fantastic ChatGPT poetry, and we're still unable to follow the rules of the road in AI. So that's unfortunate. So bet on the limitations of AI that are durable and here forever, and build defensive technologies, because that's the kind of stuff that has longevity.
Mohammed, especially now after your trip in San Francisco visiting Apple, Samsung, any takeaways and
like, I don't think much about moats. I think you want to have product market fit first, and then you think about moats later. But generally, like, I think Ato mentioned one point that's very important, which is you want your product that you build to benefit from like the breakthroughs that happen and not be redundant. So if I'm Duolingo or something and I'm using ChatGPT inside my app, GPT-5 comes out, my app is better. And that's a very important thing. Yeah. Not your app is useless, or your app, like the ChatGPT wrappers and stuff like that. Or let me train a model from scratch that can do something very niche, but then GPT-5 comes out, it can do everything better. So like, don't compete with OpenAI, kind of. It's not per se a very smart move as a startup. And the other thing that I personally think about a lot is like focus. As a startup, you live and die by focus. If you try to do too many things, you're gonna die anyway. So like, don't try and do too many things. Just find a minimum number of things that are important and do them. Ideally, one thing. So that's what I personally focus on. But yeah, I'm not sure if this is good advice for general people.
And what are you excited about in the DAI space? So if you would not build EXO, C3, and Gatling, like what would you be focusing on, or what should other builders build?
I like hardware. I think like there's this famous blog post in AI called The Bitter Lesson, and about like how AI has progressed over time, and it's typically very general methods, like specialized hardware around it. The first good like neural networks for like image recognition, CNNs, were like in the 90s, and they were good, but it didn't scale. So people abandoned them and started to design all these models that like handcrafted. Until 2014, someone was like, oh, let's just get this general model of CNN, but use it with a GPU, and that beats everything else. So I think like just specialized hardware is like specialized hardware, generalized software is like a generally good bet historically. So if I was working on EXO, probably I think about some special chips or something for your phone that can like run very efficiently.
Arvion?
What we want is things that will improve the security, the reliability, and the performance of AIs. We don't have to touch the models themselves. Plenty of innovations happening there. One great thing that people should definitely start working on is hardware that not only is tailored for running LLMs, but is tailored for running them safely in like isolated boxes. It's like a security-focused approach to hardware that simultaneously rolls in like the acceleration features that Mohammed is saying are necessary. And I agree that these accelerators for AI compute are going to be very, very big. So yeah, build defensive technologies, build things on hardware, things that are tangible, and don't go and try and compete with these people who are all flocking to make the best model, because you will not win, especially because you don't have a data advantage.
Yeah, maybe not decentralized AI, but one of the things that I find fascinating as an opportunity in sort of the intersection between crypto and AI is actually like regulatory arbitrage on the fact that currently you can't really do payments with AI agents. So sort of like you can't use traditional payment rails for payments as easily. Whereas with crypto, you know, you can let an AI agent go ham and like really spend on your behalf and also receive money. And I think there is definitely a really interesting design space there where sort of you take a traditional Web2 product and somehow try and sort of automate a lot of the work that a human would have done, but using crypto payments as rails, since you can't do it with traditional like Stripe payment rails because of, I think, regulatory barriers. So I think there's something interesting there that, you know, maybe exists already, maybe doesn't. I think that's the most exciting area for me, yeah, personally.
Thank you, guys. I'm going to open up. If you guys have questions, please feel free to ask them. I'm not sure how much time we have, Jiahu, but maybe a few questions.
1 minute.
Yes.
A question to Urban. Could you please elaborate on what you mean by defensive technology for AI or something like that?
So a good example of this is what we're building, right? So there's a branch that says AI is going somewhere. We're going to like have these models that are going to do all sorts of great things. So we should just like build products that depend on capabilities that don't yet exist. Whereas there's this other branch which is there are problems that are created by AI here and now which need to be mitigated, right? One, like the leakage of data. Two, like unreliability of results, making sure that LLMs get good feedback, which you can't just solve by scaling up the LLM. You need to build things that catch out errors by like actually inspecting the results properly and programmatically. And three, things like deepfake mitigation, which is what we're focused on, right? So take the problems that are here and now, right? And then find creative solutions that can't be like easily replicated. Things that are crafted to specific markets and specific verticals. This is a whole family of ideas, right? And then pick something that is just like got a really good moat, and then go for that. Something that solves a fundamental, core, immovable problem that is inherent to AI.
Any more questions? Good?
No, okay.
Awesome. Thank you, guys.
Thank you. Thanks, man.
Thank you. Yes. Right, thanks. Thanks, all my friends from Oxford. Those are great projects that if you are interested, feel free to talk to them. So rest, we will have a bunch of new feature announcements from our real non-bluffing friends, right? So due to some time arrangements, I will have Arnold first to talk about Theoric and their new updates. So sorry, I pre-planned the slides, but this should be yours. Yeah. Arnold, you can use this one right away. Yeah. All right, and next up, Nesta.
Thank you. So which one? Okay. Hi everyone. Thank you for having me. My name is Arnaud Flamant. I'm the CTO and co-founder of Theoric. So to start with, I want you to take a little bit of time to think of your day, today or before. How many machines you use, how many mechanical force you used to be here today. So maybe in average, you have maybe 200 machines helping you. But tomorrow, imagine a world where 200 brain power is behind you. So really that's the key of what we are building. So a place where we could have brains around us. So today, what we are thinking is we want to build a place where we have decentralized AI with dynamic agents. So today you enter a prompt, you get a response from the LLM agent, and that's it. But what we want the place to be is to send a task to a decentralized place of AI agent, and all those agents are solving a task and get back to you your solution. So how do we want to get there? So we are thinking at Theoric that we need to build a solution based on three different pillars. The first one is intelligence. The second one is collaboration. And the third one is trust. So intelligence. So we want to use AI agent as the base foundation for the intelligence piece. So an AI agent will communicate through prompt and with some AI and LLM. They are enhanced by tool and knowledge base. So at the end of the day, this single piece of intelligence is the AI agent. And after, what we want to do is to combine those AI agents into what we are calling collectives. Because we deeply think at Theoric that a single AI agent will not be the solution. We are definitely thinking that a team of AI agents, what we are calling a collective, will be the solution to have better performance. Just before in the panel, they say that you need some security, you need some different aspects to build a solution. So having a team of agents that have a different role between each other is the key to make good solutions. And also we want to use the decentralization aspect and also the Web3 community to build those agents, to build those collectives, and to use the Web3 decentralization and payment mechanism in order to build those collective of agents. So at Theoric, the plan is to solve key challenges in order to build those team of agents, those collective of agents. The first one is to have a layer in order for those AI agents to operate. So communication layer, to have the ability to measure the performance of this agent, and also to conduct payment, because we are also really convinced that the payment mechanism is important to have a fair retribution between the agent builder, the one that is deploying the agent, and the one that they are testing the agent. And after we want, in the solution, bake in the protocol also to measure the quality of the agent. So that's something that, like in the real world, you have good and bad actors, so we want to constantly measure the quality of an agent to record that on chain in order to promote the good agent and to be able to demote bad players. And the last one is agent selection. Because when you have a task to solve and a budget, the protocol is built in order to select the best team of agents for you to solve your task. So we have some optimization mechanism in order to, with a large team of possible agents to solve your task. We have algorithm, and with the measure of the contribution, we will be able to build the best team of agents. So that's really the agent selection. We are optimizing from a task and a budget, the agent selection to solve your task. But if we don't have trust to solidify all of that, all those agents could really not go in the good way. So we really want to have trust built in the protocol. So at the bottom, we have this agent layer where we have communication, security, and measurement. But on top of it, we are building two additional layers. So the first one is the proof of contribution. This is really where we want to measure how an agent contributes to solving a task. Because in order to make a reputation of an agent, in order to measure the contribution, the same way that within a team, not everyone are contributing the same way, we are measuring agents. So that will be the proof of contribution. And after, when we are building this collective of agents, how to optimize the fact that an agent is working well with another. Because if you are putting random agents all together, they might not go in the same direction, they might not generate output that are good input for the other one. So we want also to measure on chain the proof of collaboration. So at the end of the day, what is Theoric? So really we want to combine those three forces the AI intelligence coming from the agent itself, the collaboration layer in order to group all those agents all together, and the trust. So the solution that we are building is the following. At the very top, we will have the Infinity Studio. So this is a place where you will be able to send your task, and the Infinity Studio will build a collective of agents and resolve your task. We have the agent builder, because we also want to enhance the community to build agents. So that's something that the Infinity Studio will provide. Below that, the technical layer, we have the agent protocol that enable all the part that I mentioned before. And we also have the Infinity Hub, which is the second part visible part of our solution. This is really the marketplace where people will be able to build agent, promote the agent, will be able to see the agent reputation, or they are collaborating all together. And all of that in order to enable the builder of agent, the provider for the resources, because we will need GPUs, we will need a ton of resources in order to put that in place. So we want Theoric to be the place where all these community are coming all together and build together AI agent with trust. So that's it. Thank you all for your attention.
Yeah. Sorry, just. We there.
That's one.
Oh, you have your mic. Yes.
Okay. How do I go?
Next slide.
Next slide.
And to go back is the right.
Hello. I'm Nestor from AgentCoin, and today I want to present you with one of our latest creations, Indexer, which is an agent to find the signal in the noise. So at AgentCoin, we believe that as AI infrastructure and AI models become increasingly commoditized, the layer or the place that has the most potential for future innovation is the agent layer. And so for this reason, we are developing a network of specialized agents whose job is to interface and interact with the centralized protocols. So each one of these agents has its own decision-making process, its own structure, its own model, and Indexer is only one of the agents in this network. The objective of the network is to function as a socio-technical system to address fundamental challenges in the Web3 and the AI ecosystems. However, the Web3 and the AI spaces have a very broad range of problems. So in this particular scenario, we're going to zoom in on decentralized social networks as our problem space. As you may know, decentralized social networks, especially Firecaster, they have emerged as a very powerful and extremely interesting alternative to traditional corporate social media. But they have some of the few same challenges that traditional social media has. For one, the space is cluttered with spam, ads, self-promotion, scams, and just like plain irrelevant information. And there is so much of this that cutting through the fat in order to get to the gems is a tedious process that takes a lot of time and a lot of effort for users. In the words of Dan Romero, decentralized social networks are limited by the supply of interesting and entertaining content. And while this is true, this problem gets amplified by orders of magnitude if the supply of interesting content that does exist does not even make it to the end users because it's lost among so much noise. So for this purpose, enter Indexer. Indexer is an AI-powered curation engine that's currently public and free and that you can try right now. So if you go on this link, warpcast.com/indexer, or you open up your Warpcast application and search for the Indexer profile, you will be able to tag along with me as I explain to you what does Indexer do, how to use it, and how does it work. So Indexer has 3 functionalities. Its main feature, it's called Ask Indexer. So you can tag @Indexer on any Firecaster post with a question or query of your preference, and Indexer will search and evaluate across different data sources of information through a carefully crafted agent loop pipeline that we have created, and will prepare an answer for you. And not only that, it will include a list of references and citations of the exact pieces of information that it used in order to prepare that answer. So in here, you can see 2 simple examples that convey the point. In this one, the user says, what's happening in optimism this week? And in this one, the user says, who is talking about AI research lately? In both examples, you can see that Indexer first replies with a high-level answer that serves as a concrete answer to a concrete user question, and then it posts a frame that it builds on the fly that serves as a slideshow of citations and references of the pieces of information that it used in order to give the answer. Since it's a frame, you can interact with it, navigate it, and click on the casts, which will take you to the original posts of the authors. Interestingly, too, Indexer has knowledge of trends. So it's very common in social media that you will be exposed to trends that you don't know enough about. Or maybe you start reading about a few concepts and you feel out of the loop on that. Not a problem. You can ask Indexer about any of the trends on Firecaster, and it will be able to prepare a meaningful answer for you along with citations. More interestingly, Indexer has time and space awareness. What does that mean? Indexer understands the time and space constraints of both the question and the information in its sources. So maybe you just want to connect with people that are coming to this event, or maybe you want to connect with people that are going to ETHCC, or maybe you follow a project and you want to know if they're sponsoring any hackathons or any events in an event that you're going to IRL. In this case, the user says, I want to meet up with people in Brussels or ETHCC. More focus on AI topics in case you find anybody who's cool. At Indexer. An Indexer essentially prepared a slideshow that contains posts from different teams and people that were coming to ETHCC and Brussels that now this user will be able to know about and connect with. Also, it has thread context awareness. What does that mean? In all of the examples that I've shown you so far, they are top-level casts, which means that you simply open up your Firecaster client, you click on the cast, you type something, tag Indexer, post, that's it. However, if you tag Indexer within a thread, Indexer can understand and see the content of that thread and use the content of that thread as context for the answer that it's preparing. So in this example, a user tagged Indexer in a thread that contained alerts of a scam. And it said, at Indexer, can you surface this critical information? Asia is just waking up. And Indexer is smart enough to read the content of the thread, understand it, and then post the official Ethereum email updates at ethereum.org has been hacked. Avoid clicking any links from the list, mark as spam, and block the sender ASAP. So we hope that, for example, this main feature serves as a very strong mitigator of the problem that we saw at the beginning. The problem with you know, what was that problem that Dan Romero was mentioning? You know, I know I said the quote, but I can't exactly remember what it said. Maybe if I ask Indexer, it would know? So it's funny, because that quote that I showed you earlier from Dan Romero was actually sourced from a question to Indexer that I did just a few days ago, because I knew that I had read this quote from Dan, but I couldn't quite remember exactly what it was, so it was really hard to search, and I couldn't remember either if it was like a recent post or an old post, so I just asked Indexer, it surfaced it for me, And I was able to include it in the presentation. The second feature that it has are daily insights. This is very simple to understand. Indexer analyzes the top summaries, the top trends and top discussions from Farcaster, prepares a summary of the information from the last 24 hours, and posts that summary into your feed. So it follows the same structure as replies. So it has a top-level summary, and then a frame with a slideshow with everything that it features. So in this case, the front page is Jesse Pollock, because a few days ago, the Build-a-thon ended. So that was like a trendy discussion at the time. This is actually a recent daily insight. And then the final thing, which is one of the most interesting things about Indexer, it's a social curation aspect. The more Indexer is used, the more it learns. So simply by virtue of tagging Indexer within a thread, Indexer is able to see the content of the thread, and it will then index it as content that users are interested in a social data set that it can then consume to prepare answers for other users. And you can also tag Indexer in any post that you want Indexer to see, and it will index that information. So by virtue of simply using it, it will get awareness of more and more information. A final thing is that when you ask Indexer a question, it doesn't know everything. So if it can't find relevant information about the thing that you asked, it will perform fallback searches. If relevant results are found as part of those fallback searches, it will store those relevant results in its social data set too. So for example, if I ask a question to Indexer about something that it doesn't know, it finds it. The next user that asks about the same topic Indexer will now be able to answer to that user without any fallbacks, because it's now information that it has in its own memory. So this is all very interesting, but what if we open up the black box and see how does it work? There are two pieces to this. You have a data piece, and then you have an agent piece. Moving on with the agent piece first, we have two kinds of curation. Indexer has a list of tailored queries with popularity metrics embedded on top of them that make it fetch information across the whole Farcaster network and aggregate that information. It then runs spam filtering algorithms along with data aggregation algorithms. It then deduplicates the data, normalizes it, and creates embeddings for it. And then the social curation aspect of it is the one that I was telling you about earlier, about, Indexer takes content from just using it and content from relevant fallback search results. So this all is to prepare the data sources that then the agent will be able to consume in order to prepare the answers. So the actual agent, how does that look like? Looks like this. We carefully prepared this agent loop pipeline, incorporating various modern techniques in order to make the responses consistent and quality. We called it adaptive curation loop, and I'll walk you through it. It works like this. The agent extracts the user queries. It then performs different semantic searches across its data sources, its algorithmic and social data sources. It then uses a fine-tuned model for re-ranking results. So now you have a smaller data set to work with. It then handpicks the most relevant results to answer the user's question. Then it goes and uses a technique called self-reflection, or LLM in the loop. What that means is that it uses a completely separate LLM instance to evaluate the results that it handpicked to answer the user's question. That part is where it evaluates if the time constraints are respected, if the space constraints are respected, if what it handpicked is actually relevant to answer the user's question, and so on. After filtering the ones that do not pass this evaluation, it asks itself, are the choices enough to answer the question? If they are not enough, it will perform fallback searches, as I was telling you earlier, which are keyword-based, And if it will incorporate the results of that into the information that the agent needs to consider, and then it will repeat the loop until it finds relevant information. After a few times, if it can't still find relevant information, it will not make an answer from thin air. It will just give up and tell the user, I'm sorry, but I don't know this one. But if it does find enough relevant information, it will prepare an answer with the references, as you saw earlier. We then have a step of translating to the user's language. So if the user, for example, asked a question in Japanese, Indexer should respond in Japanese. And finally, if the fallback search results were relevant, we save them into the social data set. So everything that you just saw about Indexer and how does it work, it's only one piece, one agent of the broader agent coin network. It's only one of multiple verticals and multiple problem spaces that our network is looking to tackle. So we have a few different ones featured. We have social agents. This is the vertical where Indexer is located, but it's not the only one there. We built a specialized spin-off of Indexer tailored specifically for the base community, for example. So its decision-making process, its curation algorithms, everything is biased towards the base ecosystem. And we're now doing the same thing for optimism. And you can add more features on top. So for example, since these are domain areas that are well constrained, the based Indexer is able to quote the official base documentation, quote official base articles, and so on and so forth. We also have transaction agents. We have just built an agent called AutoTX in collaboration with Morpheus and Flock, and in partnership with Bioeconomy, whose job is to streamline and execute and plan for transactions, leveraging account abstraction. And with the help of Gnosis AI and OLAS, we built a prediction agent towards tackling challenges within the prediction market's problem space. So as you can see, we have a varied array of problem spaces and agents that work towards solving the fundamental challenges of Web3 and AI. And we have so much more. We have resource allocator agents, we have public goods funding agents, and so on and so forth. So I invite you to check out our website, to check out our code, which is open source, to join our Discord, and to try Indexer today. Thank you very much.
Thank you.
I don't know. There we go. Am I live?
I think this guy.
Can you hear me?
I think this guy is going to
Hello,
demic.
hello, hello. Hello, can you hear me? Yes. All right, am I good? All right. Hello, everyone. My name is Stephen Hilton. I'm with Space and Time. We are a AI verifiable, decentralized data warehouse. There's a lot to that. So I'm going to go through just a couple slides, and then I'm going to do a demo, because demos are always more fun. So, but just to give a real quick level set as to what Space and Time is. Space and Time, like I mentioned, decentralized data warehouse with a few key primitives here. We do index different blockchains into our data network, and you can do queries on those blockchains. You can bring your own data. We are a data warehouse. The intention is you bring in your off-chain data. We bring the on-chain data. You can join it together. Again, we'll do a demo of that here shortly. We are ZK proven. We have proof of SQL, which is a ZK snark that allows you to generate the query results along with a proof that you can take to a verifier, and you can verify that the query you submitted against the data in the database has not been tampered with. We have embedded AI, so traditional data warehouses, what you're doing is submitting SQL, SQL, right? Select star from blah, 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 blah. Well, you can still do that on space and time. However, you also have the option of saying, hey, show me, you know, the number of blocks in a particular chain, right? You can just do it through natural language. And that allows you to kind of merge the best parts of the efficiency, maturity of the Web2 data stack with a Web3 paradigm on-chain. So this is the architecture. I don't know how much I'm going to really go through this, except to say that everything's decentralized. We have a decentralized gateway here. We have the data cluster. This is a big data tool, and again, we'll see that here in just a second. So we're talking about, you know, hundreds of gigabytes to terabytes per query, and hundreds of terabytes on the network itself. Decentralized indexers. You can bring your own data. We have an Oracle in the gateway, as well as streaming, if you're familiar with Kafka, because that's very kind of a traditional part of the data stack. And then because we have those ZK snarks, you can send those results along with the ZK proof to be verified on-chain. So all of a sudden, you can take a smart contract and you can extend the capability of the smart contract into a big data system that allows you to do hundreds of terabytes of queries. Of course, you also have traditional APIs, so you can run dApps and apps with it, analytic dashboards, et cetera, et cetera. So that's, I think I'm going to stop the slides there, and can we go do whatever you need to do? I think it's as complicated as plugging in an HDMI cable, but you really want to do this, so I'll let you. There you go, sir. There we go. And then I have to hit allow, and then we should be in business. There we go. All right. Like I said, demos are always more fun if you can see it. And I'll mention while we get this sorted, there we go. We've recently open sourced our proof of SQL cryptography, so you can go out to GitHub and search for space and time, all one word, actually space and time labs, and you can search for proof of SQL. You can also search for our GPU accelerator, which is what we use to get sub-second proof time, and I'll show you that as well. So this is the user interface here. And I'm already logged in here. You can log in with traditional methods. I'm logged in with my wallet. I'm just going to go in and run some queries. Let me see if I can make that a wee bit bigger. There we go. And the first thing you might notice is that we give you a lot of context when you run the query. The second thing is that came back in about 3.5 seconds. And what I just did was a select star from Ethereum native wallet. So I'm getting all of the wallets on Ethereum with a balance greater than 100. And so if you see right here, this is the table that I'm querying. It's about 180 gigabytes in about 3.5 seconds. So it is a big data system. It's intended for large-scale queries. But of course, you know, that's interesting. That's table stakes, so. Let's do something similar, but using natural language. Show me the count of Ethereum wallets with a balance greater than 1 billion. Oh, and it's already written the SQL for me. But fortunately, we leave the prompt on top here commented out. With a balance greater than 1 billion for last week, and you can see it's able to run that. That took about 5.5 seconds, but there's the answer, and we're against the same table here. Let's do that one more time. Whoops. But let's do including balance yeah, that's fine. Actually, let's say including balance and by date. We'll just modify it here a little bit. And so there, it's, yep, so it's got the balance, it's got the date. So, and by the way, even if you're a SQL guru, it's kind of nice to be able to go through and just get a starting point. The reason I wanted it by date is so I can show you the other part of a little AI engine that we have that just takes these results and does graphs for it. So it'll look at the structure of the data, and see what would make the best graph here. And as you see the wallet count, the total balance. Of course, this is like a UI element, so if I don't like the way it's structured, I can go turn this into, I don't know, column, and you can look at it that way. But, you know, the intention here is to just quickly go from the idea, right, which is I don't really know SQL that well, but I know how to express what I'm looking for in terms of data sets. And with that, I'll actually jump over and we look at the data set just very briefly. I'm not going to go through this, but this is, actually I'm going to back up just one step. These are the different chains that we've indexed. We indexed from block 0 to about 10 seconds ago, about 10 seconds after block finality. We index it into relational structure. This is a relational data warehouse, right? There's some primitives, so you see blocks have transactions, transactions have event logs. This event log would be every single event that's ever fired on Ethereum ever. And you can see it's about 625 gigabytes in size, so it's more than half a terabyte. This one table, I know if we go look at Polygon, this would be over 3 terabytes, this one table. So you start piling these things all together, and this is where you get, you know, big, big data. Of course, you can do cross-query joins as well, so we could go look at Polygon compared to Aptos, what's the TPS, right? And so you can see Polygon's about 54, Aptos about 51, about the same. But we try to keep the data models very similar to each other. And so I can come down here and say, instead of Aptos, let's look at Ethereum. And we'll drop Ethereum in here. And we'll run this again. We'll see that everything runs, right? Because the intention is that these things are supposed to be very interoperable. So once you learn what the data model is, it becomes very easy to start, you know, adding things on. So Ethereum's down here at a little 11 and a half. Of course, we index this blockchain data kind of just as table stakes for the network. There's no additional cost to it, right? You can just get in and start using it. But again, we're not doing anything that's different than what our customers can do with their own data, right? And so by way of example, I have another table here, which I have in my demo space just called stocks. I went and loaded some stock data here, right? And because I structured this to look the same as the TPS above, you can see that now we have Polygon, Aptos, Ethereum, but then we also have Amazon and Tesla and Microsoft. And it doesn't make a ton of sense, like, you know, what's the TPS of the New York Stock Exchange? But the intention here is just to show that you can do things like query 3 different chains and your off-chain data all in the same shot, and in 8 seconds, you know, bring back a meaningful result, right? And you can do this with tamper-proofing. So again, we have this proof of SQL, so we can return not just the data, the result here, but we can also return a ZK snark that allows you to tamper-proof that, right? And that's just as simple as turning it on. My stock table, you do have to have a tamper-proof table here. Whoops. So I can run it, but let me try and enable proof of SQL. And what you'll notice is in 0.9 seconds, we were able to run the query as well as return and verify the results. Now I'm using I'm using a space-of-time verifier network to do this. So the prover is the database. The database actually generates that sub-second proof. And we're able to do that sub-second proof because, again, we have this all GPU accelerated, but we also have, you know, we're not trying to do arbitrary compute. SQL has a finite function set. And so that's where we really hyper-optimize to get this down to, I think we can do sub-second queries up to about 1 million rows returned. And then, but it's not a linear scale, so you can go up to like 10 million and you're at like, I think you're at like 2 seconds. If you get up to 1 billion rows, we've tested up to 1 billion rows, and I think we're at less than a minute, right? So it's not a, you know, if you double the number of rows, you're not doubling the proof time. In addition, you can take this off, take your proof off to verifier networks. We have our own verifier network, but it's convenient, but of course you probably want to take it to an external or third-party verifier. You can go get your own verifier. You can go to Chainlink. You can go to Horizon. You can go to other partners that we're building right now. And I think the last thing I'll end with here is that we also have dashboarding. and I'll just go to the public dashboards. These are dashboards that other people have made in the industry. This one looks good. Let's look at the Aptos one here. So these, like once you go through and you run the queries, you've used the AI engine. And by the way, you can use any LLM you want. We're Microsoft's one of our big funders, and so we use OpenAI, but you can use anything you want. This is something that, again, I didn't put together. This comes from our community. They put together this fantastic Aptos dashboard. And I'm not going to go through it, but I'll just kind of show you what's possible. And they did all of this great markdown here. And they have a bunch of NFT projects that they're interested in, right? Let me find one more here. And by the way, the color of this, if you upload an image, it will match the color, which is why everything's kind of black and white, but it doesn't have to be. If I go here, let's do the sushi swap. This one might be fun. This one's also kind of black and white, but it's got a little color to it, you can see. Let's find a more colorful one. And you can go, let's go back to public dashboards. We'll see what this cat one's about. The intention here is not really to be a BI tool as much as it is to provide some lightweight visualization. It's a great way for us to engage our community because we can do things like programs, contests. Hey, working with Aptos, working with ZK Sync, these others, come have community build out the best dashboards that they can. And because it's all AI powered, right? Our community doesn't have to know SQL. They can just get in and start asking the questions. As long as they understand the idea of Web3, they can express that in whatever language. It doesn't have to be English. English is my preference, but it doesn't have to be, right? Then the AI engine inside of Space and Time can actually produce the queries for them and then even produce the graphics for them. The next step after this, by the way, is to have AI be able to build the entire dashboard for you. So instead of saying, hey, here's my query, take the query, make a chart, take the chart, build a dashboard, you can just say, give me a dashboard showing me all the liquidity on ZK Sync. And it can go through and do that. So I think that's probably about time. Oh, I was going to say, if you have any questions, feel free to reach out to me. You can hit me on Telegram or on email. Otherwise, you can go out to spaceandtime.io. And I'll be at the ZK booth most of the week, so come visit me. Thank you very much.
Cool, thanks. Cool. Good to go. Good to go. Hello. We good? Cool. Hey guys, I'm Evan. I'm here from Gnosis, and I'm talking about building the autonomous AI agent economy on Gnosis chain. So let's go. Formatting. Okay, so what we're building at Gnosis AI, so we're a new outfit. We've been started with the remit of building proof of case use cases for the AI agent economy on Gnosis chain. So what do we mean by that? So we have agents acting autonomously on chain, and they're competing for finite resources, and we call the kind of emergent phenomenon that you get out of this the agent economy. And the reason why we're doing this is because Gnosis Chain cares about having active users and a vibrant ecosystem. So if we do this, we will onboard more users onto Gnosis Chain, where users, in this case, are AI agents. So where does this sit in the AI Web3 intersection. So from what I see, there are kind of two broad, you can divide this into two broad categories. One is where you augment the kind of Web2 AI stack with Web3 technologies. So we've seen things like zkML, decentralized compute projects. And then on the other side of things, you have where you add AI to Web3 applications. So that can be helping users kind of interact with the blockchain via natural language, or having AI as a player in the game itself. And this area that we're particularly interested in. Okay, so right, we want to build some AI agent systems. What applications are we going to pick? What kind of, how are we going to narrow down this search space? So the top level goal, the agent needs to be able to autonomously make money for itself. Where's it going to do this? There are kind of two additional kind of constraints that we think narrow this search down for us. The first one being where general intelligence beats out kind of the ruthless scripting approach. And the second one is where incentives are too small for humans. This second one at least applies for the time being, while kind of machine intelligence is below that of humans, but this constraint might be lifted not too distant future. Okay, so with those things in mind, the application that we've chosen to focus on in the first instance is prediction markets. So prediction markets, what are they? They're platforms where users can buy and sell outcome tokens in future events. So a market creator puts up some liquidity for some question that they want answered, and then the kind of market incentives around this kind of create this truth-seeking behavior. And this is great for our agents because if they do a good job of forecasting, they make good predictions about these future events, then they can profit from this. And up here on the right is an example. AI Omen is a prediction market that's currently running today on Gnosis chain. Some other things that we think are a great fit for AI agents and prediction markets. So what do you need to do to be a good kind of user of prediction market applications? Well, you need to have a wide knowledge base so that you can kind of answer markets on a broad range of topics, and also kind of a deep knowledge base so that you can, do more than just like token, like basic answer. You can have like high quality predictions. And LLMs are kind of good at both of these. Kind of state-of-the-art LLMs can do these things really well. And then this third thing that we just mentioned, a lot of the time in prediction markets, the market creator will only provide a small amount of liquidity. This might not attract kind of human interest, sufficient human interest, but AI agents don't have this same kind of constraint. Okay, great. So we've picked our use case. A little primer on AI agents. What do we mean by this? Kind of a couple years ago, you think of an agent as some kind of parameterized model that has some model of some environment. It takes an action, gets some reward, like AlphaGo kind of thing. These days, when we say agent, we don't necessarily mean this kind of model. We've got some LLM-based agent, perhaps built with these kind of Python agent-based frameworks, with some which kind of have an LLM plus some things, extra features bolted on top of it. And what are these kind of extra things that are fundamental to agents? These extra features bolted on top of them. So the LLM is at the core that provides the planning and reasoning capability. And then the kind of main extra feature is tools that allow the agent to interact with the real world. So in the prediction market case, the agents are kind of doing some kind of web search and scrape to do some research about this future event that they're predicting. And then they have these kind of on-chain library functions that allow them to actually kind of participate in the prediction markets themselves. Additional features. So memory is an important one to kind of for performance reasons, to allow the agent to kind of move stuff in and out of context window. And also that overcomes the kind of context length limitation which current LLMs have. And also to allow it to kind of act over a long period of time, so it can kind of pick up where it left off from a previous session of execution. And lastly, control logic to kind of allow the agent to go from a high-level goal, make money on chain, or participate in prediction markets to and manage progress towards this goal. So just a quick primer, kind of to demonstrate what we're talking about here. So here's a 2-line Python example of evoking an LLM. Here's a prompt: will it rain in Berlin tomorrow? If you do this, it'll say I don't have real-time data access, so not very agentic. It can't give you a good answer. Now let's just make another minimal example with a bit more of an agentic nature to it. So here we see these kind of features that we just mentioned on the previous slide, initializing a LangChain agent with a search tool that allows it to search the web, and specifying some control logic saying, do a back and forth conversation, but the LLM controls both sides of the conversation. So now with this query, will it rain in Berlin tomorrow? You do some webs, the LLM kind of sees it doesn't have that knowledge to hand, does some web search, and comes back with an answer saying, there's a significant chance of rain in Berlin tomorrow. So this is a more agentic kind of system, what we were referring to here. Sucks to be them in Berlin. Okay, the formatting's a bit screwed on this slide, but the title is Scaling Autonomy. What do we mean by that? So this is an engineering consideration when we're building agent systems, is where on the spectrum of hard-coded scripting to complete autonomy, where do we kind of, what do we program into the agent? So how much autonomy do we give it? To kind of illustrate this, you've got these code snippets on the right-hand side. So these are the kind of set of functions you need to be able to participate in prediction markets. And on the top example, you've got the kind of like a scripted approach where the order of execution of the program is fixed. So you might have kind of calls to LLMs within each of these functions, but the execution structure is completely fixed. Then contrast that with the snippet below, where you give the agent the tools that it needs to participate in prediction markets, and you give it a high-level goal. And the order of execution now is completely handed over to the agent. So there's a kind of trade-off here, because we want the agent to have more autonomy, because this has upsides. It means that the agent's more flexible, it can add new capabilities more easily, and it has the capacity to learn over time. But on the downside to this, with the current kind of level of reliability of LLMs these days, for these long horizon tasks, it can quickly go, if you kind of build agent applications, you often find they'll go off the rails quite quickly and just produce garbage results. So this is a kind of engineering consideration that we're making, where we have to kind of pick where we want to be on this spectrum and give it as much agency as possible, but add mitigations in place to prevent this going off the rails behavior. Okay, cool. So we've picked our problem space, we've given these set of features to our agent. Now we want to deploy it in the real world. How do we know that it's doing a good job? With kind of agent applications, there's less of a kind of it works, it doesn't work case, and there's more of like a kind of willingness to have these like vibes-based intuitions of it's kind of working, it's kind of not working. But in the prediction market case, at least, there are some hard metrics that we can use to evaluate our agent. For the kind of deployed agent that's out in the wild, we can say, how accurate are your predictions relative to the actual answer, the actual outcome of the markets? This is a bit of a pain to benchmark your model on, because it has to be done a posteriori. You can't kind of benchmark your model on this, using this before deploying it, because that just slows down iteration. So a kind of proxy that we use is to compare the accuracy of the predictions relative to the crowd prediction of existing prediction markets like Manifold or Polymarket. Sorry, typo. So that's for the specific to prediction markets, but there are also considerations more generally. So for observing agents in the wild, one really useful thing that we've found is to use LLM ops dashboarding for for debugging, because you can get nice execution traces of your agents over time. kind of intel on tool use and kind of eyeball the responses to particular prompts and so on. This higher level goal of making money autonomously for the agent, this can be something that we can kind of benchmark. So the agent has costs associated with it, inference costs, and then additional API services. And we can kind of measure its return on investment from its participation in prediction markets. And then lastly, the thing I want to mention is evidence of learning over time. So this is something we're kind of actively working on at the moment, and hope to kind of present to you guys in the near future. So this is things like optimizing the behavior via in-context learning and kind of allowing the agent to have kind of adaptive tool use over time. Okay, great. Those are the features that I wanted to talk about and our work that we want to talk about. So just lastly, if you're interested in kind of learning more about us, you can find us on this Linktree link here via that QR code. And there you'll find things like Streamlit demo apps, our GitHub repos for open source code, and Dune dashboards for the deployed agents and some stats about them. Okay, that's everything from me. Thank you for your attention. Cheers. Who's coming? I think it's lunch, but I don't want to announce it. I guess I'll leave it to Flock to announce. Cool.
Hello. Hello, everyone. Hi, I am Andrea, co-founder of Wisdom. So I don't really have a lot of fancy slides at the moment, but I do have a lot of pictures. And I'm going to tell a story, and hopefully the pictures are going to be enough to convey what I'm trying to actually say. So I'm the technical co-founder of Wisdom, but I've not been technical my entire life. My background is in the world of finance, where I graduated from a couple of different degrees. I worked in London for a while in banking, and I always was curious about the world of, programming, but I always felt very intimidated and afraid. And because what most people see when they search up the term coding or programming is things like this. And who would not be intimidated by something like this? So let's take a look at how written content is usually consumed by average people. This is a form of written content that is usually consumed by programmers, by technical people. But more average users are used to a Microsoft Word type of experience. So something very easy, very clean, very simple, with beautiful text. And this is where I came from. So if you're used to something like this, switching to a dark mode filled with symbols and complicated things is very, very hard to actually get into, right? Intimidating. So, of course, for more technical content, there are articles and blogs that do mix text with images or snippets of code, right? But in order to fully help people to reach a better understanding of programming, what needs to actually be done is to be able to execute the code on the same level as the text is displayed. So this is an AI audience, so probably you guys know what I am alluding to, and I'm alluding to the concept of a notebook. So a notebook is a fantastic tool to basically be able to both visualize texts and code and actually be able to execute the code line by line in a sequential way. So coming back to the example of not understanding anything coding and programming related, and this is because the interface that is usually presented to many, many people is this complicated interface right here. And I now am a technical co-founder, especially because of my approach to notebooks. I come from a financial background, so what I mainly did was use notebooks as if they were Microsoft Word documents to basically build out workflows of financial data analysis coupled with programming. And in the AI space, these notebooks are widely used to explore different data sets, to look at different types of ML models, and to basically interactively explain very complex topics in the machine learning and AI fields. Now, we're probably all in the Web3 and blockchain space here, and the blockchain space is extremely complex as well. And upon transitioning from the world of finance to the world of blockchain, I found it extremely complicated and daunting to understand all the different smart contracts, all the different DeFi, workflows and contracts, because there is no such tool like a notebook that easily allows you to interactively run the code line by line and to be able to have unaccompanied text with it. And this is what we're building at Wisdom. We're building the world's first computational notebook platform for Web3. So what this means is we give users the ability to write, instead of having to write Python in notebooks, you have the ability to write Solidity for smart contract execution and deployments. And we've done it in a very innovative way to basically be able to abstract the object-orientedness from the contracts themselves and to be able to run directly each and every statement and its output and actually see the output in real time, giving it a lot more interactivity and actually being able to hopefully onboard the next million developers onto Web3. Currently, we have 23,000 developers in Web3 only, as opposed to 27 million developers in Web2. And most of this, in our opinion, is due to the fact that onboarding is extremely hard because smart contract development is not just about learning another language. It's about learning an entirely new type of system, philosophy, and understanding all the bits and pieces of how the blockchain work and how money is actually created, essentially. So let's take a look at an average smart contract development experience, how it is done at the moment using Remix. So what is usually done is if you are a novice, if you're an amateur, if it's the first time that you're approaching smart contract development, you would go on a blog, on an article, and copy the entirety of a smart contract code. And then you would plop it into a tool like Remix. And then you would have to compile the entire code, deploy the entire contract, and what you're left with is a bunch of different buttons that no one is able to understand what to actually click on and what they actually do. Because Remix does not give you, and this is not a shot at Remix, this is just to give you guys an idea of like what the average experience is for introductory smart contract developer in the Web3 space. So you're left with all these buttons and you don't know which one to click. And this has been my experience getting into the Web3 space a couple of years ago. So what do we do that is different? Again, we're building a notebook for Web3. So this is an example of a ballot contract, and this is the exact same ballot contract that you'll find on any Intro to Solidity course. And as you can see, you don't have to write the entirety of the contract within the file, but you can easily chop it up into different sections and have text explanations, and you can easily output every single variable that you're actually declaring in real time. And this will speed up the learning process, the prototyping process, and the auditing process of smart contracts greatly. On top of this, we also offer the ability to generate code via AI, and that's also why we're here. So to be able to use generative AI to generate code for you on the fly for Solidity, to be able to convert code from one language to another. And this is all powered by our good friends at Flock AI that train custom models for us to specific esoteric programming languages that are used in Web3. I kept everything very, very short, and I hope you all enjoyed the talk, and thank you for your time. Okay.
All right, thank you all. So we're gonna have about 30 minutes break for lunch. So everything's there. We have sandwiches and famous Brussels sweets. So feel free to take some, and then we'll be back 1 p.m. Thank you. stressful? Yeah, sir. Hey, hello, hello. So we are soon to start our afternoon session. If you finish food or drinks, feel free to take a sit. Yeah, I'm gonna give my session back also for vlog. So have a seat, guys. So we can start our afternoon session now. Yeah, or if you are standing in the back, feel free to volume down a bit, so it's easier for people to hear about the pitch in the front. So, yeah, humming, it's all right, it's all right. Right. So I'm gonna talk about I'm gonna use this as our opening for our afternoon, basically to talk about flock and what is flock, right? So actually, when many people curious about what is flock, they think about, oh, it's a flock of data, flock of entities, right? Yes, similarly the idea, but also it's a technical term that stands for federated learning blockchain, flock. So that's what flock is actually. So this is one of the papers that we published. We actually have a bunch of other papers published before, and this is one of them that we eventually published on a journal, which take about 2 years to do it. But yeah, eventually, co-working with all our researchers from Oxford, Imperial, CMU, and lots of their research areas. So what we are talking about and what we are focusing on is about this federated learning part, where federated learning is actually something that everyone's using it right now. If you check out your phone, that your typing habits is actually using federated learning. So Google is using it to predicting your typing habits. Apple is using it, but the only thing is it's controlled kind of by Google itself, right? So you can say there might be some backdoor, you don't know. So that's why what we are trying to do is to mimic this central control, so that we don't need to have this server in the middle to do the aggregation. So the middle server, what it means? It means that you have a server in the middle that actually aggregate all the users' change of the weights to a central server, and then to aggregate the model. Why? Because in that way, you don't have to send your data out. So actually, everyone can have their own data on their phones, on their computers. They don't have to send them over to any third party. The only thing that's sending is the change of the machine learning model. That machine learning model will then be aggregated by a central node. So that's traditional federated learning. So what makes us different is we're trying to mimic that thing in the middle. Because if you're trying to do it in a decentralized way, you want to make sure there's no central control for everyone, right? So this is what Flock is proposing, that we call it federated learning blockchain. So using blockchain to do the on-chain consensus, so you don't need to worry about that your data is actually leaked out to a third party, and you don't need to worry about that any central node in the middle is actually having a backdoor or picking your data. So that's how it works. So every time when we have an update about the gradients, we will have it send it out in a ring structure to the next one. You don't need to worry about what it is, because eventually everyone will get it if it's a ring or reduced structure, right? And for the updated model, we will do a vote randomly by the voters in the same group, in the same ecosystem. So every time they will check out the machine learning model against the loss function. So if the loss function is going well to a good direction, then we vote up. If it's not, we vote down. That's basically the idea behind. So we have this randomization every epoch to make sure that this process, everyone in the training is genuine enough. And if there's some poison attacks or some hackers in the middle, they will be slashed out. So that's thankfully to the blockchain mechanism especially for staking and slashing mechanism. So we don't have to rely on any central power to do the training. We can rely actually on the blockchain to do the governance. So that's how basically it works. So if there's if there's no hackers in the middle, so when we have the participations, we select them, and then doing local training, nothing is sent out to any third party, and then we do global voting and approval, and that's approved, push to a next block, and then, yeah, that's next. But if there is, the red one is malicious clients, if they are selected to as proposers, then whenever they have their propose to the global model, then we will see that there's a decrease of the loss function, and those ones will be slashed, and then the model will revert to the previous state. So they don't need to worry, okay, that we are getting some poison into our model. Yeah, so this is a pseudocode for the whole process. It sounds intuitive, right? But you need a lot of mathematical proofs and experiments to make sure it works. So that's why we did a lot of those experiments. This is like a 3 years ago paper, so we are still using traditional fade average and traditional algorithms for doing regression. Yeah, so we did try some different parameters. For example, the ratio of malicious clients, 10% of them, 20%, 30%, 40%, to test out how much that we can defend. Actually, for 40%, we can do pretty well. So there's several of the results. We can go straight to the final result. So basically, that's how we get the final result. So this is the oracle result. Basically means that if everything is trained centrally on a single node, it should act like this, right? 97% accuracy. And the row above is when we have federal learning without malicious clients, which means that everyone is so honest that we are having a decentralized training. Yes, you can do that. And then, of course, your accuracy is still high. But the thing happens when it comes to an open system, you will always expect there's going to be some malicious clients, right? So these malicious clients, for example, this one, it will, when the number of malicious clients going up, their accuracy will go all the way down to 70%, which in industry doesn't work. It means the model doesn't work at all. In comparison, that's ours. So ours with federal learning with block, or we can call it flock, we can still maintain the 95.5% of accuracy without needing to worry that, oh, there's already 40% of the malicious guys joining the training already, but we can still maintain a very high standard of the accuracy. So that's basically what Flock is presenting, and that's basically the result of this whole paper. So we have tons of, we have many of other papers as well relating to this, not only just Flock itself, because we are so interested and happy to see lots of different privacy-preserving technologies in the world, right? FHE, ZK, TE, they're all good. So we even have a paper called the ZKFL. If you're interested, Zhipeng is there, who's our researcher. So he can talk you through how ZK can work with the Flock system, can even more enhance the security of the training system. And maybe in the future there will be a FHE Flock or some TE Flock. So that's why I'm talking with Arbian. Oh, where is he? He left maybe. So about this, all these interesting things together. So what we are, so that's the paper itself, right? So what we're building in product is actually this decentralized AI training in practice. That we are actually launching out the whole platform already. Now you can use it. Everyone can just join the training, can experience how this on-chain governance works. The whole data flywheel is like this, 3 parts. So we have AI Arena, which is basically our battlefield for people to join training and then to compete with each other. Whoever got the highest score will win and win out a lot of incentives, of course. That's another beauty of blockchain, right? So, and we have FL Alliance, where the best model will be pumped to. So this Federal Learning Alliance will help you wrap it up into a dApp or app, which we work with many of our clients already, so they have the app. So that model can run on the app, and we can ensure that all the client's data stays local with this app or whatever client side of the applications they are using. So basically, that's how Flock works. The three parts of us: AI Arena for the competition, FL Alliance for deployment, and then the applications for applications. Yeah, this is the whole structure, how it works. Currently in our platform, there are people joining as task creators, like our collaborators, like Foundry, TensorPlex. They all map their own tasks, and then training nodes who train the specific tasks, and validators who actually join as a validation nodes. So they just continuously run on those validation results to make sure the whole network runs honestly. And then eventually end users. So whoever is using the app, either it's an AI companion or a transaction bot, whoever is using it, that's our end user. That's how the layer works. So they can work either on your proprietary data or on the user data. So basically, you can choose between either working on some open domain data to train on a best model on open domain first, then pump it to your own users' application so that it can continuously run better on their user data. Yeah, so the growth so far, we have more than that nowadays. So yeah, we got early support from Foundry, who's here as well, Akash, who we talked about earlier in the morning, TensorPlex, Gnosis as well. Hey, thank you. And many more. And also the engineers from Hugging Face community, Numerai community, which we're actually having a Numerai meetup later in Tokyo this month, and then several other ones in Spain, in New York, in London. So yeah, if you guys are interested, feel free to join the Numerai meetups, which we're gonna co-host together. Cargo and researchers from Oxford, of course, all our friends. Yeah, and some of our applications in both Web2 and Web3. Web2 ones are interesting and maybe more intuitive to everyone. Like with healthcare, with hospitals, we are doing a collaboration to do glucose monitoring with 8 different hospitals in 8 different countries. So that's a cool thing. And we're going to demonstrate this in one of the academic conferences later this year. And then for credit scoring, that's for Web2 cases. So Web3 cases maybe is even closer to everyone since the audience here, right? AI companions, we know a lot of AI companions, right? With our like Farcaster bots or Character X bots, and you have a lot of bots there which is actually trained, and with Wisdom as well. Oh, are they still here? So they just mentioned, right, their code generation bot that's with Flock as well, and also the DP integration, Akash, Hyperbolic IO, and then transaction bots with Morpheus, Olus. These are all our collaborators, which are actually generating real use cases and revenue for this whole decentralized AI space. Yeah, so just want to quickly showcase how it works in the decentralized AI and the deeping side. For example, with Akash, nowadays that you can easily, on Akash, you can just look at search for Flock templates. So there are 2 templates already in Akash. Easily, you can just using Akash to load up an instance on demand, and then it can just run directly a Flock validator or Flock training node. Well, depending on the computer power you can get from there. So there's going to be a live demo, but yeah, not sure if the audio works well here. Yeah, so basically how it works is we have all the code bases here, and then all you need to do is in the awesome Akash, their community earned repo, you can search Flock, and then you will see where it is. Can we have this audio out? Can we have this? Yeah, can we have this audio out? Okay, no, okay, that's fine. Right, so it's fine. Don't worry. So we have computer there. If you want to see this live demo, feel free to just drop to our stand. We can show you how it works. It's a bit slow, but it actually works like this. So on Flock side, you just pick one of the tasks, as I mentioned, one of the tasks that you want to participate in, join together. Now, it was like 3 tasks before, but now we have about 7, 8 tasks already, and it's increasingly. And pick one of the tasks, and then choose how much you want to stake to join the training, because you need to stake in case you play evil, right? There's a stake and a slashing mechanism here. Yeah. And all you need to do is to get this YML file and then put down your own API key and your task ID. And then where's your API key? Basically, it's here on your own wallet account, and then you'll see your API key that you can copy. And then when you go back to a cache network, you just yeah, it goes slower than I do, but that's how it means. Yeah. So you search flock, you'll find the flock validation. Well, now the training template is here as well. You click on the validator, and then you just deploy, and then just copy paste your API key and the task ID here, and that's it. Then it will just straight run the task for you. Well, you need to connect your wallet, and you have some AKT in your wallet. Sorry, that's another thing about blockchain, that you always need to have some gas. Yeah, that we have enough AKT for this, and then approve. Yeah, then you just pick one of these instances that you want, and then it will just spin up instantly. So that's how easy it goes. And then, well, of course, we are working with different deeping providers that make this experience super, super easy for everyone, so that you don't have to have an instance at home. You don't have to have a graphic cards at home. You can just easily spin up from everywhere just to start up your flock validation set or your flock training node. Right, so that's how it runs. It's basically run already. So yeah, so that's how the whole product and also the collaboration with Akash works. If you want to know more about it, feel free to just scan the QR code and then join the training. We have some models out already on our beta site. So beta.flock.io is where we showcase all the models that's already built on us. And then yeah, that's pretty much for us. Thank you. Okay, you wanna, yeah. Okay, so now for the afternoon session, let's welcome Tommy and your crew for the great panel about hypes, real and hypes in decentralized AI. I think everyone will like this topic. It's great. Oh, it's here. Yes, I'll leave it to you. And also welcome our friends, David from After Party, Sylvie from Flock, of course, Kalentia from Masa, and Harry.
Cool. Is this working? Awesome. Thanks, Jihao. Appreciate you having us on here. Yeah, like Jihao said, what's real, what's hype? There's obviously, to nobody's surprise, a lot of vaporware in our space. And I think it's really important as an industry that we talk about these things, check projects, and figure out what's real, what's adding real utility, real value to ecosystems. So super excited to have this panel up here today. Start by letting you guys all just introduce yourselves, talk about what you're working on.
Sure. Hi, I'm David. I'm a co-founder at After Party AI. We've been building at the intersection of crypto and AI, focused on creators. At After Party, our mission is really to enable anyone to have an AI that reflects their personality, is authentic and accurate to who they are and to their business. So creators has really been our initial launching pad. We've had hundreds of thousands of users paying to interact with AIs already. And one of the biggest challenges we face with conversational AI is really focused on structured data. So we launched a subnet on BitTensor about a month and a half ago to enable a decentralized scale AI. Scale AI is powering, hundreds of thousands of humans doing a lot of the structured data work for the largest companies in the world. We're now using BitTensor to do that with validation of miner activity and allowing miners to do that with LLMs.
Hey everyone, check. Is it on?
Is yours on?
Hey everyone,
So.
my name is Clancy. I'm co-founder of Masa. At Masa, we're building a decentralized AI network where people earn by contributing data. We've been building towards this vision of open permissionless data network in the past 2.5, 3 years. And if we're to focus any problem or any vertical in the decentralized AI space, we decided to focus on data because we believe that's the most long-term valuable vertical in the data space. Assuming every single one of you who's training an AI model or AI agent would require data. But currently, the most efficient way for you to get data is really to get access through the likes of Twitter Developer API, or even for other data sources, you cannot even have an API to call. With Masa, we actually build a decentralized network of node workers and validators, whereby you can get data wherever and whenever you want. Excited to share more today. Thank you.
Hi everyone, I'm Sylvie. I work on product at Block.io. And our focus is really on allowing different community members and protocols to create and fine-tune their own models without just relying on OpenAI or without handing over data to like the big corporations. So we have 3 core products. So the first one is called Federated Learning Alliance that achieves machine learning while data stay decentralized and all training nodes are incentivized based on their contributions. We also have one called the AI Arena that is used to refine the base models that goes into the federated learning process. That one we just showcased. The number it shows has 6K submissions, but currently we have 45K model submissions from like around 150 developers. And the third one is currently called beta.flow.io. So all models trained for assistants, companions, or Web3 agents are showcased there. Thanks.
I'm Harry. I'm one of the co-founders of Jensen. We're a machine learning compute protocol. Our thesis is that in the near future, artificial neurons will be as important as biological ones. And in order to kind of build a world where machine intelligence can grow, we need to verify compute which is performed across devices and do so at high scale. That enables machine learning engineers to train very large models across decentralized and distributed hardware, which forms a world computer. Our protocol specifically allows you to take a neural network graph, split it up, and train it across lots of untrusted devices, then recombine it in a way which is low cost and high scale.
Awesome. Thanks, guys. So kind of covering the full stack between the 4 of you, right, in AI from data, training, inference. I'll start with you, David and Calanthea. I see a ton of value in incentivizing users to provide data, quality data, but I think it adds kind of the question of verification. How do we ensure now that there's crypto rewards that the data that people are providing is of quality? So how are you guys tackling kind of building robust systems that verify data quality?
Yeah, and I sort of think of us, and we're actually working together on some stuff, but we're really focused on the structured data side of it. So part of what we've really enabled with the subnet is any validator can put any conversational data that they think is valuable or a customer of theirs thinks is valuable and receive structured data that has metadata, that has all this additional value to it that's really useful for fine-tuning. It's really useful for getting retrieval systems for RAG solutions. So we've been focused on the structuring of the data. So for our models, and we're actually going to launch the first model fully kind of fine-tuned and kind of the RAG solution based on the structured data from our subnet. We're doing that with Jake, the founder of BitTensor, and with all the BitTensor kind of docs and information. So that's about putting data through the system that we think is valuable, structuring it, providing metadata, and kind of ensuring that is of high quality. It is, it's really up to the validators or customers of those validators to make those decisions.
Yeah, from my perspective, I'll probably give you two answers, Tommy. The first one is that in the data universe, it's a wild, wild open ocean, right? It's a matter of what kind of data is most valuable for AI developers from model training and AI agent training perspective. From our discovery and conversation with developers, we realized that structured data, especially a lot of text-based structured data from the likes of Twitter, Discord, Telegram, and diarized data from the likes of audio and video content has been the most valuable, and it's really low-hanging fruit. So in the near term, we decided to really focus on those kind of structured data. But then I'll give you another answer, which is, in order to incentivize high-value data, you need to design an incentive mechanism that does exactly that. So what we do at Masa is that we have really used a game theory-based framework in order to determine the utility of the data that is decided by things such as your data uptime, but also how your data is consumed by developers, whether developers believe your data is valuable. So using a game theoretic framework, we're able to better incentivize high utility data in the network.
Awesome, yeah, makes sense. Moving kind of down the stack to the training side, Sylvie and Harry, bringing in the kind of decentralized node, right, adds questions about quality of the provider. Is the node that I'm paying to use actually doing the training? Is it properly carrying out the tasks? How do you guys integrate verification in a way that ensures that the end user product is not harmed?
Yeah, sure. Especially with training, performance and accuracy are key. So the way we do it is embed cryptonomic incentives right into the training design. So in the FL Alliance design, after each round of training, the global model will be evaluated by a group of validators, and those who participated in the training and had good results will get rewards, otherwise they'll get slashed. And after a few rounds, the ones that consistently put out bad results will be filtered out. So they'll no longer be part of the training pool. And we have done lots of simulations so that the expected return for someone who is only putting empty or bad results will be filtered out. Their expected return will be less than 0. For AI Arena, it's a similar idea, but the validation will be done by users as well. So it's not just the validators giving them a score. Since we have the model platform showcased on beta.flock.io, the final rewards for model creators will also depend on how many users they are getting and what is the feedback from those users.
Yeah, to build on that, I think we want to enable arbitrary models to be trained on Jensen in a verifiable way, so we don't want to limit it to certain model architectures. And that puts us in a kind of tetralemma where there's a kind of four-dimensional trade-off. The first one is if you add in verification, you're probably going to have an additional cost to the user. You're also going to have performance concerns. Does it change the way the model's trained? You'll have speed considerations. Does it just the process of doing the verification just make it all run slower? And then finally, does it affect generalizability? In other words, are there certain model architectures which might not actually work with the verification system you're using? A good example of that would be if the architecture is very non-deterministic and kind of hard to reproduce, that produces results which are unstable, which means if you're doing any hash-based verification, it becomes much harder to do kind of Merkle tree arbitration, etc. The kind of two, I'd say, big things we focus on are, one, making arbitrary machine learning graphs fully deterministic on the GPU. So that looks like us building our own compiler stack, but also just kind of monkey patching kernels inside CUDA in order to make the models run identically across heterogeneous devices. And then the second thing is working out a secure game theoretic framework whereby through staking and slashing, you're able to essentially push the Nash equilibrium to people not cheating. And we do that in a framework which is trustless, so there's no kind of reputation in the system. So we don't have a kind of points-based reputation system or anything. It's just if you have a GPU, you connect to the network, you stake, and then you should be incentivized to do the correct actions.
So, Harry, I'd love to dig into that a little more. How do we keep, like, how are you guys keeping costs low with that verification? I'd like to open that up to everyone else as well. When you're incentivizing, you know, a group of people to do this and you need to add in a verification element, how do we keep costs low so that we don't end up more expensive than the initial problems that we're trying to tackle?
So I can maybe start with just a quick one, which is you typically have a trade-off in terms of how much of a burden you put economically on the solver before the training run versus, you know, how much risk you want to take. So if a cost to cheating is them losing $1 million and the job's worth, you know, the training job they're doing is worth like $100, they're obviously very, very disincentivized to cheat. However, it means that their yields get very compressed. So there's a third dimension you can add in, which is basically, well, if you make the job sizes quite small, that means you can then reduce the amount of stake required per job, but then you have a higher communication cost because now you've got more jobs. And in a decentralized system, that doesn't really work very well because you're typically communication constrained versus compute constrained. So for us, a lot of our research over the past kind of 3.5 years has been working out the optimal set points for those different dimensions, such that you get an optimally low cost with the same level of security.
Yeah, I agree with what Harry just said. I think if we look at the cost in terms of communication, which in our case, when you're doing the validation, you need to first download the model, and there also is a compute, so you need to run the model on your device to see how good it is. So we tackle it in two ways. So firstly, on the download bandwidth, there's really no need to download the whole model, especially we're doing like LLMs, they can be very big. But if you're just, say, fine-tuning or improving the models in like a small way, you're basically just adding a layer to it, so it's a response to Web3 transaction-related questions better. You can just download that. So that is what we enable in our validator script. So you're just downloading the LoRa, and that reduces the download time by like probably 98%. And in terms of the compute used to run the model locally to give a score, there are several ways of doing it. And in federated learning, we find, especially it's not like after each round of training you get significant result. So you can adjust the meta parameter so that a local training can run several rounds before it becomes meaningful. And you can optimize that based on the training process so that each time a validator runs a compute, there will be a meaningful change to judge on.
Anything to add?
Mostly a model question or a data
well,
question?
I think both, right? I think on the data side, right, when you're adding in verification of data, how do you keep costs low?
Yeah, I think across the AI stack, probably verification focusing on different parts of the stack has different level of requirements. For data, especially the more structured data that we're focusing on right now, compute requirements is really low to the extent that we actually plan to do hopefully through Akash, a one-click deployment on your desktop of running a node on Masa network later on this year. And hopefully by the end of this year or early next year, we even want to be able to help you run a Masa node on your mobile phone. Think of tethering your phone, but in a very similar way, how you can contribute your spare bandwidth and your compute resources to run a Masa node directly on your mobile phone. So it's basically an afterthought almost, and at the same time, you accumulate passive rewards.
Yeah, and I mean, I think for each of these use cases, it's really important to think through like what is the value being received by the end user, and cost is an incredibly important component of how most end customers are going to think about really I think across the stack are going to think about this space. And so one of the things that we were really excited about with validation and sort of the incentive model of BitTensor for our specific use case is right now there's a large amount of humans in the loop and structured data, and LLMs are now performing and exceeding the levels of sort of the average kind of human verifying data and providing that metadata, and it could be done at a fraction of the cost. And so you need to have that validation mechanism in there, but we're removing a very significant cost in structuring the data that's valuable to our products and to products of other customers.
Yeah, it makes sense. Zooming out a bit, all of you guys are calling on, right, the community to kind of source, whether it's training jobs or data or running inference. What are your biggest concerns? Is it quantity of provider? Is it quality of each provider? How are you guys thinking about that? David, we can start with you.
In terms of the community that's doing the
whatever
work?
tasks, yeah, exactly, yeah, the tasks.
Well, I mean, we sort of think about it, in a couple ways. One, we've sort of designed the system to really enable, the validator or the customer to decide, well, what data do they want processed? What we need to be successful at with our incentive mechanism is making sure that they receive the structured data back that's valuable to fine-tuning and retrieval systems for that data. So we're really focused on ensuring that incentive mechanism is succeeding and delivering better than kind of human annotated or human metadata delivered information.
Yeah, I'll plus one on that. I think it's really all about the incentive mechanism you're designing for your network. And dropping a little bit of alpha here. Actually, on Tuesday, we're announcing that Masa is launching a BitTensor subnet as well, very similar to what Afterparty has done in the BitTensor ecosystem. And on the subnet, you actually only have 256 miner spots available. So you essentially need to compete based on the utility you provide to the network in order to get one of the 256 spots. And as soon as you get the spots, you start to generate emission, which is quite generous across the BitTensor ecosystem. So end of the day, it's really all about what kind of incentive you are designing for your network.
Yeah, what is my biggest concern or focus? I would say by AI Arena and FL Alliance, Flock has accumulated really a very sharp team or community of machine learning developers. So now it's figuring out how we can best utilize their intelligence, like what are the problems that are worth solving in Web3 AI that we can put as a task created so that it generates protocol revenue in the long term, but it also gives like real usage for the models created.
I'm quite sanguine on the supply side, so I think our verification system weeds out people who are bad actors. I think on a macro level, I'm most worried about the kind of, and to the kind of topic of this panel, like the hype in the space and the kind of upstream effect that has on basically the demand side. So, the very high likelihood, the vast majority of users, at least in the next kind of 5 to 7 years for all of our products will be kind of non-crypto users. There'll be people who are doing machine learning kind of in Web2, so to speak. If there's kind of projects in the space which have kind of infamously crypto-style blow-ups and things go wrong and like it's all kind of it kind of reconfirms a lot of the kind of cynicism that some Web2 people have around, crypto being scammy and everything. I think that's probably one of the greatest kind of risks, just from a kind of community perspective. I think like so far, with maybe like a couple of exceptions, the space has actually been like relatively resilient to that. But as we've seen with kind of FTX and all the stuff that came before it, in every kind of hype cycle, there's always always this kind of phenomenon. So I'd say actually that's probably the thing I kind of think about the most, although it's kind of outside of my kind of locus of control because it's other companies. So yeah.
Yeah, crypto needs a PR team.
Yeah, exactly.
badly. When creating these decentralized solutions, incentive alignment is so important, right? How are you guys thinking about building robust and resilient incentivization mechanisms that allow for the quality of your digital commodity to be supplied in a manner where I guess we're building, to the point of the slide, real quality products.
Me again?
Lead the way, David.
So I mean, for us, there's kind of like two different sides of like how we think about the incentive design. So, we are progressively sort of decentralizing what we're doing at Afterparty AI more broadly. We think of the subnet as really providing kind of the decentralization on the data front, so enabling us to provide that really valuable data to our customers who are the creators and and businesses and ultimately anyone who wants to create a really authentic and accurate AI. We're going to be doing some stuff in terms of how we're going to incentivize and create decentralized ownership of that platform, but we're a little earlier in the exploration there. I mean, on the BitTensor side, I think it's a little bit specific to that ecosystem, and I think it's a constant sort of evaluation of how the mechanism is working. It's a living, evolving thing. I think that is one of the things I'm sort of most appreciative of the BitTensor ecosystem. Is I think it's been out there in the wild for a while, and it's had some big sort of swings, different. I mean, even right now, obviously, there's some some issues with the chain. But it's constantly evolving. It's dealing with a lot of these adversarial attacks that are actually happening at a chain level or happening at like the subnet level. And I think the ecosystem gets stronger because of that it is in market. And you can definitely point to things that are real there. I think you can also point to things that feel less real there. But overall, I think that's a big positive of that ecosystem in my mind.
Yeah, I'll probably be a little bit cynical here. And to Harry's earlier point, any crypto project out there can claim that, oh, I have like 5 million users and 10 million users, but who are those users out there? It's probably like 100 of Clenthias floating out there with my farm of bots and wallets. And in reality, if you think about everything that we're building here, right, specifically to what we're building on the data side, it's about data supply and data demand. What we're looking for is really the so-called data product market fit. Sure, you can have like 10 million users supplying useless data to you, but end of the day, only the data that is valuable to the developers will be valuable to the network. That's the reason why my ingenious co-founder, who's going to give you a demo in 10 minutes or so, designed this game theoretic framework that mostly reward data suppliers who provide high utility data to the framework instead of anyone provide any invaluable data points. So yeah.
I think in the long term, on-chain incentivization makes a lot of sense. I used to work in like big consulting firm, and a lot of the job and incentivization is handed down by a senior managing director, and that is really not a fun way to work. If you think of a long-term picture where all your contribution in code, compute is tracked on-chain, and you get rewards based on how many people have appreciated or used your models, I think that's a great blueprint. But in the short term, I think there are two obstacles I think most crypto protocols are facing. Like one is, how do you track the contribution on the supply side correctly? So we've all seen the news. There are Sybil attacks, faking compute, faking model contributions, and faking inferences. All of those are possible. And I think it's not a bad thing, because if there aren't any Sybil attacks, it means people aren't really thinking about your protocol design. So I think the answer shouldn't be, oh, we should go back to centralized system, but it should be, we should come up with more clever cryptonomic designs. So I see protocols already doing how do we use AI native ways to check compute, to check data contribution or model, and this should be like a constantly evolving thing. Yeah.
One of the things I think about the most is incentive rewards and how useful they can be. In a sense, they created our whole industry with the Bitcoin block rewards, and then various projects thereafter. But they've also been kind of abused and gamed to the point whereby there's just huge questions around how useful they are, particularly when you're incentivizing physical infrastructure. I think in an ideal world, you wouldn't necessarily want there to be incentive rewards other than the incentive of the buyer paying the seller, right? Because then it's just a clean, free market. There's like less speculation. I think one of the biggest challenges for people who are incentivizing physical infrastructure is trying to reduce the kind of, I guess, like percentage of the reward, which is kind of like truly market driven. So a good example is right now, or at least before I don't know if it's just now, but before the last halving of Bitcoin, approximately 98% of the block reward was, or rather 98% of the income was block reward, right? And 2% was fees. it's obviously unsustainable. It creates questions about the long-term kind of future security of Bitcoin. I think a lot of people, particularly on our side, when we're incentivizing compute itself, there are these questions around how can you get people to attach these very expensive machines. Ideally, it comes from a very robust demand side who are willing to kind of funnel a lot of volume through the network. But I think so often, and particularly we saw this in the last cycle, deep-in networks basically end up overpaying the supply side and absolutely melting through their kind of token supply, giving it to people who are completely misaligned with what the goal of the project is, who are basically just using it to print cash and then just disappear when the market tanks. And I think that's definitely what we're indexing against. We don't want that. Yeah. There's not really a kind of concrete answer in there, but more an observation that I think that's one of the most important things.
Yeah, that makes total sense. I think what's fascinating to watch and what's incredibly difficult is kind of bootstrapping supply and fostering demand at the same time. So hopefully you guys are the ones to do it. Cynicism aside, we're all obviously here because we're really excited and have conviction in a decentralized AI future. So let's end it on a happy note. What are you guys most excited about in a decentralized AI future?
Yeah, we think a lot about. Our core product is around giving creators like ownership and control of their AIs in the future. And I just think that fundamentally, with a technology as powerful as AI, if you're a creator, if you're really anyone, handing over the keys to that AI to a meta or the next meta, I think is really problematic. And I'm actually kind of conversations we have with creators in LA all the time, they're really focused on that. They understand that this is a forever technology, and so I'm really optimistic on the ability to deliver that fundamental ownership for people to own and control their AIs.
Yeah, similarly, I think I'm most excited about two things. The first thing is really that you as end users will get to monetize and own your data. I'm sure a lot of you have seen that some big publications such as Wall Street Journal has been selling user data to the likes of OpenAI. We don't want to see that repeat ever again in the future. The second thing is that I'm really excited about non-Web3 developers using all of our products in the future. I want to see every single AI developer out there, no matter where you're from, decentralized, centralized, you want to use Masa API for data consumption. We are onboarding a few of our first few Web2 AI developers right now. I think as we develop in the next 2-3 years, I want to see more of it.
I'm most excited about the monetization of data or skills, but without losing ownership. So through federated learning on chain, data can stay decentralized, and you can have decentralized model building. Like, to me, that just makes a lot of sense than handing over data to big tech, and they have one model for everyone, and you had to pay for them to customize the model based on your data. So I'm quite excited about the federated learning rollout, and in a way that incentivizes data holders and developers who aren't previously paid.
I'm excited about the long term. I think in the next 10 years, we're going to get a machine-to-machine economy, which goes parallel to our current economy. I think that economy will eclipse the kind of human-to-machine or human-human economy, where machines transact value with each other, they create things. I think all that has to be on-chain, or at least chain-adjacent, for two reasons. One, we need property rights, so they need the ability to basically store value in places. And two, we need a substrate on which they can connect to resources in a permissionless way. That to me really excites me because it's completely out of distribution for human society so far. We've never had an economy which has existed outside of the context of humans. And I think that the opportunity there is just, uncapped.
Awesome. Well, thanks, guys. Really appreciate all your insights, and hopefully it was an interesting chat for everybody. I'm sure you guys will all be available to answer questions for people afterwards. Thanks.
Thank you.
Is it on? Okay, I can hear it. Right, good afternoon, everyone. Who's going to join me for a very exciting demo about data? I can see you're all absolutely thrilled about this. Come and join me. I'm going to show you how you can use the Masa network to scrape data from anywhere for free to use in your data pipelines, in your AI models. So I'm Brendan, co-founder of Masa. You just listened to my great co-founder, Kalanthi, here talk about data and the future of AI with other people. And today I'm going to take you through a demo of how you can get up and running on our network, access any data for free. We're going to focus today on Twitter data. As many of you all know, around 6 or 7 months ago, Elon decided to really clamp down on the Twitter API, make some really tight restrictions, and essentially shut it off for a lot of people. So we saw that as a huge opportunity to bring that data to the Masa network, and today anyone, anywhere can get access to any data on Twitter through our API, all for free, and it's aggregated by our network. So let's dive in. What are we? We're a decentralized AI network where anyone in this room can run our software and earn by contributing data. That data is either data you have personally, or it's data that you scrape and acquire from other platforms. Twitter, Discord, many other platforms which we'll dive into today. So we're going to focus on building unstoppable AI applications. We call them unstoppable because they're constantly evolving. We all have ears, senses. Data is the ears and the senses for LLMs and AI agents. Without those ears and eyes and senses, LLMs are unable to evolve. Agents are unable to kind of keep up and keep track of what's current and present today, and learn and evolve without being retrained. So our pipelines are critical for the evolution and the, I would say, adoption of AI models. And as I keep saying, I keep repeating, this is interesting. Yeah, that works. This is great. Some of my colors are gone. We enable anyone, anywhere to access Twitter data, Discord data, structured website data, podcast data. This data comes from RSS feeds, your favorite podcasters, your favorite YouTubers, whether it be a Bankless podcast, whether it be Human Labs podcast. You can easily extract that data speech to text, diarize it, and then use it directly in an LLM for pre-training, fine-tuning, or RAG. I love RAG, actually. RAG is amazing. If you do RAG really well, it saves you a ton of money and a ton of effort. And with Masa, as you'll see, you can easily take any of this data, annotate it, structure it, vectorize it, and use it directly in RAG. It's really powerful. Through the Masa protocol, we have a decentralized set of worker nodes, around 48,000 nodes today on the Masa network. Each of these nodes runs a specific scraper that aligns with one of these data sources. Outputs are system prompt integrations, RAG, LLM training, fine-tuning. You can tokenize the data and use it to pre-train or train your LLMs on Flock, Akash, or any other network you so wish. We have around 100 developers using Masa at the moment and have processed millions of data points over the last 2 years. So firstly, I'm going to show you a quick video. I'm not doing my demos live today. I could show you live, but I decided to pre-prepare. We could do a quick start. I'm going to show you how quickly you can get up and running, this should play, with Masa. So all you have to do is go to our developer documentation, go to our quick start guide, and you're going to clone the repo. Once you've got the repo open in your favorite code editor, you're going to install our smart contracts. All you have to do is stake Masa to access data on our network right now. You don't have to pay, there's no fees. We will be transitioning to a fee model in the future, but that's not going to be a few months. So you can all-you-can-eat data at the moment just for staking. And right now we're on testnet. So here we've just installed our smart contract packages. You need to use our faucet, which is all in our command line. So I'm actually going to I'm building the binary here. And this is very small down here, so I'm sorry for anyone that can't see it at the back, although you're all having wonderful conversations. And And we use our faucet to essentially mint some Masa directly to our node. And then we stake our node. All of this takes you about 3 or 4 minutes, literally going from cloning the repo to getting data we're going to show you in a moment. Once you stake your tokens, you'll be able to start the node and start accessing data from the network. And today we're going to focus on scraping the last 100 days of Elon's tweets. So every tweet that Elon has put out in the last 100 days, we're going to scrape. We're also going to scrape some meme coin tweets as well. And we're then going to put it into a RAG setup and just see what it can tell us from these tweets. So right now, I'm going into these Swagger docs that are on our local thing. I can easily, quickly go out and fetch Elon's profile, or yeah, profile. You can see here the, let me just pause this. Oh, I've accidentally put that back to the beginning. Let's just put it back here. Let me show you what happens here. Okay. So what I'm looking for here on these logs is the request that has gone out to workers on the network here. The workers have gone out and scraped the data. We essentially reverse engineered Twitter's API. Said fuck you to Elon, went and did it. All of our workers can go get data. And it means that anyone, anywhere can get data from Twitter. So this is going out to a set of workers, a subset on the network. They fetch, return the data to a validator. The validator concatenates the data, verifies it, and then returns it as a request to the API. Now we're going to get the first 20 followers of Elon. This is a particularly valuable feature. Elon cut off the followers endpoint on the API for every package other than the $42,000 a month package that he has. Also on everything but the $42K a month package, you're limited to 1 million tweets a month. So the $5K a month package, you can scrape 1 million tweets a month. Again, this is unlimited within some rate limiting, which I'll explain in just a moment. So let me just hit play again. We're now going to get the most recent 10 tweets that have meme coin hashtag anywhere in the tweet, and essentially return from our workers, from the recent tweets endpoint that we have in the API, all of the recent tweets that have a meme coin hashtag in them. And that's the end of the quick demo of our API before we get into showing you how you can work with the data. So you can see very, very quickly, get up and running, go out, start scraping data, and this is accessible to anyone, anywhere. A lot of geofencing still goes on in both the LLM access space, AWS services space, and we really want to make any developer able to get access to this amazing, incredible AI technology. So we have shown you how you can go out and get Twitter data. This should play. We have a set of scripts and tools in our GitHub under our awesome Masa repo. You can come in, download these examples. They're written in Python, get up and running really quickly, start scraping data. In this particular script, we've got an Elon tweet script and a meme coin script. You can use either one of these to go out and build pretty vast, big data sets. And within here, I'm going to be scraping the last day. We're going to scrape 200 tweets a day here, or 100 tweets a day, sorry, and return those to a CSV. And from that CSV, we'll be able to use them in a small editor I have on the side of this IDE, which will pull the data in, vectorize it, and then inject it into the system prompt using RAG. So we're going out to the network. We're fetching tweets here. So we fetch the ones from today. Going to go back to our node, and you'll see that it's actually fetching here. And we're only fetching 2 days here. And then we'll go back, and you'll see it's fetched 100 tweets from yesterday. And it will keep cycling through until it gets rate limited. Twitter does rate limit you to around 450 tweets every 15 minutes. So this script is set up that if you leave it in the running in the background, it will detect when you're rate limited, pause, and then continue the job afterwards. So it'll just pick up where you've left off and eventually go back as many days in history as you want based on the topic you're searching for. So here we have cleaned, sanitized, let me pause this really quickly. Cleaned and sanitized tweets here, all with this meme coin hashtag in it. Above here, we've also got our Elon tweets, which is the last 100 days of Elon. And I'll show you that in just a moment. So what we're going to do on the right here, we're going to use this data that's now been vectorized on the back end of this particular IDE. And we're going to start, I accidentally started it again. Let me just go back to here. 1 second. Okay. And we're actually going to start interacting with this file. So we've asked this editor here to summarize these tweets on meme coins. And it's now going to give us an answer based on all of the context that we've just scraped from Twitter in real time as of today on these particular trends we're seeing. So it's giving this summary here. Let me just go back to the end. That stopped very quickly and has given us a really nice, clean output. Let me just pause that. Okay. Sorry about this. Okay, managed to pause it. So you can see here, it's given its kind of sentiment. We actually have a system prompt on the back end that steers the LLM to talk more about sentiment rather than anything else. And it's been able to kind of like take this huge, well, it's not huge, 200-line file and then use it as RAG in this particular query. So this is just to demonstrate how quickly you can go from zero data to using data directly in an LLM to give you real-time context on a specific topic. If I show you what I scraped last night, this is Elon's tweets here. This is the last 100 days of tweets that Elon has put out over the last, 100 days. And it just goes on and on and on. He roughly tweets 70 to 200 times a day, which is kind of crazy if you really think about it. So there is a lot of data here. I could just keep scrolling for quite a while. It's kind of ridiculous. So go back to my presentation. Before I go any further, are there any questions? Any comments? Yeah. Yeah. The question just asked here, can this be applied to any API, whether it's password protected or not, to scrape data? So we support a lot of different interfaces as listed up here. If it's OAuth 2, if it's web-based, or if it's permissioned, we can do. Doesn't mean we do today. We support a lot of interfaces, but if you make a request, we can spin something up and normally put a scraper or parser out within about 48 hours. Yeah, so most interfaces supported, but if it's not, we'll typically create a parser. And here's something we do. For example, the web data here, which I'm going to show you in a moment, we actually use a JSON fine-tuned version of Llama 3 to structure volatile data as part of our pipelines. So we don't use LLMs just for chat interfaces. We actually use it as part of our data pipeline for processing volatile data. That's always changing, always dynamic, especially web data where all the tags are changing very, very frequently. So, great question. Any other questions? Yeah.
Of scraping Elon's tweet, right? Then you give this task to some 100,000 agents, something, right? So how does it go about, right? How do they go about and get the data?
So how does he go about getting data? Sorry.
So what I want to understand is when you create this task, right? Let's say we need to scrape last 200 tweets of Elon Musk, let's assume, right? And we do not have an API access. but you created a job for some of your agents to go and do it, right? Are they incentivized to do it? Like, how does it actually happen?
Yeah, great question. So, gentleman here is asking about our incentive model. So, really good question. Today, miners or workers make money through emissions, either Masa emissions or BitTensor tau emissions, which is what I'm about to show you. So this week we're launching an integration with BitTensor. We have a game theoretic model that uses mean field game theory to essentially model this stochastic system. So the stochastic system is a lot of different nodes. Validators is one agent, workers another agent, and a user or consumer of the data is another agent. Every single one of those agents is trying to optimize their utility. Each agent stakes to the network, and there is a relationship that defines the utility of a worker, the utility of a validator, or utility of a consumer of data based on their contribution to the network. Obviously, a consumer, their contribution is fees to the network, so as the network's getting paid, so as it can trickle down back to validators and worker nodes. So we've sort of formally defined that mathematically. When we transition to a fee model in, let's say, 3 or 4 months, those fees will also get distributed back to users. So anyone can download the code today from GitHub, run a node like I showed you, and start querying data immediately. Yeah, good question. Thank you. So the last thing we're going to cover is we're launching an integration with BitTensor this week. Who knows BitTensor in this room? Quite a few. Amazing. So incredible project or product protocol. Really phenomenal way of tying incentives and game theory to driving the right outcomes. We had Bitcoin using incentives to verify payments, Ethereum verifying compute and block space, and now we have this amazing ground for proving out different models and different ways of acquiring and distributing data for machine learning through similar incentives. And with Masa Subnet, anyone here can join, so we'd love anyone to participate. Testnet is starting this week. We'll run for 2 weeks, and then mainnet launching at the end of July. You'll be able to scrape data and pre-process data for other subnets and for static data sets. You'll earn both Masa and tau emissions for running on the subnet. You'll be building static data sets, pre-processing data, or running pre-trained LLMs that we're training on Akash and Flock as well. Maybe that's an LLM trained on the entire corpus of Human Labs podcasts, which is something we're doing right now. So how can I get better sleep? The response you'll get is take magnesium for bed, work out, don't drink, la la la. And this is done through diarization, annotation, and then tokenization and vectorization of the data. Miners on the network do all that kind of pre-processing of the data from the actual protocol itself. So we now have this union of decentralized data scraping with the subnet ecosystem that allows for these kind of newer, more compute-heavy processes to happen when we're really an early stage protocol ourselves. And to give you a quick overview of how this works, this is our subnet explorer. You can see on the left there are axons on the subnet here. And you can get my Twitter profile through the subnet. This is actually querying my Twitter profile, which will load in just a moment. And the incentive model on our subnet is very similar to what I described earlier, with each participant, each actor optimizing their utility. On the subnet, you have a validator and you have a miner, and each of those are providing different functionality. This is our web scraper, so you can see this is just scraped the Masa website. The actual data itself was passed through a Llama 3 model and structured. And this is now the GitHub website where we've actually got a fully passed out structured JSON object that we can then go on to annotate and do as we wish with, how we want to process that further down the line. And we'll just keep going. Each worker on here is optimizing their uptime, the amount of data they scrape, the amount of compute they put on the network, and the quality of their data. So here is this axon has been up for 88 or 86% of the time. You can go through here and you can go and set up your BitTensor node really quickly. and get going. So I'm going to conclude here with this demo. And let me just go on to my final slide. 1.6 million people have contributed data to the Masa network over the last 2.5 years. We've got over 100 developers, and we've got 9 leading institutional validators, both on the protocol and on the subnet as well. And all of these great AI builders, here are some of our friends here and elsewhere. And if you want to build with us, just go to our dev docs. And that's it. Thank you so much. Cheers, everyone.
Testing. Hey everyone, nice to meet you. I'm Anna, founder of Vana. Today I'll be showing you a demo of Vana from a data portability perspective and also from a data liquidity perspective. One ask actually for folks in the back, would you be able to talk Is it? Oh, you can hear me now? No? Yeah? Okay, cool. So I first got into crypto in 2015 through mining. I was starting my first year at MIT and learned about Ethereum and the fact that you can go find like GPUs in dumpsters that labs would get rid of and then set them up to mine. And that's kind of what got me down the crypto rabbit hole and kind of learning about decentralization. I wanted to actually start with a distinction. I guess, are you all more AI people or crypto people? Like AI, raise your hand, crypto? Okay, they're all, okay. In that case, so maybe like today a lot of the movement around pushing the frontier of performance for AI models happens in the context of open source. And I think a really important distinction that often people miss is the difference between open source AI and user-owned AI. Right, so today most people are familiar with centralized AI, that you can think of like OpenAI, they train a model, they keep those weights private, and so because they're private, they're able to monetize them, right? And then you have open source AI, and what's nice is it's controlled by many, but the problem is there's not really a business model as soon as you make something open source, right? Like if you make data open source or if you make model weights open source, there's no reason for anybody to pay you because they can just access them for free. And we've seen this kind of play out, I'd say, over the past 2 years or so, where people have had trouble monetizing open source. They've raised a bunch of money, and then you just don't have enough money to train Stable Diffusion 4 or whatever it is, because people are just using your model for free. So I think the real opportunity at the intersection of crypto and AI is within user-owned AI. So what you get is model weights and data that are monetizable, but also you allow it to be controlled by many. And the key to make this work is that you have to be able to keep the data or the model weights private, right? You need to be able to keep the thing that you want to charge for private. A little bit of background on kind of just some of the recent models and how much data they're trained on. So this is the training data for GPT-3. Most of it's common crawl, so that's just the publicly scraped internet. And then some of it too is like WebText 2, that is an older Reddit data set. Basically, you go to every single Reddit post that has more than 3 upvotes and scrape all the text, but like publicly scraped data. But importantly, all of this scraped data represents less than 0.1% of the internet. Right? And so actually very little of the internet, and if you think about just your day-to-day, most of your activity probably doesn't happen in a place that is publicly scrapable, whether it's your messages or your email or just like permission documents. And so there's kind of this concept that AI researchers today are calling the data wall, where basically we are running out of data to train on. And I'm sure many of you have seen these exponential graphs that basically are like, hey, model performance is going to just kind of like go through the roof as we scale compute. But one of the big assumptions there is that we have enough data, and we actually don't. Like, we are running out of data. So here I've graphed how many tokens. This isn't like a crypto token, it's just a word in the context of a training data set. Were used to train different models. So you have something smaller like GPT-3 and then GPT-4, and Llama 3 was really like the next frontier because it used 15 trillion tokens, which is a huge amount of information, right? But what's interesting is we've kind of hit this bottleneck where that's actually around the number of tokens that are available on the public internet. FineWeb, it's a subset of Common Crawl that's basically deduped and then sort of cleaned up, but it's like you have around 15 trillion good tokens that you can publicly scrape from the internet. So you run into this problem of like, where are we going to get the rest of the data to train on? And so with Vana, what we're doing is kind of bringing user data back in the control of users in a fully private way. So your data is fully yours. That means non-custodial, portable, and monetizable. So first, I'll show you what it means for your data to be non-custodial. Who has run like an LLM on their MacBook or computer? Okay, I'm running one right now. It actually kept killing my battery life, so I think it's still running. But yeah, here I have my Vana personal server running. So it has an LLM, and then it also has my data connected to it. So I can have like my Telegram messages, here I have my WhatsApp messages connected, and all of that's plugged in, but it never leaves my machine, right? So I've got this full privacy. And so that's kind of the non-custodial piece of it. But often you want to actually use your data in an application, right? Like I don't want to just have my data sitting locally. So with Vana, what you're able to do is log into a third-party app. This app is called, let me just, USLAP. It's going to be able to access my local server and actually talk to some of the information on there. So it's going to be able to access my voice clone, my memory, and then some information about my personality. I'm just going to open my logs to make sure this is running. Okay, cool. So then when I click connect, what I'm doing now is I'm granting USLAP access to talk to my personal server and call the LLM that has all of my data running with it, right? And what that allows me to do is, so this is like a sort of self-motivation app that folks have built out. So I'll just say like working on my meditation practice. And I think the audio, it's gonna repeat in my voice, but I'm not sure how well that will play. The most important thing though to show you is that the model is actually being called locally with the data never leaving my machine, right? So here you can see the model was called with the prompt and it passes it to my machine, it runs locally, and then it returns the reply. And so what this allows you to do is like use your data across different applications while not actually revealing a copy of the underlying data there. And I think that often people think of privacy as maybe this ideological thing, but from our perspective, it's more economic, right? If you want to protect the economic value of your data, you need to be able to kind of guarantee that privacy. And so here I was able to kind of generate the output, but I can play the audio for some folks after on the side. Okay, and then finally, your data becomes more interesting once you can monetize it, right? And so being able to charge people for your data, I think sort of like almost feels dirty to sell your data for $300. I think people might not like that concept very much, but when it shifts from like, hey, earn cash for your data towards like, hey, you're gonna have an AI clone of yourself that can like work on your behalf and autonomously earn wages, then you care a lot more about owning that, right? And in the same way, you can kind of collectivize around that and actually create shared ownership of different models, right? So then the trade becomes, hey, contribute your data from Google, Facebook, Twitter, et cetera, and in exchange, get a share of ChatGPT, right? And what we're working towards at Vana is actually a user-owned foundation model. So we think that we can beat the performance of GPT-6 and GPT-7 by just beating it on data. So if you get 100 million users, you can sort of scale beyond the data that's available both privately and publicly that you could reasonably buy. So an early example of this is the Reddit Data DAO, which was launched just a couple months ago. I can pull up this. And so I'll call out the scraping thing here actually, because when we hit about 100,000 users, Reddit actually, there were some mainstream journalists at like Axios and TechCrunch writing about it. So Reddit got in touch and was like, they're breaking the terms of service, like this is scraping illegally. But because of data regulation and because it was every user bringing their own data, actually the project was able to stay up, right? And so that shows the importance of non-custodial data and of kind of tying that together with data regulation, because while you can scrape data early on, it really doesn't work at scale, and people are trying to find ways around this. We think the best way is through the users. Any questions on the Reddit data DAO or anything to date? Okay. Oh, something to note too. So there's now a machine learning researcher who's training a user-owned model on the Reddit dataset. It's going to be the first user-owned like shitposting model. It won't be a foundation model, but it is that kind of early example, right? And I'll call out again, in order to monetize this, you have to be able to keep the data private and the model weights private, right? Otherwise, you can't charge someone for it. And so that's what Vana enables. Vana is actually technically architected as an L1 for private data. And I'll show you some of the key concepts here that kind of underpin Vana. So one is non-custodial data. You should be able to manage access to your data just like your funds, right? So you can sign a transaction and then grant someone access to your data. You can also log in with your wallet and all of your data is there. The other thing is proof of contribution. So it's really hard to measure the value of someone's data, right? Like how much is my Twitter data versus kind of compared to yours or someone else's. And so with Vana, proof of contribution is implemented at the dataset level. So for every dataset, there's a different proof of contribution function. Some of the folks who have built the Twitter data DAO, they're actually early BitTensor subnet creators and miners, and so they've sort of designed the economics around valuing someone's Twitter data. There's also someone working on the LinkedIn data DAO who he used to sell LinkedIn data working there, and now has sort of moved over and designed the tokenomics to value that. And each data set has their own data set specific token that can sort of have its independent tokenomics and also acts as governance for the collective data set. So yeah, this proof of contribution is the core of the network, and it allows you to aggregate your data together, right? You need a lot of data to be able to train on and make sort of work in a meaningful way. The last thing I'll show is just the high-level Vana architecture. And so here are the sort of key pieces of the network. The data liquidity layer has 16 different slots. It's sort of similar to BitTensor's subnet model, and each one of these is focused on a different data set. And so right now on the Satori testnet, there are a bunch of folks competing for these different slots. There are, I think, 8 different teams building for the Twitter data set, and that competition is actually really healthy because it allows for people to build better ways to validate the data and better ways for monetizing the data. So yeah, 16 different slots here. Maybe I'll call out some of the interesting ones that surprised us. Someone is building a footpicks data DAO, which we were not expecting, but like is an interesting data source. And then we'll also be launching just a cookie data DAO as part of an event tomorrow for Vana. Then you have the data portability layer, right? So once I've joined with my Reddit data, my Twitter data, et cetera, then I can log in with my wallet and bring all my data with me anywhere on the network, right? And so you have full control of your data and this full kind of portability. There's also this kind of connectome, which is basically just a real-time map of all the data flowing through the ecosystem, and that's fully EVM compatible, right? So you can write smart contracts that are interacting with, it can basically call private data, and you get that full programmability in order to manage some of these resources. So yeah, just to kind of wrap up, Decentralized AI, our view is that it's all about owning your AI and you're part of a user-owned foundation model. We think that in a world where AI has really large economic impact, it's important that you have exposure to it, and it's also important from an AI researcher's perspective just to get better and better data to be able to push the performance. And so foundation models, they often tend towards monopolies, right? They require a huge amount of compute, a huge amount of data, but you can actually, with the right incentives, aggregate enough resources to be able to train something that's fully user-owned. Yeah, so that's all I have. Happy to take any questions. Yeah.
So what validators actually do? What do they validate? What are they validating?
Oh, what data are they validating?
What are they
Yeah. So in the case of the Reddit data DAO, what they're validating is, one, do you actually own the Reddit account? In order to do that, they have you put a code inside of your Reddit profile to check that you own it. And then they're also validating things like, is the account sufficiently old? So like, if you just created a new account, that's not very good. So was it created typically before the launch date of that particular data DAO? And then is the data any good, right? Which is obviously a very hard question. One thing I'll actually pull up for that, so the sort of purest implementation, this is the best implementation of measuring data quality. Are you familiar, has anyone heard of model influence functions? Yeah, model influence functions. So the intuition is basically, you take a trained model, so you take Llama 3, it's already been trained on a lot of data, you show it a new data point, and what the model influence function tells you is how much information does that data point contain that the model doesn't already know. So to build some intuition there, here, let me see, like here are some of the most influential images. So the MNIST data set is this handwritten data set that's classic in machine learning to work with. And so here are some of the most influential training samples. So it's sort of like the weird twos, these edge cases of like, oh, is it a 2 or is it like, I don't know, a 9 or a 7? But what I would call out here is someone could put a really bad 2 in there that you actually don't want to teach the model, and it would be very influential, right? So you need a few different pieces of proof of contribution. One of them is like, okay, just purely how much information does this contain? Is this valuable? And the other one is like, is this good information to teach the model, right? And like, Vana doesn't have any sort of solution on this core truth problem, which is a very human problem, but we rely on basically the existing Web2 platforms or social consensus to decide this is truth or this is not. And you can also allow for different models with different ideologies, right? You might have one ideology that is leaning one way politically or another way politically, or different kind of national models that get formed from people's data. Mm-hmm. Yeah. So the question is, can we talk more about the tokenomics model? With Vana, I'd say the closest analogy is Ethereum. So there's a native token, which is the gas token, and is used for staking. And then similar to how Ethereum doesn't own any of the ERC20 tokens, Vana doesn't own any of the dataset specific tokens. And so every data DAO on the network has full control over their tokenomics. And then Vana is essentially just a small gas fee that's used for any data transaction. And our view is sort of err on the side of very minimal fee to get as much infrastructure, become kind of the default place where all personal data lives, over trying to capture maximum value from every single data sale in the system. Yeah. Yeah. Yeah, so the vision behind the founding, I guess for me, like I had gotten really into mining Ethereum in like 2015, and then I dropped out of school in 2017 to start a machine learning company that I had started. I just automated my job as an intern sorting documents at the World Bank, and then got really familiar with sort of all this machine learning tooling and saw just like the immense value of data from two perspectives. One of them is like, I'm very much an AI accelerationist, right? And I just want to push model performance as fast as it can, sort of as far as it can go. So you need a lot of data to do that. The other perspective is from more of kind of a social perspective, right? Of like, hey, it seems wrong for 1 or 3 companies to create AGI from everyone's data and then be the only ones who own that, right? And so I think it's sort of two pieces. One of them is around like, how do you build a world where users still have agency and control over their data and can kind of push the frontiers of technology in a way that doesn't feel super dystopian. And the other one is around just purely like, how do you build super capable AI that can make like crazy scientific discoveries, like give us an amazing understanding of ourselves? And then where Vana fits in is really just that kind of like L1 infrastructure layer for the data. Like, we think the reason why this hasn't happened is because it's so hard to work with private data on chain, and to be able to unlock something like that, you need this. If you're interested in the space, other projects I'd call out are Solid and Urbit project. Both of them are purely sort of self-hosted, right? And they don't have a financialized layer on top of them. And I think that because of that have really struggled with adoption. And so we've sort of taken some of the pieces that have worked well on-chain and combined them with that personal server architecture to be able to create this like user-owned data ecosystem. Okay, well, thank you for all the questions. I will pass it to the next speaker. I don't know who that is.
Does this work? Okay. All right, we're good? You guys can hear me? Cool. All right, hi everyone. I'm Sunil. I'm a founding member at Ritual, which I will explain what that is in about 3 minutes. And if I stumble at any point during this, please forgive me. I got off a flight 3 hours ago. But I'm going to go really quickly through the first half of this presentation so we can get into the meat of what Ritual actually does, because you probably have had a bunch of other wonderful speakers that explain why AI and crypto is important. So blah, blah, blah. AI is eating the world. Usage of AI is up. This is the most important technology. All right, great. I think we all know that, right? But there's a lot of structural flaws with AI, right? It's highly centralized, but what does that actually mean, right? I think crypto has this tendency to go be like, oh, it's centralized, so it must be bad. But the reality is that centralization is bad in this vein for 3 lenses, right? One is speed of innovation. Usually open source just wins out in terms of speed of innovation and iteration because you can sort of crowdsource ideas. Access to data is unequal. Provenance is missing rapport. Unless it's a closed source model, we have no idea, what data is used, who's getting monetized, are people accurately compensated. Structurally, a lot of these models are very, very censored, right? So you see a lot of consumer applications that want to go and use certain models have to go take open source models and fine tune them for their use cases because OpenAI will never, give you certain outputs. And there's also just structural barriers to accessing these. If you want to go use the OpenAI API, you have to pay in US dollars, right? And basically all this creates is a very, very highly permissioned system, which isn't really good for innovation, doesn't really open up the innovation service to a large majority of developers and users out there, and doesn't even open up a bunch of use cases, right? So, it's important that we make sure that models in the future are not censored, weaponized, not used for propaganda. For example, we already see that ChatGPT is banned in most parts of the world because it's used as a vessel for Western propaganda. Probably true, it inherits the value system of a small safety team at OpenAI. And transparency matters, right? We like to parody the Dune quote of who controls spice controls the universe. It's who controls models controls the world. And we see that the way models are playing out right now looks very similar to the cryptography export bans in the 90s. Now, AI and crypto to the rescue. Obviously, crypto as a very decentralizing, sovereign first technology comes into play here, where you can build a lot of really interesting primitives around incentives for getting people to provide data or provide compute to run models. You can build a lot of really cryptographic gadgets that provide provenance and things around integrity or security or privacy. And you can build censorship resistance. If you have a network of models that you can access at any time, you have the incentives to access them, and all you need is an internet connection, you can create a censorship-resistant network for accessing these in the same way that Ethereum gives people a censorship-resistant computer and playground to go and use. So this is where we get into Ritual. Our sort of why is to combine the best of both worlds and create a shared infrastructure layer platform for really aggregating a lot of these primitives, really focused on bringing things closest to the end application user. So I think you guys have heard from a number of people here that work on compute or data, et cetera. What we really care about is allowing a new class of developers to access models with all of the familiar semantics around privacy or censorship resistance that you would want. So what does this actually look like? Well, phase 1 is Infernet. which is, you can think of it as an AI-optimized Oracle network. Infernet is an off-chain network of nodes. People run models on these. They have a bunch of client software that allows them to coordinate on-chain. You can do on-chain payments for inference requests. You can pass on proofs that, arbitrary proofs that can be verified on-chain. And basically, we just open up the design surface for smart contract developers to access models, right? So now you can inject models into your DeFi app. Even if you just want to monetize your model on-chain, that's like possible, right? You can take payment in any ERC20 for accessing your model inference. And so we've been working with a bunch of applications to iterate through both the universe of models that are available on Infernet and also applications that are using these, right? And people are using this from everything from really just having verified inference on-chain to linking certain dynamics around their ML workflows to incentives. So for example, some applications may want to meter on a per inference basis requests to like their consumer platform because they've built a whole incentive system that resolves around sharing the profits or the revenues from inference with people who create the apps and agents, other stakeholders that may invest or front the capital for that, et cetera. In order to have that on-chain coordination happen, you need to basically be able to link your actual atomic like inference request to some sort of on-chain transaction. We make that happen. But phase two, and ignore that description because these were done very last minute, I know it's the same, but phase two is the ritual chain, and this is a little bit outdated, but basically we want to take the infrastructure that we built for Infernet and go ahead and make this its own sovereign layer. Now why its own sovereign layer? Because with Infernet, with any Oracle, you have to do call out, someone has to go fulfill that request and then call back, right? And that's great, and it works for most use cases, it's good for sort of expanding across chains, but it doesn't give you a sort of atomic level guarantee or semantics around that inference request. With ritual chain, something like making an inference request as a single transaction that interacts with other parts of the state will be possible. Now, like, how is this possible? So we're building our own custom VM that will take an existing Ethereum implementation, so it'll be fully VM compatible, and add on a bunch of functionality in the form of precompiles and stateful precompiles. You can think of these as like little sidecars that we give to node operators on the chain that let them do additional things that interact with the chain but may not necessarily be a smart contract on the chain, right? These are precompiled contracts. So a good example of this is that you may have a DeFi protocol, right, that has isolated lending protocols, and you want that protocol or some part of that protocol, maybe the loan to value ratio, right, some risk parameter, to automatically be set. With ritual chain, you can literally just write a contract that at a regular cadence pings a model and sets that within the same block. You won't have to do anything else. So essentially, you'll be able to write smart contracts over models directly. Now, the other thing that we really want to fold in is there's been a ton of innovation in the sphere of cryptographic primitives and other game theoretic primitives around providing guarantees for models. Things like zero-knowledge proofs, things like remote attestation with trusted encrypted enclaves, things that basically give people additional guarantees, or even FHE, right? Things that basically say, hey, your input's private and people run the model, but you still get the result you want, or you know that this model was not running correctly. So you can see that we have proof nodes and privacy nodes there. We also have infrastructure enshrined on the train that makes it modular and composable with all of these primitives. So you may have nodes that are running TEs that produce proofs or remote attestations around the run-through of these models to show like, hey, this model was run correctly, and then everyone can just go ahead and verify that. No one needs to re-execute it. Consumers don't really need, all right, I guess the laptop went off. Consumers don't really need, this is not my laptop. All right, wait. All right, anyway, consumers don't really need to trust that some node on this network was running it correctly. And the last part is that we've done a lot of really interesting work around like routing and incentives here, right? So obviously if you're running a model, you should get rewarded, right? And users similarly shouldn't have to think about what models they're using for their best use case. So we're building a lot of really interesting systems around like, hey, I'm a user, I want my model to accomplish this task, and then you have a whole bunch of people running models on the back end, right? Where once that transaction goes through that says like, is awaiting confirmation that says, hey, I want, this inference request, there has to be someone there that basically matches you to the right person based on like a number of criteria to go fulfill that and execute the action on chain. So we're doing a lot of really interesting research around that as well. So yeah, we're working on that. I'd love to continue with the presentation, but I think the laptop went off. And right now we've been working with a bunch of wonderful partners. I mean, we're working with Flock to build models for new novel use cases. We've been working with a number of folks on that actually around things like computer sourcing data for the chain. But I think the thing that's most interesting to us right now is that we think there's a huge design space that is yet to be unlocked around ML-enabled protocol design. So both DeFi with models in the loop to do better risk parameterization or interact on behalf of humans, things around creating protocols around models themselves, right? What sort of interesting things arise when you have incentive structures on chain for accessing models and then passing that to a wide variety of users, right? So we're really looking to work with a lot of ecosystems builders that are going to build applications on the chain. We have around, probably worked with a dozen applications now that are building on us. And so if that's something you'd like to talk about or learn more about the chain, since the presentation went off, please come find me after. Thank you. All right, we're good? Yeah.
Only.
Okay.
Sorry, I'm so enjoying.
Okay, yeah. Sylvie? Oh, yeah. What's up, Andrew?
3, I'm here. No, 4, here.
Oh, boss.
Hey.
Hey.
Do you know them?
I think I was on a panel. Yeah. What happened? Oh, sorry.
Check. Check, check.
This is Greg Osuri.
All right, we're waiting on just one more of our panelists to get mic'd up, but if you're going to have a loud conversation, feel free to step outside. If you're interested in learning more about the obstacles to adoption, come on forward and take a seat. We'll get started in about 90 seconds.
Sure. Sorry.
All right, everybody, welcome. My name is Evan Malanga. I'm the Vice President of Strategy at Digital Currency Group. And this is the panel about the obstacles to adoption for decentralized AI. So I think it would make sense if we start off with some introductions. Panelists, go ahead and introduce yourselves. We'll start with you, Anna.
Hey, I'm Anna, founder of Vana. We're focused on user-owned data. So how do you allow users to own their private, personal information and the value that that creates through AI models?
Yeah, so Zhao San, you probably know me already, founder of Flock. We're trying to utilize the technology about better learning and the blockchain to make sure there's no central control of any training facilitation, and also the user's data can stay local.
My name is Greg. I'm the founder for Akash Network. Akash is the world's first open source supercloud with a focus on GPU and accelerated computing. We power good degree of decentralized machine learning infrastructure, Flock being one of them, and also quite a lot of non-decentralized infrastructure like Brev.dev or whatnot. And it's the only place you can get on-demand A100s and H100s for a reasonable price.
I'm Kat Daly. I'm the head of marketing at Space and Time. Space and Time, we're focused on scaling ZK proofs for data processing. So we see that as super useful for kind of proving data provenance and proving the integrity of training data for AI models. So we work with a lot of data providers and data orchestration layers, as well as decentralized models as well to deliver data.
Thank you, guys. And for those of you who don't know, Digital Currency Group, we're a large international asset manager and investor, and proud to say that almost everybody up here, I believe, is a portfolio company of ours, which is fantastic. So, Greg, I'm going to start with you, and we're going to kind of move our way through this discussion through kind of like the tech stack, if you will. So we're going to start with access to compute. Depending on what you read in the source, over the next decade, I think estimates range between tens, if not hundreds of billions of dollars, or up to $1 trillion of additional compute will be needed to power AI globally. And today, there's about 10 hyperscalers that buy 75 to 80% of the hardware that comes out of NVIDIA at current estimates. So how big of an impact will access to compute have on our industry?
So I think the estimates might be different for actual hyperscalers purchasing NVIDIA stuff, because NVIDIA wants to keep hyperscalers away and they want to give it to more customers. NVIDIA is actually doing a pretty interesting job in distributing as much as possible, right? But the question remains, NVIDIA being a big monopoly, right? They're still challenged in terms of supply chain and whatnot. So the two main aspects of when it comes to access. One is just hardware diversification. So we're starting to see incredible innovations in the diversification, all the way from leveraging heterogeneous chipsets to be able to train models. So that means that opens up your chipsets to not NVIDIA stuff like AMDs or even Apples or even some of the Amazon or silicons that are coming out. So that's good news, right? Because we do need compute, and supply chains are extremely constrained for one company to have all the monopoly. And two, like if you think about, a lot of chips are with companies that actually use them to train and infer or whatnot, and there's no real way for these companies to share their underutilized capacity. That's where decentralization plays a major role, because open source and decentralized permissionless systems can go places where your traditional hyperscalers cannot, right? So you obviously have cloud-grade compute now, which resides in data centers, but what about non-cloud grade compute, be it in consumer-grade devices such as PCs or even gaming machines that have enough flops that are not coming to market, right? But there is definitely the need for it. So I think the need and the demand is going to drive innovations, like some of the stuff we're seeing with Open Dialog Co and whatnot that are actually like coming to life now, that can leverage. Ideally, the idea is to leverage these low-grade chipsets, right? So I think decentralization is the answer to the access problem. And as systems get easier to use and as research takes fruition that can leverage these chipsets, we're going to be solving this issue. So decentralization is saving AI and will save AI in the future. That's my take.
And just to follow up to that, do you foresee there being any complexity around coordination with underutilized
Absolutely.
compute?
I mean, we are in the thick of it, right? So coordination is very challenging when it comes to just from a technology standpoint. I think we haven't gotten, I mean, there's work happening, but we haven't gotten to a level where it's completely frictionless, right? Like a challenge, just about Akash, the providers need to have Kubernetes, which is not a normal consumer thing. Even from a technical aspect, it's also very, very complex for engineers, right? So that's where we are right now. We are in the 1980s internet, I would say, to use. But we need to come to 2024, so I think that's a function of time, right? And also from a usability standpoint, like right now to use Akash, which is non-custodial, it's challenging for like regular folks, right? Like that don't have crypto or don't care about crypto, which most of our machine learning folks are, right? So how are we solving those problems and doing so without taking shortcuts, right? Doing so not by putting a login password and putting a credit card on top of it, because that's not the answer, right? How do you still remain non-custodial, permissionless, and free from all the old problems that we came to solve here, yet solve the user experience? And we're doing some work there. I think that seems very, very promising. That's going to solve the user experience from a demand side. So, but we're seeing a lot of integrations happening with Akash, right? So we have Brave integrated, and pretty much like we have 4 integrations that happened this year so far. So that means the access to compute is getting easier and easier and easier. In 5 years' time, you can see hundreds of these integrations come out and play, and that's going to be a big determination factor as to how far we succeed.
Any other panelists want to chime in on this? Okay, thanks, Greg. We're gonna move on to access to data. And Anna, I just watched your demo, so you're top of mind for me. But it's no secret that AI needs a lot of data, but not just any data, quality, real-time data that might not be publicly available. So how do you think about incentive design when it comes to accessing data?
Yeah, so as soon as you put some kind of financial incentive on the internet, people will aggressively attack it, pretty maliciously too, right? And so in any sort of network where you're incentivizing the provision of whether it's a GPU or a solar panel or data, you need to be able to kind of quantify, okay, how much is someone actually adding value to this network? In the case of Vana, it's kind of built all around proof of contribution, which is measuring kind of, hey, how high quality is this data? how much does this data teach that the model doesn't already know? And that's an important point where like, if many people similar to you have already contributed their data, then you don't have as much to add. So it's also this aspect of kind of what's already in the models and what needs to be added in. And early on, we actually tried to do this in a totally general way, where we were like, we're gonna build a general purpose way to value someone's Twitter data versus Reddit data versus all these different data sources. And what we found is that actually it's so dependent on the data source. And there are a lot of really motivated builders who are excited to think about the specifics of this problem, right? So like the guy building the LinkedIn data DAO has a tokenomics advisor just thinking about LinkedIn dataset valuation, right? Like what is a marginal LinkedIn data point worth? And like how do you measure that and reward it? So there are a lot of tools that we've built into Vana to make that easier. We've kind of broken it down from the perspective of uniqueness, ownership checks, kind of like some grounding in does it actually come from this platform? But we've actually pushed a lot of that decision making to the data liquidity pools because it depends just so much on the data set. Something else that I would call out is that data quality doesn't have to be perfect, right? So often when a machine learning engineer works with a data set, they might cut like 80 or 90% of it out and then just work with the best 10%, right? So like I think of this researcher at MIT I was talking to about like his training data, and he really wants to be able to train on synthetic data. So people train on like GPT-4 outputs, ChatGPT exports, and I was asking him, well, like, would you be okay? Like, how much of the data can be bad? And he is fine with like 90+% of the data being bad, so long as he can get that 10% that's good, because there's not really a good way for him to be able to get GPT-4 data that he's allowed to train on today. So that's something I'd call out where like, even if proof of contribution is not perfect, the economics aren't as efficient, but so long as you can get some amount of high quality data in there, it's still quite valuable. And most of what we pre-train on today is actually not very good, right? Like if you imagine teaching a kid by just like randomly feeding them information from the public internet, including like 4chan, Reddit, YouTube, it's like not great information, right? And so there's some early research coming out, like Microsoft had a paper, textbooks are all you need. I don't know if folks have read that one, where basically it shows you can really improve model performance with a smaller amount of data if you just have much higher quality data, right? So we think about it both from a quantity and quality perspective. You need a lot of data and you need a lot of high quality data in order to kind of beat the performance of those future models like GPT-6, GPT-7.
Yeah, that I have some follow-ups. Yeah, of course, especially for the data, especially for Llama 3, which released earlier, that they use a 8 billion parameter size of the model, but use 6 to 7 times large data set, which can achieve somewhere similar to 3.5, GPT 3.5 capability, which is a great sign and telling us, okay, so first of all, open source model can get there, and secondly, the very important thing you need is the high quality data that you can get. And normally, in many cases, these data are not open and free on the open network, right? You need to find a way to, Vana way or block way, that to keep them secret or keep the incentives as distributed to the users who are willing to actually share or collaborate together for those high quality data.
And are there any barriers or concerns when it comes to data privacy or data security? I'm thinking more of like from a consumer angle as well.
Yeah, so I think there's kind of the consumer angle of like, I don't want all of my messages to be public, right? And then there's also the financial angle, which is like, if you make something public, you can no longer charge someone money for it, right? So like, if I create the model weights that represent AI Anna, and I make those model weights public, like, then I can't charge anyone for it, right? And it's not really my model anymore. And so I think there's the consumer kind of privacy sentiment piece, and then there's also the piece around like, how do you make sure that the valuable data and the model weights in the system stay secure? We've found some, like I think at Vana early on, we would talk to people a lot about how we secure their data, how the kind of non-custodial data system works that I was showing earlier. We found that it actually just freaks a lot of consumers out. Like as soon as you talk to someone about data privacy, they just feel kind of uncomfortable. And so that's been interesting where we've had to abstract a lot of that away and then for some more advanced users kind of share, hey, this is how it actually works. And I think it comes in with the terms of service. It comes in for folks who are running something locally. But yeah, it's been, I think, an interesting shift as well in public perception where like, yeah, more and more people are starting to care about that data privacy piece.
All right, thank you. We're gonna move on to the next topic. Jihad, I'm gonna start with you, but we've kind of talked already around token incentives to incent certain behavior, but I feel like token incentives and these types of mechanisms introduce new complexity, right? There's regulatory risk, there's operational, legal, et cetera, et cetera. What conditions in your mind are required to introduce a token to an AI-related business compared to a typical, DeFi meme? Yeah, exactly.
Yeah, I think if a token is just representing, I don't know, a model or representing a data that's there, I don't see much value of it. But then when it comes to the real usage or real utility, is either this token can have some usage when it comes to the whole training process, inference, and data contribution, right? That's a real usage of it instead of it's just a symbol of, oh, there's a model and then that's it. Then let's meme the model. So to me, I feel like the most important thing is whether that token can actually help the decentralized AI's process, whichever stage they are. For us, the story is basically we need people to stake the token to join the training, because in that case that we can have this decentralized governance that people, if they play evil, they will be slashed. And then there will be a slashing mechanism or kind of like a game theory happening in a whole decentralized training system. So that's a way to keep you out of any central control. Say I need to have a central governor saying, oh, this is a training that we want to govern together, because otherwise who can believe in each other, right? So I think in token-wise, this is a very beautiful way, and that's the beauty of blockchain industry. Like you actually have this governance, token governance mechanism that's already there. Like the white paper is there, like since 2010, 2012, right? So we were just using it again and again in a different scenarios in different applications. And actually, we're pushing it to decentralized AI now. Yeah, that's cool.
Yeah, incentives are challenging, right? Like, so the problem with incentives is it can go in, in a direction that you want them to go, or not in a direction that you don't want them to go. We saw recently about a project that we don't talk about, but that incentives went very, very wrong. And they had similar tags and all kinds of things, right? So incentives are phenomenal, because I wrote a whole paper in 2019 about like, how can you bootstrap a free market by borrowing from the future, I call it, right? Incentivization is literally borrowing from the future value and bootstrapping a behavior that you want to see in a system in the present, and that is phenomenal in crypto, right? Going beyond incentives, just from a behavior standpoint, there are incentives to even build the ecosystem and grow the system, right? Like with Akash, we have Public Goods Fund where we are like giving grants to or the community gives grants to university professors to do research on Akash, right? So, and these professors tend to work on open source systems because they can publish what they're finding, so instead of a closed source system. So you get access to a whole lot of resources that you never got access to as a closed system, but designing them and really the verification is the challenging part. Without verification, doing incentives are just going to be the worst thing ever possible. So, and verification is challenging, right? So depending on what level you're verifying, and for Akash, it's hardware verification, which we have something in works. But when it comes to model inference, it's going to be like inference verification, right? That's a whole different animal, right? I mean, so yeah, incentives are great if you know what you're incentivizing, and be as narrow as possible when it comes to incentivizing, and be as rigorous as possible when it comes to verification. Without that, you will fail massively.
I think it's important to start backwards and identify and really align on what behavior you're trying to incentivize before you introduce it into your ecosystem. Otherwise, you're just introducing unnecessary overhead and complexity. So I think Anna talking about the way that they think about quality of data and how you're scoring quality of data is really important. For us, it's a little bit simpler because we're just focused on performance for our ZK proofs. But aligning on that before you introduce it into the network, I think just saves so much headache in the long run to make sure it's very narrow and very focused. And that will make your community happier as well once it is introduced.
I quite like. Sorry.
And we saw with Helium, right? Like a classic example is incentives gone wrong. Like I remember, I love Helium, good friends, whatnot, but I ran a Helium node in 2019 from my apartment in San Francisco. I was living in Twin Peaks, and I made about $500,000 and I paid like $100 for the box. And within a span of a year, I made $500,000. I'm the wrong person to incentivize, right? I took the money, but I didn't cheat. I was just like, just put a box in, just started making money, right? So, well, that's an example of incentives gone wrong, right? Like, so we don't want to be Helium. Even though I'm very happy Helium holder or former holder at this point, but.
I think the power of token incentives is really important, especially if you look at kind of the broader AI ecosystem, right? Like OpenAI, I think recently hit like $3.4 billion in revenue, right? And just like NVIDIA's market cap and broadly, all these different players have a huge amount of capital that they're deploying towards centralized AI, right? And I think that there are like grassroots open source AI movements that are trying to move towards this, but AI is not just like an open source project because you have to make huge infrastructure investments from the perspective of compute, from the perspective of data. And so I think because of that, you really do need these incentives that have worked so well, right? Like it's amazing that Ethereum, I think, turned from like an academic sort of project of kind of tinkering, et cetera, to very, very widespread adoption. And that is largely because of incentives. I think today, decentralized AI feels a lot like those kind of early days maybe of Ethereum, where people are still figuring so much of it out, but it's clear that incentives are very much needed to reach like widespread adoption.
Thank you, guys. Next topic, I'm going to pick up with you. You talked about community, so let's talk about awareness. Standalone, both AI and crypto are really good at confusing people with industry jargon. So how do you think about spreading awareness and communicating your value prop to end users?
I think there is a really big chasm right now in the AI crypto space. Like on one hand, you have grifters, right, who aren't building anything but are just latching onto this like buzzword of AI crypto. And that doesn't help any of us, right, because that just creates more confusion and creates more noise for the community to have to break through. So that's one side of the chasm. And on the other side, you have projects that are building something real and very valuable, but are maybe led by a more technical founder and have a hard time kind of breaking it down to simplicity, which also is hard to understand. And like the juxtaposition of those two sides of things means that no one gets it, right? No one gets the big picture just yet. And I think we as builders and as marketers have not done a great job so far of figuring out how to effectively cut through that noise. So we've been thinking a lot about this at Space and Time, especially considering that we're a little bit more, AI is more of a use case for us rather than the core focus of our business. So we've been thinking a lot about how do we cut through this noise and how do we really boil it down to where it's simple enough to understand, but still a valuable proposition to the community. And two ways that we've done that. Narrowing it down. I think there's such a tendency, especially like when you're a founder and you're really proud of what you've built, to try and focus on every single aspect of your product and your business and how cool every single one of them is, and trying to convey that all to the market, which seems like it's the right move, right? Because it seems like your product seems more valuable the more features that it has. But in reality, to a community member who only has a few seconds of attention span before they move on to the next cool project, narrowing it down to what you think is really like the one home hitter is actually a lot more valuable in cutting through that noise. So for example, for space and time, we have this kind of thesis, or this hypothesis, if you will, that in a few years, AI agents are going to be transacting primarily on-chain. If you think about like how far we've come in the last couple years as like seeing bots doing everything from trading to liquidation to more menial things off-chain, that's going to continue to accelerate over the next couple years. And if you have a bot that is managing your finances or booking your travel or just Venmoing your friend for dinner, it needs a way to transact. You can't hand it your credit card, you can't hand it your bank account information because it can't just wait days for settlements, but there's already this amazing technology that's been built to handle this case, and that's blockchain. So at Space and Time, we're like, okay, so this is happening, we see this coming, there's signals everywhere across the industry. What's one thing that these agents are gonna need? Data, right? They're going to need context around what's happening on-chain, what's happening off-chain, and they're going to need it in a way that's verifiable so that they can't mess up those trades or those transactions when they're handling your money. So we're like, okay, this is a very narrow focus for us, right? It's not the whole of our business or the whole of what we satisfy, but it's something that people can grab onto. It's something people can understand, can get excited about, can see as a very real near-term future, right? It's not theoretical, it's coming. And that has been really, really useful for us to be able to communicate our value prop in the AI space. So start with the problem that it's solving and narrow it down as much as you can would be my 2 main points.
You can also use incentives to build a community, right? So we, early days at Akash has got about 500 contributors that contribute to source code, about 30,000 developers in the discourse of the world, I think in our channels. Our early community we built using simple rewards programs, right? So many tools now with crypto especially, to get the top of the funnel, and the people that stick are the ones that are end up building a community, right? So I mean, crypto community is the competitive moat. Like the technology is great, but what gives value to the ecosystem is the community that you build. And the more nodes that actually talk to each other, the stronger the network gets, right? So as community members start communicating with each other and collaborating with each other, it just produces amazing things. Now with Akash, it's a community of different companies that build Akash Network. We work for Overclock Labs, which is one of the largest contributors to Akash Network. Now we have a whole academic community that is contributing quite a lot, is actually increasing. Overclock employs about 20 people, 500 people in total. That means 90% of the contributions come from the outside the core team. And for us, we measure the success as a community and the contributions we get. All the events are run by the community. In fact, we see here half the representation is non-core team, right? So we have formal programs to recruit community members, to train them and whatnot. So we treat community as a first-class function from Overclock Labs. And we have a whole team that manages and that takes this as a priority and works on it.
Sorry, just to follow, I think that's why it's so important, like we were saying earlier too, to align on how you're incentivizing behavior within your community before you start introducing these sort of reward programs. Because otherwise you get a bunch of Sibyls that are just going to dump your token on day one, or you get a bunch of really unhappy community members that are expecting one thing to happen and then that doesn't. So making sure that the core team and all of, everyone who is participating in this design of your incentive and rewards program is really, really aligned, and it's very well narrowed, is really going to help build and scale that community function.
Yeah, I think a very important thing, maybe it's chicken egg thing, that you should have a handle of your product that can actually be used by the community, right? So otherwise, you can only rely on some social quest type of websites and people follow you and then that they get some points, but it's not your core user or core community. You want someone who actually join your community, can actually contribute to whatever that you're building. Like, I quite like Steven's demo this morning about the sub-second ZK stuff. Like in this space also, like so many so many buzzwords as well, like someone who actually built a database that's up second. And I think everyone here from our event today, right, they all have their strong products that's actually showing to the public. That's great. So those are the core things I think projects has, that they actually have something as aligned with their ultimate goal, and then the community can actually start to build it together with them. But yeah, of course, it's a chicken egg thing that you have to heads down for a while to build it.
Yeah, 100% concur on product first or something, or code first or something that people can align on instead of incentivizing to posting memes, right? And it's so important what you do in the early days of community building. That'll determine how your community is built, right? Because if you go the degen route, then you're going to end up with a degen community, which is very, very they don't stick around, right? They go for the next shiny toy.
Yeah, especially this cycle.
Or you can give them more incentives.
Yeah, they just go to the wrong places. But for us, in 2019, Akash did a lot of test nets. I mean, we are known for doing, creating this whole test net culture of incentivized test nets, right? So we wanted to teach how to use the product. So when we would do incentives before we even have a token, right? You can just put a shiny badge. We had these badge systems, like 1, 2, 3-star badges. We call them founder badges. And there's no promise of nothing, right? There's no token at that point. But we had a product, we had a testnet, and so you would go participate in the testnet, and you had to post your transaction hash that you completed a task, and then you would get this badges, some points to get those badges. And people love those badges. People used to put them on their websites and whatnot. Their GitHubs, right? I won this badge from Akash, and so that was a community that was incubated in code and in product. So from there, people started sending us pull requests, and we had engineers that were pretty good. They liked what we were doing, and from there we built a massive community. And so that set the standard. And you saw at our event, at a conference that we had more developers, a lot more developers than non-devs, right? And because that speaks volume to the kind of community we built.
All right, guys. I know we're running up on time, so I'm going to two more things, and then we'll open up for Q&A if we've got any remaining time. First question is, any critical improvements or infrastructure, in your personal opinion, you think is needed kind of over the next 12 to 18 months? And then lastly, how can people get involved in what each of you are building? Any kind of call to action for users, developers, et cetera?
Core infrastructure, I think, for me, is user engagement infrastructure. We just don't have in crypto. I don't know what that looks like, but from a problem set, like sending a notification when something happens. We don't have emails. How do you send notifications in crypto? Recurring payments, I don't know how that works. How do we monitor and observe in a world where we don't have monitoring capabilities or observability capabilities? How do we do all these things that Web2 companies can in Web3? How does the ads infrastructure work? The paid infrastructure that doesn't seem like a scam. There's so much we need from a user engagement infrastructure, and as a marketer, you probably experience quite a lot of this, right? I don't know the answers, but it'll be great for people to do something. We're doing something similar, but that's just going to be for Akash, right? I mean, I don't think we can export that out. Maybe we can, but it doesn't. We're not starting off with the intention of exporting it out to others, but without that, we're not going to succeed, I'm afraid. And how can you get engaged? I mean, I'm Greg Osuri at Twitter. AkashNet _ is the Twitter handle. I mean, Twitter is the most active platform to engage with us. Or discord.akash.network also works.
And your personal one?
Personal Twitter is Greg Osuri, GregOsuri.
Yeah, I would definitely second user engagement, and I would just say user experience as a whole, which I know is a very low-hanging fruit answer from a marketer, but we still have so far to go in Web3, and I think especially in AI blockchain, in order to be competitive with centralized systems, we definitely have to improve the end-to-end experience for users. So definitely hoping to see more of that. Getting involved with Space and Time, join our community. We're at Space and Time DB on Twitter, Discord/Space and Time DB as well. We also just open sourced Proof of SQL, our ZK prover, so we invite community contributions for that. We invite, generalized ZK VMs to integrate it for faster data processing, and DeFi protocols, AI protocols to integrate it for verifiability.
Yeah, I mean, I think the UX piece is really important, where it's just really still it's hard for a developer to build an amazing consumer experience for someone to bring their data in, and I think there's just so much improvement that I think is happening now. The other infrastructure piece that I'd call out is kind of the legal infrastructure. I guess legal and kind of regulatory that's the infrastructure on which an organization and community exists. And I'm based in San Francisco, and I think the US there's a lot of kind of regulatory issues that make it harder to launch a decentralized project. In terms of following Vana and user-owned AI, we're with Vana on Twitter and vana.org. You can also test out or try out our developer docs, which are linked from the website.
Yeah, cool. And I'll actually echo what Evan mentioned earlier, like about AI to help crypto to help AI. I think there's gradually more use cases that we see that can actually beneficially, mutually benefit to each other. Like, crypto was quite important mechanism in the Flux system, right, to help us facilitate decentralized training. But in the other way, we're thinking about recently all this, decentralized compute type of things. I think you're also, Greg, you're also focusing on this, working with one of the professors in Austin. Right, yeah, about the verification stuff, and I mean, AI can also help on this in a way that, compute and algorithms, as they all cost time. There's compute complexities, right? You can actually quantify them and then make them as one of the verification that you can do to this crypto world in a way. So yeah, these are all the things that I think is gonna help the community to grow very, very healthy. Like there are ways that we can anti those evils, right? To trying to make sure that one card is one card, it's not 100 cards virtually. Yeah. So, and in terms of our call to actions, basically we launched our training platform a month ago, and the growth is quite cool. And then we do encourage many of the friends, engineers, or institutional operations. Well, actually there are. So to join us at trend.flock.io to join this movement together to see how we can actually to bring this decentralized AI to many more applications, many more areas. Yeah. Thank you.
Awesome. I think we probably have time for maybe one question or two.
Thanks to the panelists. So in terms of adoption, there are supply side, so suppliers of the compute or developers who supply the model. There's also demand side that includes like protocols who use those models and users that run inferences like query on ChatGPT. So I was wondering how each of you would sequence them. It's very hard to do both demand side and supply side at the same time. So just wondering how you think about that. Thanks.
So what's the question?
So how do you sequence the strategies to optimize adoption on the supply side or demand side?
Yeah, so it's a two-sided marketplace. That means you need both. You need supply and demand, right? But the way I think about it is like walking into a grocery store, right? When you go to Walmart, you want to see the racks full, right? So that means you optimize for supply first, and then and the demand as secondary, right? Or else what happens is when the demand comes, they don't see nothing. And that's bad, right? So incentivizing supply and then optimizing demand is the pattern that we took, right? So of course, with our verification, you had to do in a more controlled manner. That means incentives may not be decentralized when you go live, and that's fine, right? Because you just need one rack full. You don't need a whole warehouse to be full, right? Because nobody's looking at the warehouse; it's just looking for what they want, right?
So, but never optimize, never incentivize demand, then you end up in a situation that's not great. Then people are just using your network to get wrong incentives, right? Yes, chicken or egg problem. I mean, depends on what you're doing. Like in case of like Heliums of the world, they had to go really over incentivize supply because without that there is no network, right? Like, but with GPUs, people need a lot of GPUs, so it's okay. It's okay not to like over optimize for demand because the demand is just will come. But till you hit a point where your conversion rates are like so bad, then you really have to like improve your user experience. That with crypto we face that quite a lot, right? So it's very challenging for non-crypto users to use Akash because they just don't care about installing a wallet, or they just don't have experience of what a wallet and what installing a browser plugin. They had no idea what's going on. It's going to check all your, have access to all the things that you browse, right? And that's scary. So a lot of these problems, I think, like is getting solved, and we're doing a lot of work there. But yeah, incentivize supply, optimize user experience for demand is the pattern we took, but it's different for everybody. I don't think this.
I think it's really easy for a deep-end network to sort of believe that the market is supply constrained and then just build lots of supply, and then it turns out there's actually not that much demand, or maybe the demand is slightly different than the supply that you've matched up. In terms of kind of our path at Vana, we actually ran into a supply problem where we had sold a lot of data. We're collecting data from users, and we're finding that it was actually really hard to get people to offer up their data. I think in the context of data collection, there's very much a monopoly, right? Like only one person can sell Reddit data. Only Reddit can sell Reddit data. Only Amazon can sell Amazon data. So because of that, the data collection market is very much supply constrained, right? If you can actually get 10% of all Amazon purchase data in the US, there are a lot of people, like Target would buy that, many other people would buy that. And so because of that, we sort of get signal and stay quite close to data buyers and make sure, hey, is this actually the data that people need, both for consumer insights and for AI training data, while also building the supply side, since that's really the bottleneck in data collection.
Yeah, I did notice this on Twitter. People talking about in decentralized AI, too many infra, not many applications, right? So yeah, there's a thing there that the demand side isn't that like charming in a way, but the good thing is we focused early, and we focused on our partners where they have companion apps or transaction bots or even the deeping use cases. So yeah, especially in decentralized AI, where you see that too many infras already in this market, that you definitely need to figure out your demand side first, and then that can be your driver to your product in the future.
I think also building for the demand of the future, like I think Akash has done this really well, where like you should basically set the network up for demand like 2 years out or a year out or even 5 years out. And so thinking like, what is that thing that's growing exponentially? And also like, what are the new kinds of applications that we might not expect? Like with the Reddit data DAO, they've created their like user-owned ship posting model, which honestly doesn't seem all that helpful. But now there's a project that's using it to actually be able to simulate a conversation. So you're like, this is what I'm gonna post on Reddit, and then you can see what the AIs would respond, right? And so I think that also listening to those emergent use cases so you can understand where demand might be a few years out is really important as you build both sides of the network.
You're talking about emerging use cases. There's a professor that's working on quantum to put on Akash. So that's,
wow,
7 years out, maybe. Yes. But we are funding it. I mean, I have no idea what that. I'm not anywhere close to. I don't even know anything about quantum, so it makes it at a high level how it works. But
they do quantum. They can be SIBO attack to Akash. I mean, quantum SIBO attack. Wow.
The current stage of our quantum projects is in pre-proposal from an MIT professor, and that's the stage. I don't know what. I mean, if I can get like a arithmetic operation on Akash, I think that's the first step for a quantum computer.
When we do this panel next year, we'll check in on this.
Absolutely. I mean, the proposal will go online very soon. Actually, there's a lot of interesting stuff in the proposal. I was like, wow. I mean, I need to do some
LLM to even understand what the proposal is.
Well, panelists, I want to thank you for your time. Audience, thank you for keeping the volume to a minimum. But Anna, Jiha, Greg, Kat, thank you so much.
Thank you.
Did you see the Anthropic could create a
Hello? Hello? All right, everyone. Is this working? Yeah? Okay. All right. We're now going to have the panel on AI agents and economy. So if my fellow panelists, Ron, Mr. Bodkin, let me grab him. Sorry to interrupt. We need you on stage. All right. Ava isn't joining us today because she's meeting with Jack Ma in London. So, you Feel free to move in, Wrench.
It is.
Yeah, like she's literally meeting with Jack Ma. So I think we
Just
can
tracking
understand
Jack Ma down
why-
is an accomplishment.
Yeah, exactly. So I'm Don. I'm the moderator for the panel. First off, I'd like to thank all the sponsors for putting this event together. Looking forward to chatting with the dais present right now on AI agents and economy. So first, what I'd like each of the panelists to do is spend a minute just talking about who you are and what you're working on, but also, if you'd be so kind as to tell us one of your superpowers, that would be great. I'll go first. So I'm Don. I'm the co-founder and CEO of Nevermind. I'm crypto and Web3 OG, I guess. I co-founded a project back in 2017 called Ocean Protocol, which was one of the first AI and Web3 projects to come out. Subsequently, I'm now have co-founded Nevermind. We're hyper-focused on AI payments. So we have a vision of the world where what we're actually witnessing is the emergence of a wholly new consumer that's going to manifest as trillions of AI agents, and that these agents need a fundamentally new means of payment. They need their own standalone payments protocol. So we're building this decentralized protocol for them. In response is, to be the PayPal of AI, and powering something that we're calling AI commerce. My superpower is the ability to moderate awesome panels.
All right, well, so I'll go next. I'm Ron Bodkin, co-founder of Theoric. My background, I've been working much of my career as an entrepreneur and in AI the last 15 years, whether it be at QuantCast, who was a pioneer in AI and machine learning for ad tech, or started a company, Think Big Analytics, and sold it to Teradata for enterprise AI, then was responsible for applied AI in the CTO office at Google, and then worked at Vector Institute on scaling AI with our sponsors and 500 researchers. Really got drawn to Web3 and the ideals of decentralization and community empowerment, and felt that it was super important that we strike back against big tech. That I felt for many years AI was going to be the defining technology of our lives, and doing it right, doing it in a way where it's community-based is super important. At Theoric, we're really focused on the agent layer. How do you make it so these autonomous agents that have access to data and can take action can coordinate, they can discover each other, you can dynamically have specialized agents working well together. And I think that vision of many agents that are specialized working well together, paying each other, composing, making it easy for discovery and to have trust in what are the right agents, that's the critical challenge and opportunity. So excited to talk more about that. Oh, in terms of superpower, I think I've tended to be a little ahead on technology, sort of seeing a trend and jumping in a little before most people see it. So hopefully that continues here.
Hey everyone, my name is Hwan Soo, co-founder of Exhibits. We're in the business of powering various decentralized compute marketplaces that we all know, with over 65,000 H100 chips that are located across in data centers across North America and Europe. I come from a very traditional economics and finance background. I have a PhD in economics. Used to work as a staff economist when President Obama was in his first term in office during the financial crisis. I was a professor for a long time, and was a head of equities at a large bank in their asset management division. In terms of my superpower, I think I might have the most interesting one here. So I've actually have a track record of having dreams before my friends knew that they were even pregnant, that they would give birth, and including what they would name their child. And I've had that twice in my life.
That's amazing.
I don't know, I can top that. Forecasting pregnancy and it's a tough one to follow. I'm Wrench. Thank you all for taking the time and joining our panel. I'm the co-founder of Giza. At Giza, we build verifiable agents. Verifiable means tamper-proof, reliable, scalable, trustworthy inferences, and agents take these inferences and they convert them into on-chain actions. The idea being, how do we reduce cognitive load of Web3 users and how do we expand the capabilities of Web3 protocols. My superpower is more towards organizational cybernetics. I have a big passion of putting together people, institutions, organizations who take on complex challenges and come on top on the other side. My background is more on product. I was head of product at Johnson & Johnson for 5 years before founding Giza. I was in charge of releasing FIFA 2018 to the world, which maybe some of you have played. And before that, I was head of product at Sony Electronics.
Very good. All right, there's a number of themes that I want to try and cover today, including how AI agents will impact current economies and their overall effect on global commerce, how constraints like hardware on the GPU side will impact the economics of agents themselves, what trust looks like in the age of agentic AI, and then potentially, if we have time, might get into some of the risks around the manifestation of agentic AI. But first, I'd like to get everybody's interpretation of our AI agent future, what we believe will be their primary economic contribution, and then considering where we are now, how do we get to that future state? So Ron, I'll pass it to you.
Sure. I mean, I think we're seeing such an incredible pace of improvement in the underlying AI that I expect that that's going to continue unabated through the rest of this decade. That we'll have rapid improvements in the algorithms, in the hardware, and increasing investment, so that getting 1 million times more effective compute is likely this decade. And what that's going to mean, lots of interesting things we'll talk about, but how does it land? Well, what it's landing is the capabilities of AI is getting to be so powerful that we're going to have increasingly autonomous agents that take actions. And in fact, I believe that by the end of this decade, a majority of knowledge work will be done by AI rather than people, right? So increasingly, your coworkers will be agents. The people, the team that you manage will be agents. And for increasingly the things you do at home in your life, you will have agents available to execute and take advantage of that, right? So if today we're just starting to see this take off in terms of it's getting more feasible to have agents that might build software for you, it's getting more feasible to analyze on-chain data, analyze social data, to say, hey, is this a good project? Should I invest in it? Should I participate in this ecosystem? These types of use cases will quickly turn into more sophisticated ones where instead of just doing analysis, we'll get closed loops of why don't I also experiment up front and then take action to really drive an AI-driven business, right? So I think that's where it's moving over the next few years. And I think we have a big opportunity ahead of us, but it's also incredibly important that we, as a decentralized ecosystem, come together because we're not the only ones who see this future, right? We also have what I would call the vision of the billionaires, which is they will control the agent that you rely on, and they will extract more and more from you as you use their one agent in your business or in your home life.
So as an economist, when I hear about AI agents, I'm thinking, what's very interesting is in the last 10 years, the meta trend in the world has been that there's been this tendency toward disintermediation, right? So you can think of YouTube from a very large network used to just get content delivered by one source to now everyone can create their own content, you can watch them, right? And a lot of this DIY movement, the fact that Web3 exists, it's really an offshoot of this disintermediated world of decentralization. And that would certainly argue against an economic model that's dominated by agents, which is really, that's the quintessential intermediary. And when we talk about agency cost, that's primarily rooted in the fact that it's very hard for you to have a perfect alignment of incentives between an agent and a principal. But you can think of AI agents as sort of the virtual model where you can literally minimize that misalignment in incentives. But of course, that's also predicated on who ends up being the ultimate owners of those agents. You can think of a few owning just few agents that's being leased out to individuals versus each person creating and owning their own agents outright 100%. And I think it's a big technical and economic question, which of the model ends up prevailing at the end of the day. So it seems like there are some really big questions that needs to be answered before we can really fully commit and imagine a world of a fully functioning, flourishing AI agent economy.
I just wonder if, you know, YouTube is any less of an intermediary than the old TV networks. It's a different kind of intermediary, but also a really powerful one.
Well, I mean, I don't know if you guys ever heard of Terrence Howard, the Joe Rogan podcast. He's been on that, and he has crazy theories like 1 × 1 is 2. Imagine having someone like that with that kind of platform in the old world. It would never happen, right? It would never happen. So, I mean, I still think YouTube is hugely. I mean, that's to me is really the archetypical disintermediated media platform. And to me, Terrence Howard is sort of like the Dogecoin of that world. Like they know it's bullshit, right? But they're happy to make a mockery of that content and see how many views they get. And the fact is, it's been very successful, right? And that's why they continue to have him, because it convinces enough people to watch him.
We could debate that.
Okay.
That might just be bad.
You want to dive deeper into
I don't know.
Terrence Howard, the right rabbit hole? It's a deep one. But yeah, echoing everything the panelists also said. I think going back to like organization cybernetics and agents it's going to empower people to pioneer at a pace that has never been before, because you're not going to need 100 employees to build something paradigm shifting. You're going to need like 2-3 agents that can basically compensate each other. And I think that is going to have a huge impact on how economy evolves and like the unicorns that we create and the incredible products that we create.
All right, I'm going to kind of touch on what we were just discussing. I think within a closed source application of AI agents, it's pretty easy to understand like who's going to own them and how those are going to be commercialized. But what about in the open source space? And how does AI trustworthiness and open source go together? So you everybody alluded to the fact that there's AI agents that are coming. We're already starting to see this manifest in the form of Devin from Cognition, which is for anybody that's out there that doesn't know what Devin is, it's actually a developer, an artificial developer. It's not a co-pilot. You give it a task, it's supposed to perform said task and give you an adequate response. So with these, these synthetic developers are obviously going to use the code that preceded them. And we have conventions in place to kind of govern open source community and what good practice is. It's loosely enforced, and we rely on ethical reuse of the technology with proper attribution, et cetera. But so the question I have is, how do we safeguard technology creation, in particular as it relates to open source technology creation, when we have agents, AI agents in mind? If the tech is developed by a synthetic developer, who actually owns it, especially when we get to a state of somewhat autonomous nature of these agents? And then a bit more esoteric, how does this impact competition or non-competition for that matter, right? The US just struck down a federal law on non-competition. So if you have an agent that works for you and then is going to potentially get farmed out with a competitor of yours, how do we actually, is that a threat? How do we mitigate that threat? If your knowledge corpus has been used in training that agent to perform for you, what are the limitations on that for your competition, et cetera? Whoever wants to go first, feel free.
Well, I mean, yeah, I think there are some really big unanswered questions, and this is part of the reason why I'm still sort of stuck in the beginning of whether or not this is even possible. Because when you think about ownership, for example, ownership comes control, right, monetization, and responsibility. So if you talk to any agents that are either in the business of security brokering or selling life insurance policies, anything like that, they'll tell you they have general liability insurance. Okay, so if there's a technical glitch that your AI agent ends up harming another agent or another person, what sort of insurance policy should exist to protect you against this? What is the limit to how much you can delegate tasks? And you sort of want to tread on this fine balance of giving them enough autonomy so that it's useful, but also within limits, and for it to behave in a way that's fully in line with your expectations. And if it's artificially it's AI trained, and I don't think we've quite figured out what the limits are and the parameters should be.
So we've got to insure our agents.
Well, so again, and that goes in hand with, how much do you want to delegate to your agent to do what, right? And on the one side, you want to give them as much autonomy as possible so that it does a lot of useful things for you. You don't want it to just be a button pusher that just executes and getting your flight ticket because it's already confirmed with you the itinerary. It just has to make a transaction. Well, that's okay. I don't know if that's really revolutionary as what a digital agent can do for you, but perhaps you wanted to, within very few guidelines, trade your mutual fund portfolio, right? So if you talk to a security agent that doesn't have full discretionary trading authority from you, they're really limited to executing on price as long as you've given them the maximum price to buy an asset and the security. But in terms of timing, it's up to them to figure that out, okay? But of course, you would want your AI agent to do a lot more than that, right? You tell them, I want to make sure my beta exposure is limited to X. Just maximize a Sharpe ratio and make sure you don't have a maximum drawdown of 10% in the portfolio, and then it's up to you. Pick the asset classes. It's up to you to how you concentrate an individual stock, and that's quite wide. But there are hedge fund managers that lose job that still deliver within that parameter, but because it's no worse than the next guy, the guy next door. So a lot of questions around that.
Yeah. Ron, maybe, there's been a lot of talk in previous panels around data attribution, how AI agents in particular, or in this case, they were talking more on the models and the training side. This seems like a pretty pragmatic bunch up here. Is anybody really going to care about that?
I think what really is going to matter the most to people is the ability to access useful capabilities, right? So the data that's super valuable, and what OpenAI is doing all of their closed deals, secret deals around is access to data at runtime, basically for agents, right? How can I, if I want to trade, how can I get live social data? How can I get live index blockchain data? How can I have the insight the agent needs in order to do a good job, right? So I think there's going to be a healthy market for data that can make real-time decisions. The good thing about that too is that kind of real-time data loses its value very quickly, right? So unlike a training corpus where it's very hard, somebody buys it once and then why would they keep paying for it? They could archive it and just keep using it, right? For real-time data to make decisions, it's super important that you have a live market. So I think there'll be healthy markets for the things that are sort of valuable for agents to do at real time. But also I think a super important thing is going to be how do you assess that the agent does a good job, right? So I think your point was right that, hey, it's not enough to say, did I meet some criteria? I, as the user, want to know that this is the best agent for my needs, right? What do I care about? How can I give feedback, maybe get incentives to say it was a high-quality agent that's serving my needs well? How can I ultimately have a system that I rely on to say, hey, I'm going to do my best job to pick the agents that are important for this need or that need? I think that's where there's the big opportunity for us, and where the big risk is that, however disintermediate they may be, as long as you have a monopolist that sort of is controlling the rails and deciding what to use, it's going to be hard for users to have a lot of confidence in an agent like that, right? Surveillance capitalist controls it for their purposes. So I think it's super important that you have it be one that is, aligned with the needs and the incentive of the user. But I think in that circumstance, people will pay for data, they'll pay for models, if it's producing agents that are delivering what they need.
All right, I'm going to come back to the marketplace in a minute, but I want to get Wrench involved. In a world where AI agents are first-class citizens, at least from an economic point of view, how do we establish reputation and develop trust around an agent that might be entirely ephemeral? And what takeaways, if any, are there from the Web3 space that can be applied to this progression?
Yeah, I think that's a very good question. I think this is where slowly, we talked a little bit about trust, we talked a little about traceability. This is where the value of verifiability comes into play, at least from our side. And I see the importance of verifiability increasing as these agents take more and more complex tasks on behalf of users or on behalf of humans, and they manage more and more funds in the form of Web3. I think verifiability brings a couple of different things, at least to the agents part. From a fundamental perspective, there needs to be persistent intelligence. Persistent intelligence means that you're able to trust the agent is going to act the way it's supposed to act when they are taking on complex tasks. Without persistent intelligence, there's no verifiable agents, and without verifiable agents, there's no trustworthy actors that you can delegate things to. From a consumer perspective, between the user who's consuming the agent and the developer who's building the agent, there needs to be some kind of a trust mechanism. The user needs to have the trust that the model or the agent that is taking actions on behalf of themselves, they're not going to be tailored with, or they're not going to be interpreted with. And I think finally, in terms of scalability and composability, verifiability can be the guiding entry point, where if everything is verifiable, you can basically compose agents in a much more efficient way. I think those are the things that I'm looking towards.
Yeah, I don't think verifiability is nearly enough, because it's not just enough to compute a result accurately, right? I can take Llama 3 and verify that I correctly computed a hallucination and it wasn't useful, right? Yeah. So instead, what I need to know end-to-end, essentially proof of alignment. Is this thing actually aligned with me? Is it delivering what I need? Right. Unfortunately, nobody knows how to prove alignment, right? Yeah. So instead, we're stuck with what are the mechanisms we can use in order to establish reputation, which is, obviously a dishonest broker that's extracting MEV from your trades, if it's in an agent, is just as problematic as if it's any other intermediary, right? But, how do you assess the end-to-end quality of the agent? I think, the best thing we've seen so far is community feedback and reputation, but being brought on chain.
I think it's also a fair point. I think also the doc managed to refer to it as well, having verifiability and some kind of benchmark of performance where you have this clarity that, hey, the results are what it's supposed to be and it's computed the way it's supposed to be computed. I think that creates an end-to-end pipeline that can be trust minimized, not trustless, but trust minimized.
I would even go to say, I think depending on the value and the risk of abuse, reputation may be enough rather than paying a heavy premium in terms of a high overhead way of proving computation, but it's going to vary depending on the use case. Yeah. If you're securing $1 billion TVL vault, you're going to want the highest order of security possible. But if you're summarizing the news, you may not need to pay a big overhead for verifiable computation.
Of course. And I think that's why, in terms of scaling, verifiability plays a role, because going back to your $1 billion TVL vault, you want the security. But if you're typing 5 best restaurants in Brussels, no one gives a shit about it. So I think it depends on the use case, and if you're scaling towards financial use cases, I think that's where there's true value in verifiability.
How soon, just related to that question from your front, because I know you guys are offering a centralized service to decentralized counterparties. So specifically with exhibits, do you guys give a shit about the verifiability of that provider's capabilities, or are you just saying, we're just a broker for the, you know, the hardware? What you do with it is up to you.
I mean, so for us, we have to, I mean, because cloud computing is a very mature, established business, which means customers have, you know, very clear expectations of what they expect from service and product. So we have to follow that to the T, you know, whatever is the acceptable practice in the marketplace. So we certainly don't, you know, verifiability is not the top priority in our SLA, or when our customers come and asking for, you know, what sort of T3 data center reliability and power capability we can deliver to them. So I guess the short answer is no, not at the level that, you know, these folks are struggling with every day.
Right. Ron, you touch on AI agent marketplaces. Wrench, you alluded to it as well. There's a lot of talk around the emergence of AI agentic marketplaces. You know, at least from a commercial point of view, there's not really been much that's manifested at this point. So a question I have is, what's it going to take for these to emerge? What will be, you know, the catalyst for their emergence? What kind of, you know, signaling will we need in order to leverage marketplaces efficiently, especially decentralized ones? You know, I think there has been an allusion to a marketplace being the aggregator and providing that trust mechanism, at least to a degree, for those that are going to consume the services, but in a decentralized capacity, that becomes quite difficult. So I'm just wondering, because you guys also at Theoric are quite focused on the marketplace angle, what kind of thoughts you've given to this?
Yeah, I mean, we're building a marketplace and a protocol associated, and, you know, I think, you know, we believe that there's huge advantages by having community feedback, by having it so that it's easy for developers to build specialized agents that can work with each other. That really is going to kickstart an evolution towards, you know, a rich marketplace. Likewise, we think, you know, having the ability so that you don't necessarily have to be an expert programmer, but you simply can be an expert in a domain and leverage some building blocks to create agents for your own purpose for a thing that you know how to do well. So think about sort of taking a flow you already know how to do, but it's tedious inside of a chatbot, and say, how do I automate that in a way that it's available to others, right? And how can I earn from that, right? And that's where I think, one, the models have gotten so much better, even than, you know, like last year, if you were using GPT-4, you know, it was cool for demos, but it was so slow and so expensive and limited that it was very hard to scale that and really rely on it. I mean, it's changed that now you've got models that are fast, reliable, and affordable, and are starting to significantly improve on that quality, so you can get agents that you really rely on, right? So combine that with having a marketplace and then having the advantages of using tokens to incentivize so anyone can benefit from creating a great agent and users can really seamlessly interact. I think it makes crypto the perfect place to launch agent marketplaces, but it won't be limited to crypto use cases. If that's the first use cases, I think we're going to see a much broader set of use cases come online as more people realize this is the place to get great agents.
Anybody else?
Yeah, I think in terms of a marketplace, I think in terms of like the supply, Ron pointed out very straightforward mechanisms that you need to put in place. You know, you need to have an agent that's easy to develop, you need to have great DevRel, you need to have docs, all those things. I think in terms of like supply of, especially for like the Web3 part, we need to come to a realization that everything we develop in Web3 is super complex to use. And that's what we were talking before this event as well. That's why in every event you go to, you see the same type of people talking about the same type of things, because we still address the same type of audience. On one side, you have super ideological people who has been, you know, decentralization maxis from the very first moment, who's able to forego of like the shortcomings of terrible UX and oversaturation of information. And on the other side, you have basically volatility chasers. As long as we don't build, products that reduces complexity of the current decentralized applications, we're not going to get real usage, and I don't see like real use cases being developed in Web3 that goes beyond DeFi and speculation. I think this is where like agents have a big role to play. I think agents can reduce complexity of the current Web3 applications that we have, opening the barrier for massive participation, and I think that can invoke like a huge demand on the marketplace side. Again, this is like on the Web3 frame we're looking at things.
You front ran my last question. I was basically going to ask, exactly that. If you look at the AI schedule this week, it's basically the same sets of panelists talking to the same groups of people. And just to, Wrench talked about this. I'd like to give you two both an opportunity to also talk about it. How do we get out of this incestuous cycle that we seem to continually propagate in the Web3 space, where we're just preaching to the same converts? What do we need to do beyond, I think, just purely on the UX front to start attracting attention, from, for lack of a better term, the non-believers in what we're doing? Any thoughts?
I think there's a huge benefit of the community and how there's so many complementary projects around AI and Web3, right? I think that's a strength of Web3, is that protocols are not trying to dominate the universe, right? No sooner did Microsoft and OpenAI announce a partnership than immediately they're going to war, and everyone's worried that NVIDIA is coming to eat their lunch. So in the Web2 world, it's an absolute, shark's tank, right, of people trying to kill each other. Whereas I think actually in Web3, there's more ideals of building great open source, integrating. The next step is actually, in my mind, a lot of it is setting standards so that you have, clarity and ways for things to interoperate. And in the meanwhile, it's the serious builders who are, actually shipping and getting usage, right? I think it's by these conversations, we're starting to get awareness and excitement, right? So I think it's there's a big opportunity that the retail community is just starting to be aware that there's a big opportunity here, and we have a chance to build the standards and to ship the products that actually deliver. And there's no doubt UX needs to be high quality. It needs to be a good way of working. I think that you can have a lot of value from building on crypto rails without having to put it in a person's face and be like, you have to do everything fully decentralized or you're not qualified to be part of the community, right? Like, it turns out a lot more people are using Coinbase and Binance than are using MetaMask to manage crypto, and that's okay, right? Like, we should meet people where they're at and create experiences that are great for them to onboard.
Yeah, agreed. I think there's a pragmatism to this. Exhibits is a clear example of that pragmatism, I think, right?
Yeah, and I think, so my team, we really struggle with like two very big questions. So in our mind, the first question is AI poised to remain big and few versus small and many? We've all seen sort of this astronomical rise of NVIDIA because they're capturing some 90% of the actual monetization of AI space right now, right? And it's really related to this question, and sort of the one that's immediately related to this is how durable is this NVIDIA's monopoly over the long run? In the software space, you've had Google the past 20 years. No one's done better. No one's done search better than Google, and they've sort of had that space. Is NVIDIA poised to be like Google in the hardware space? And I think that's a very big open question mark. And I think the answer to that has an intimate implication to sort of the flourishing AI agent economy and sort of what role Web3 can play to bring in more new converts into the space. And we don't quite have an answer, but I think some interesting observations is, one, we're hearing from big tech guys that actually have access to a large pool of capital that they've yet to see diminishing marginal returns to scale. When they have 350 to 1 million chips and they have 10 trillion parameters, those AIs are still surprising them with much better capabilities. And I had this discussion with my co-founder just minutes before. You can only deduce your way into understanding the universe so much with existing data, right? So think about like the highest level of cognitive ability for humans. That's to create new laws of physics. And that's only done through experimenting and engaging with the physical world, right? If you just have a virtual world that exists in your mind of only what you know, you still have a partial understanding of how the universe works. And that requires more advancements in robotics, right? AI that actually needs to be able to engage and generate its own data. And I think that sort of pushes in favor to a lot of value still remaining in hardware for the foreseeable future. But it's a big open question mark, but I think just given the sheer capital intensity of what's required and building out this multimodality, and when you also layer in verification with the added computational load, they're very expensive. So maybe we find the middle ground where small makes a lot more sense, and we start to see more of these AI agent economies flourish in a more feasible way.
I think with that, we can adjourn the panel. Thank you, everybody.
Great.
Thank you.
Thanks.
Thank you. Thank you all the panelists. So yeah, next up we're actually gonna announce some of our hackathon and all the Flock training frame task winners, which we picked one of them who is very strong in the recent tasks, actually from Foundry. So he couldn't make it himself here today, so that's why we did a video with him for this hackathon winner announcement. We basically had this hackathon with Akash together pre the event. Basically, someone who can use Akash and then run decentralizedly the algorithms, and then the best ones will be picked out. And then turns out Jerry was quite strong in many of the tasks, and we did an interview with him, and then basically he'll give us some tricks about how he always, kind of win the hackathons. Do you mind? Yeah.
Yeah, so basically this will be a pretty short interview, for you to share some experience on the, Flock.io training arena, AI arena platform. Especially I think you wins task 3, task 4. Also, I think you are within the top 3 for task 5, our based on Chen Summer hackathon as well. So I think there will definitely be a lot of other training notes they would like to hear, like how you achieve that, what kind of strategy they can learn, all this stuff. I think before we kick off, could you give the audience a quick introduction about yourself?
All right. Thank you, Nick. So I'm Jerry. I am an AI ML engineer at Foundry, and Foundry, as you know, is pretty well known in the crypto space. And actually, they own the #1 Bitcoin mining pool in the world. Our mission is to support decentralized infrastructure. I joined Foundry during the second week of March, not too long ago, to support our decentralized AI efforts. We're looking into protocols like tensor, Flock, Akash, and a couple of others as well. I come from an ML background. A little bit about myself. I have a master's in data science from Northeastern University. Prior to working at Foundry, I worked as a deep learning framework engineer at Intel, where I worked on TensorFlow development and optimizations on CPUs. And yeah, ever since joining Foundry, I've been working on Flock. And prior to Flock, I didn't have that much experience with LLMs, so it has been a huge learning experience for me as well, just involving myself in Flock. I loved the innovativeness of the tasks, especially with the different themes and everything. And the UI is amazing as well. And I've read a couple of the Flock white papers as well, and I'm pretty cautiously optimistic about federated learning and really looking forward to it.
Yeah. Thanks for the kind comment here. Also, I think it seems like you actually have a pretty solid machine learning background. When you were at Intel, you play around a lot of hardware stuff, right?
Yeah.
I think you also mentioned that you don't have too much experience with LLM previously.
Yeah.
I think that actually applies to a lot of like machine learning engineer, data scientists on our platform, right? They have played around with more like traditional ML previously, like, those kind of random forests, XGBoost, stuff like that, right?
Yes.
But many of people don't actually have, experience with LLM, especially the different kind of, LLM fine-tuning techniques, right? Do you mind like sharing like, how you learn all this, like what kind of resources you have been used to, let's say like, get familiar with the fine-tuning journey?
Of course. So my main learning was just based on the tasks itself, just jumping into the task. Since I have been participating on Flock from the very first task, I was able to look at your testnet training quick start node and then apply myself and then understand what each module does, and basically understand how what the input does to the LLM and how it needs to be formatted for the LLM to do well. A couple of YouTube videos here and there, and I think I was all good to go. And especially there are some tasks which were a bit challenging. For example, task 5 did have data generation component as well, which I was not familiar with, but thankfully with time I was able to get the hang of it, and we were able to make some good progress.
Oh, it's actually pretty glad to hear like, the training node quick start we developed can actually be an actual, quick start for, for experienced machine learning engineer. So if my understanding is correctly, so basically you start from that, but let's say within the task, after a couple of tasks, you actually start to, modify that script and, convert it to something different, right? Yeah.
Yes, of course, yeah. I started, I still do use most of the modules of your training quick start. For example, the data loader as well as the collator and stuff. But the fine tuning wise, I set my own parameters and I introduced a couple of techniques as well, which helped me, be a bit ahead of the competition.
Yeah, I think really happy to hear that, because I think we always want to, start with something that's at least my, hope, right? We start with something easier for people to understand what's going on, and for any experienced machine learning engineer like you, right? You can, easily find out more resources online and start to, modify things, testing out different, training techniques, different, data strategies, stuff like that. I think, I really want to, jump in the next chapter in this interview is basically other MLEs are actually curious, like how you win everything, right? Like, especially for task 5, I think it's a very challenging one, because this is actually the first task that, Flock is not providing enough training data for everyone to train, right? Because that's actually the target of this platform as well. Like, there won't, in real life scenario, right, there won't be enough training data for the model to learn, right? In such like, how can we generate more data, right? And also, besides the data training itself, like as you mentioned previously, you have implemented some training techniques. I think QLoRa is something we put in the quick start script, and maybe you can also share a bit, like, what kind of technique you have been implemented.
Yes.
I think we can first start with the data strategy. I think that's, the most challenging part.
Yeah.
So
task 5 was the forecaster documents, right?
Yeah.
If I remember correctly, the max number of parameters for that was 7 billion, right?
Yes.
So before I went into the data generation, I first played around with the base models first to get an understanding of which actually was doing well. So for this task, I specifically used Qwen 1.5 as the base model. Right off the bat, there are a couple of options that I noticed that you can use with the 7 billion parameter model. There's Qwen 2, Mistral, Zephyr. All of these models have 7 billion parameter versions. I tried Qwen 2 as well, Mistral, and 1.5 as the base models, which were giving pretty similar results. So I just went ahead with Qwen 1.5 because I've used them in previous tasks as well. Of course, Qwen does have its own benefits as well. Like it's trained on a lot of Chinese data as well and has very good multimodal capabilities. But for this task, that was not required. So any of the 7 billion models were good to go. Since this task did involve generating our own data from Firecaster documents, it was extremely vital to make sure that our models don't overfit on the sample training data first. So, which I observed most of the contestants were doing. So increasing the parameters like number of epochs and learning rate, after a certain point, it would just start overfitting the training data heavily. And the key is to find, the balance between hyperparameter tuning as well as introducing regularization, I feel. So I felt using, a regularization method would be good because in that way, the model would be able to generalize much better than just, learning the training data. So for that, I use techniques like weight decay, which is essentially L2 regularization, and it adds penalty on the loss function. I just don't want to go too technical into it. But apart from that, I used early stopping as well. And I felt early stopping helped me a lot because what early stopping does is it stops the training as soon as the loss was very similar for a couple of amount of steps. So this made sure that the model doesn't, learn the training data too much. And as for the data generation, I did not use a very complicated approach, mainly because I'm not, in any way an expert in data generation. Basically, what I did was I divided all the documents to paragraphs based on headings and the topic they talked about, and then I used GPT-4 to generate conversation based on each paragraphs. So this way, the model would be exposed to the entire list of documents. And I think that was basically my approach. And after you do this, there's some amount of data cleaning as well. And most importantly, we need to get all the data into the right format, especially while data generation, so that the model actually accepts. Because I spent more time getting them into the conversation format. Because whenever you train, even if one data point goes away from that format, the training stops and you cannot, train the data. So there was some amount of data engineering involved as well.
Yes, just like all old days, whatever XGBoost based, classification challenger, right? Like we always spend more time in data cleaning than the, actual training.
That's true.
I think that's definitely, highly expected in all different kind of, LLM task and, machine learning task, right? Actually, I'm curious, like, you mentioned like you implement some, regularization techniques, right? Have you done like anything like just relevant to like QLoRa? Like, for example, like have you try like LoRa, or have you like, changed the, let's say maybe the target module, some hyperparameter of LoRa? I think the rank alpha stuff, right? They are also somehow used to mitigate the overfitting, right?
Yes, I did change the rank as well as the dropout, LoRa dropout as well a little bit. But it did give a much better result. But you don't exactly know which one is the one that gave you the edge, because the final validation data set was done after when the final validation set was made. So I didn't have a lot of time to experiment because I don't have, the validation, the training set the validation set which covers the entire document. So as far as my knowledge went, I did use a couple of methods, but I didn't know which method, actually, completely worked. So I'm guessing each one had, their own contribution to the model being able to generalize much better.
Oh, okay, understood. So overall, like, do you believe, like, for this, like, at least for task 5, right? Like, data generation is actually like more important than hyperparameter tuning?
Of course, yes. I would I would say data generation is very important, especially for this task and the future tasks as well. I think even task 6 needs some amount of data generation, right? So
Yeah, I think task 6 is a query parser, right? For
yes, yes. So I believe that if you if you tune the model too much, that's not going to do you any good, because you need the model to be exposed to other kind of data as well. Because I think in future tasks as well as in real world, what you train the model on and what it is exposed to most of the time are completely different. So as much as data that you can get is better for the model. Either you can generate the data or augment the data, whichever way is, um, it's always better for the model. And I think those models will do much better.
Yeah, I think that's at least in my understanding, I think that's a very popular techniques that everyone in the industry is actually implementing, right? Like you use those very like large, powerful, expensive, proprietary model, right? Proprietary LLM to help generate the data set that, within certain domain, right? And you can use the data to train actually like a very like small model to achieve like on par performance. That's the beauty of fine tuning. So I'm actually curious about like one thing. Like I'm not sure whether you have tried this. So I know you like go for like the 7 billion model, like straightforward, right? Have you tried like if let's say given the fixed data set, have you tried it with a smaller model and see like how it performs?
I did try with Gemma 6B, 6 billion, but in my experience, when I used Gemma for most of the tasks, it didn't do as good as the other models. I'm not sure exactly why that is happening, but I did try Gemma 6B and I tried.
I think Gemma only have like 2 billion and 7 billion, right? Have you tried like the smaller one?
Oh yeah, maybe. I'm not sure about that. Okay. I think no. As far as I know, other than this, I would have probably tried Quen, but I didn't go too much into smaller models. I went ahead with the bigger models as well because I thought that might be, giving me an edge over the other smaller models.
Got it. So I think one takeaway is that you at least for you personally, you believe like a QN is the first go-to open source model you would apply like for different tasks.
Yeah.
Yeah, I think that's also what I heard like from a lot of like LM community and Reddit thread, right? They are talking that okay, maybe this model is the first thing like you should try. Like I think it has a pretty good like reputation among like open source model.
Yes. Yeah.
Yeah. I think we have talked a lot, and I think there are a lot of like information here. I think it will definitely be like very helpful like for other machine learning engineers on the platform to learn from you, especially you provide a go-to solution, what kind of base model you should try first, and also like data generation using like proprietary model, right? Also like some hyperparameter tuning, like to prevent overfitting on the training data set. I think that all these rules, they definitely directly apply to task 6 and task 7 as well. This is really helpful. Yeah, I think that's all the technical part like we want to discuss here.
Okay.
I think maybe at the end of this interview, like Jerry, like as a because you have worked as a machine learning engineer before, like now you enter into the decentralized space just in 2-3 weeks ago, right? So pretty new to this place, right? That's also when we designed the AI arena, right? That's also like a flux concern because in Web3 industry, right, there aren't enough experienced machine learning guy in this whole space, right? So when I was designing the whole AI arena workflow or user flow, right? I was thinking that okay, we want to make sure like anyone from the Web2, right, from the traditional machine learning background, large language model background can easily participate in AI arena, right?
Yeah.
Based on your experience, do you think it's easier for you to participate and in your whatever, in your opinion, right, which part, right, is not that straightforward?
Okay, so basically, I would have to give hats off to the Flock team for the training start node quick start, because I learned a lot from that, and now I see that it's extremely automated. The whole process is automated. The user needs to change only a couple of parameters, but the whole thing is automated, which I think is amazing. And the model itself is tuned quite well. So right off the bat, if you just run the script, you'll probably get a very good score right then. The trick after that is to use different other techniques to do, to increase your odds. I would, if I was, starting from the beginning, I would first look into where the model is being trained and where the training arguments is there, play around that a little bit to understand which parameters are actually making a difference and which aren't. And once that is done, I wouldn't change that too much, maybe here and there a little bit. But once that is done, I would, actually go through the data set itself and then try to understand like how big is the data set. For example, the first few tasks, there were almost 10,000 points, 10,000, almost 9,877 some points. So in that kind of data, the chances of your model overfitting would be much lesser because huge amount of data. But for tasks like task 5, there was much lesser data, right? It was less than 500 or 300. So the chances of your model like learning the data too well is very high. So I would suggest, machine learning engineers to actually understand the data, the size of the data, and then make their strategies according to that.
Yeah, I think that's a really, really solid like suggestion on the how to win. Yeah, I think another question from me is that do you think overall the whole like user flow as a training node, right? How comfortable do you feel? Like do you feel like you need to learn a lot of stuff besides the LLM training? Do you feel like okay, you need to learn a lot of blockchain stuff to get engaged as a training node, or like for all like MLE like you only need to put focus on the actual machine learning part?
I think like when I saw the training quick start guide, I saw the recent version as well. So I noticed that almost everything was automated, from getting the task as well as training the model and then uploading it to GitHub as well. That's amazing, because in the first few tasks, there were different scripts for each, right? And I used to run them differently. That, of course, that did help me understand it more. But this task is way faster. The present version is way faster. Apart from that, I would say like I mostly concentrated on just, training the models and, playing around with the parameters and stuff like that. I think the code is pretty straightforward and understandable. And I think if we spend a couple of hours, I think anyone can get a hang of it. And
it's great to hear that, because I think one thing like we are worried about is that, since we're doing this in a decentralized way, we are, Web3 AI like startup on this field, right? I'm constantly worried about that, we have to require people to know too much about like Web3 and blockchain, right? This may actually raise the barrier for MLEs from Web2 industry like you to join the AI arena, right? I'm really glad to hear that. Okay, just put focus on the actual LLM machine learning stuff. You don't need to worry about like the blockchain stuff, and you can join like AI arena very easily.
That's true, because I don't have much experience in blockchain, because prior to this, I was from the hardware industry. And even now, I'm no way an expert, but I did read I read the 3 of your white papers, which did help me understand a lot of what is going on and what is yet to come, which gave me, a
very touching sharing. I focus a lot on it. So yeah, so that's one of our hackathon winner who always contributing to this decentralized AI space. And next up, we have Ato, who actually is going to demonstrate for both Ato and Mohammed. So great. I'll leave this space to you.
Hello, my name is Ato. I presented earlier in the day, but I come from like a AI and reinforcement learning background, and I want to talk about GPU EVM by Gatling X, which is sort of what we're working on, which provides a capability for RL agents to have self-evolving capabilities through reinforcement learning. So at Gatling X, we're really interested in building self-evolving AI agent systems where you give it this simulator, which is the EVM, and you want the RL agent to figure out by itself how to achieve a certain objective that you define as a reward function, and then let it just play by itself and figure it out on its own. And just to give you some background into like reinforcement learning, so reinforcement learning is a paradigm of machine learning where you get RL agents, you spawn like, multiple instances, millions of instances of RL agents in a particular simulation environment, and then let them go and figure it out on its own based on some set of values that you want the RL agent to figure out. So this is an example of running reinforcement learning with Pokemon, where you just have like lots of parallel universes of these RL agents figuring out how to play Pokemon in parallel, and they eventually sort of learn from each other's experiences, and you accumulate all of these experiences across multiple agents to create a superhuman RL agent. And the intersection that we're really interested in is the intersection between reinforcement learning and hacking in particular. I think that's sort of the killer use case that we think we are uniquely poised to solve. So you can make this kind of equivalence between, games that were solved like Go, StarCraft, Dota, et cetera, and really apply a lot of those same techniques into hacking protocols and penetration testing effectively. And the way you make this equivalence is by saying, okay, in AlphaGo, where like the state space of the search tree is really, really big and more than the number of atoms in the universe, what you want to do is, given the board state, how do you find a sequence of moves such that you win against the opponent? The equivalent here in sort of smart contract hacking is, given the state of a particular contract, how do you get it to checkmate, which is, where you steal the money or sort of violate some set of properties that the contract should find. And reinforcement learning is really interesting because it's the only known type of machine learning technique where it can find novel vulnerabilities that wasn't in, or like novel set of moves that wasn't in the data set. So if you look back to stuff like AlphaGo, there's this famous thing called move 37, which is a move that AlphaGo, the AI agent, discovered that was not in the data set. All the sort of professional Go players thought the AI was bugging out, but in reality, that was a novel move that was never seen before amongst human experts that won AlphaGo the game. And so to enable this self-evolution AI and these reinforcement learning systems, we've developed this infrastructure called GPU EVM, which is the fastest EVM implementation in the world by around 100x. So this is faster, even sort of normalized to a single EVM execution. So it's got superior unit economics, and it's highly scalable because you sort of unlock this 100 execution by putting the EVM computations on the GPU instead of the CPU. So if you look at sort of all existing EVM systems, they're running on typically on a single core of a CPU. A CPU typically has 16 cores, whereas a GPU, you have around 10,000 GPU cores. Each of them are slower than one individual CPU core, but together and by sort of massively parallelizing and running lots of instances of the EVM simultaneously, you get this sort of obscene speed up versus CPU-based EVMs. And the reason why GPU EVM and sort of self-evolution of RL intersect is because in the reinforcement learning community, it is effectively consensus that you need a GPU parallelized simulation environment to do this RL process really effectively. So just to give you an example, NVIDIA has developed their own GPU parallelized simulation environment called Isaac Gym, which is this thing you see here. So there's like a bunch of robot simulations that are happening on the GPU. And when NVIDIA did a benchmark of comparing the CPU-based simulation, RL training, and the GPU parallelized version, they saw a 250,000x speed up in the reinforcement learning training rates. So this is kind of the obscene speed ups that GPU parallelized environments can cause. And this is mostly down to sort of how a lot of the bottlenecks in RL training is always in the communication between the CPU and the GPU, which is particularly slow. And so we anticipate that, once we start doing a lot of the reinforcement learning with the EVM, this is the sort of 4 to 5 orders of magnitude of training speed up is what we expect using GPU EVM. And there are, attempts at doing reinforcement learning without a GPU EVM currently, but, they take something like 40 hours. So we compress that sort of 40 hours to 4 seconds or something like that. And then, the nice thing also about GPU EVM is just the fact that you can really scale this with multiple GPUs. So you can stack a bunch of GPUs, and if each GPU EVM gives you around 100x speed up, in a slightly non-nuanced way, you probably get around 400x if you have 4 GPUs, et cetera, et cetera. And one of the sort of final things that we're really excited about is, actually, let's just go to this. So there has been a breakthrough by NVIDIA recently called Eureka. So what does Eureka do? Eureka solves the problem of sort of reward model design, where, given a GPU parallelized simulation environment and GPU accelerated reinforcement learning, you can kind of tell the system, hey, I want you to figure out how to do X in natural language, right? So an example might be, hey, I want you to figure out how to drain money from this particular contract. And the Eureka system will run through this sort of LLM loop, as well as the GPU accelerated reinforcement learning, to figure out on its own how to design the reward function that interprets your natural language intent, and then turn that into an optimized RL agent that achieves your task. So what's phenomenal about this is now you can democratize reinforcement learning training for any particular task, and all you need is sort of natural language human feedback, and the system just figures it out for you. So this is the kind of self-evolving AI and the future with these kind of AI agents that we're much more interested in. And here's a small demo of GPU EVM as of right now. Sorry, I couldn't get it to work on my MacBook since I don't have a GPU here, but so this is GPU EVM running to try and find vulnerabilities in a particular code. This is just a very thin wrapper built around GPU EVM. This is actually being bottlenecked by printing. So it's running so fast that actually printing is the bottleneck, since you need to go back to the CPU to be able to render the printing. But this is the small demo on GPU EVM. And then, we're currently at the stage of, stage 1, which is GPU EVM. But we anticipate that sort of within a year, we will be able to exhibit superhuman capabilities that will really challenge human beings at their capabilities of, hacking protocols. And that's it from Gatling X, thank you for listening, and then I'll move on to EXO unless, actually wait, we'll get to questions first maybe. If anyone has any questions, feel free to shoot it away. Yeah, so we have a singular focus, which is around sort of we think being able to develop these hackbots are the most highest impact thing that we could be doing. And our go-to-market is actually really simple. It's be better than human beings in a measurable way. So if you look at Code for Arena, for example, all these sort of public code leaderboards, right? These leaderboards are objective and merciless. It is, just a very objective metric of, did you find the vulnerability? Yes, no. Did you find a sequence of moves that, allows you to steal the money? And we want to just climb up that single ladder, much in the same way that, let's say you're a novel human security researcher. Well, how would you make a name for yourself and get a lot of private audit businesses? This is exactly the playbook you will play, which is you compete in this public code audits and make a name for yourself, and then start getting private audits as the side biz. This is exactly the playbook we want to play because, ultimately what matters is that we replace sort of these finicky human errors and really replace them with reliable AI systems that can find vulnerabilities cheaper, easier, and faster. Cool. With that out of the way, I am now gonna do, oh yeah, thank you. And then I need to quickly do the demo for EXO. So I'm not gonna do the best pitch, but I'm pitching on behalf of Mohammed. And yeah, here it is. Right. So oh, sorry, just waiting for. So yeah, EXO is a edge AI protocol designed around sort of on-device inference, as opposed to sort of the current paradigm of centralized cloud cluster LLM inference. So they have a few demos around sort of how do you optimize AI models on the edge, and then how do you build a network of device clusters such that you can do lots of LLM inference. So this is the most primitive example where they are running Llama 3 on device. So this is not connected to the internet. You can just kind of ask some stuff away, and it runs the LLM inference locally. So that's obviously the very basic thing. But then obviously the limitation with trying to do this is that you can't run large models that is above the mobile device limit, right? So I think you can only do a Llama 7B on a iPhone because you don't have enough memory to do sort of these 70B models. But then so what EXO is really focused around is okay, how do you solve these problems one by one? So one of the solutions for running 70B models is they've built this technology that allows you to shard model inference across multiple devices which are connected within a local network. So this is a demo of you're splitting up the LLM inference computation across multiple iPhones, multiple laptops, and multiple Apple devices. And I think this is running Llama 70B. So you what you're doing is you're effectively breaking up the model into a few parts and then using the computations in each of these devices and aggregating them together. This has kind of powerful implications where you can run very complicated AI agents that unlock new use cases. So this is I think this is a single model use case, but what you can do is you can get a much better Siri that is far more functional than what exists today. So for example, oh, sorry, this is a multi-device demo. So you might be oh yeah, I want to I want to schedule a calendar meeting with a friend, and you tell that to the model, and then you shard that inference across multiple Apple devices that are connected by a local network. And because it's connected via a local network, your communication overhead between each device is relatively low. And yeah, you can see the automation running where, like, you know, your LLM controls your phone, and you know, it like schedules the particular meeting at a particular time, and does the stuff for you so that you don't have to. And this is obviously just a basic demo of like these LLM inferences happening, but you know, you can generalize this framework to lots of different types of AI applications. And yeah, I mean, you can watch the demo play out. So I think here, like, they're running a Llama 70B, which again, the point is that you can't run Llama 70B on a single iPhone, but you can if you shard it across multiple devices. And yeah, you can see like the demo opens up like Telegram and then, you know, says, hey, I sent you an invite to the calendar, et cetera, et cetera. Right, and there's a few more. So, oh yeah. So like effectively, you know, what they're doing is this, where like instead of having massive GPU clusters, this EXO is all about, okay, how do you have clusters made up of like local devices, like iPhones, for example, which is a lot more readily available, and share all of that compute that is available maybe over nighttime. So, you know, for example, you might be happy to provide your compute to random strangers when you're like charging your phone overnight, and you just let jobs run in your local network cluster for use, for example, in protein folding, or, you know, LLM inference, or lots of other things. You know, there are historical examples of people running like protein folding simulations, which is really helpful for biotech, for effectively free. And you just add sort of token incentives to this to be able to do that effectively. And then, yeah, like they've also done stuff where, you know, they've connected a bunch of Mac Minis and then did like training as well of like relatively small models, because you sort of have these high bandwidth interconnects between different Mac devices. And yeah, I think that is mostly everything. I can try and answer questions, but yeah, that's all of EXO. All right, if no one has any questions, Jahal? Thank you. All right. Ah, sorry, that's yours. My bad. Hey. Ah, yeah, true. Thank you. Hey, great to see you. How you doing?
Check, check. Hello, hello. Okay.
Sorry.
It's working. Congratulations, you made it to the last panel of the day.
Sorry. Sorry.
Do you know about the one that goes over? No. Do you know about the one that's about the roof? It'll go right over your head. Yeah, I know. This is how brain dead I am. I'm like, I can't even tell a joke right now. Good thing I have my notes. No. Everybody's just finalizing the mics.
Ok. Voilà. Ok, merci. Oh, pardon. Okay, good, good. Let's go. Allons-y.
All right, esteemed panelists, let's take some seats.
Oh, sure. Yeah.
Again, if you're networking, you want to chat, please go outside. Otherwise, we can't really hear the panelists. So my name is JK, which stands for Jacqueline Kwok. I work for DCG as head of platform or director of growth. I'm here with a few of our panelists here, and I'll have them introduce themselves.
Hi. Yeah, I don't think I need the mic. Well, thank you very much. Brief introduction. Gui Silva, founder and partner of Tigers Capital. We are based in Oxford in the UK, and we focus on what we call Web3 deep tech. So we like very much in the last 2 years, we have been focused on computing and blockchain applications, AI now, everyone is talking about AI, of course. And we have some investments early stage from this area, of course, Flock included, and also 2 other presented here before. Thank you.
Awesome. All right. Well, folks, yeah, thanks for having me. My name's Anand. Also an investor. Yeah, excited to talk to you folks and unpack a little bit more about what we're looking at in the space.
My name is Anna. I'm also at DCG and doing early stage investments and really excited to chat now with these guys.
Hi everyone, my name is Tim Corey. I'm with Lightspeed Faction. Yeah, we're a Web3 venture firm. Happy to talk more about that later, but yeah.
Thank you everybody for being here. So the first question is really defining what this space is. What is decentralized AI to each and one of you? Let's start with Anand.
Yeah, and maybe for some background, like it felt a few years ago, I mean, maybe I'll get vulnerable and speak about some of the opportunities that I saw here and why I kind of gravitated towards this. But I think coming out of like Terra Luna and seeing what had happened around that time, as a new fund manager, right, in the middle of 2022, I think I was going through a little bit of an existential crisis on like what it means to stay investing in this space. And so that was like point number one. I just met the team at Jensen around that time, and they were pretty heavily convinced that there were strong tailwinds that AI was going to start to become a thing, more so than it had ever been before, which I wasn't really convinced was going to be the case because I feel like we've been hearing this narrative for about 30 years. And then, yeah, I live and work in San Francisco. I think through osmosis, it felt like I was starting to assimilate a lot about what's happening in the world of AI. So, and then as I started to dig in more, I'll kind of land this plane, I promise, but what I started to realize was that for everything that all the data that we've accumulated over the last 30-something years since the sort of like the real true birth of the internet and how these models are now starting to get developed, it felt like we needed to have a strong counterbalance for what's starting to get aggregated from a centralized perspective. And this isn't just about another search app. This wasn't just another utility. This is about intelligence. And it felt like we needed to have a good counterbalance for centralized intelligence. And it also felt like for every primitive that we've been building in the world of blockchains for the last 10 years, I've been hearing this narrative so much, and we all have, right? Which is like, blockchains are missiles looking for targets, right? And it irks me every time I hear that. And I felt like all these primitives are really well suited to solve the problems that are emanating from this blast radius of centralized intelligence. So to me, these are core primitives that support how we can think about AI moving forward, supported by blockchains. It is infrastructure that gets built on top. It's a version of the internet that we should all be super proud of using because, again, what I guess Web3 brings is the sense of ownership, and I feel like that's been what's been missing in Web2 standards. So I know it's a really long-winded answer, but to me, it is it's a marriage of everything we've been building for the last 10 years in the world of crypto, serving artificial intelligence.
Maybe just to add here, I think like AI and crypto and blockchain are the two biggest technologies, and we really see them complementary to each other. So the economic incentives and the decentralized infrastructure can help AI to, we have been chatting today about sourcing quality and diverse data sets in a decentralized way, or on the other hand, AI can solve a lot of problems in crypto, such as smart contract automation, or oracles. So we see a lot of interesting use cases that have been especially accelerating in the last few months. And that's why it's also very hard to filter and find those that are really interesting, exciting, and also feasible. So we are definitely excited about these two intersections.
Yeah, I tend to break this down into what superpowers can crypto bring to AI and what superpowers can AI bring to crypto, just to like analyze that intersection. And I think in the first category, you have verifiability, and I think that's really important, verifiability of data, of model training, of model inference, letting people peer inside the black box of AI, and be able to trust those systems more than they have been able to in the past. I think the second superpower that crypto can bring to AI is coordination of resources. Incentivizing people to bring together data sets, incentivizing people to provide compute. So I think that's sort of the second one. And then going the other way, it's what Anna just touched on, using AI to let people interact on chain in a more natural and easy way, simplifying the UI UX problems that we have. And that's kind of related to, a bunch of things. It's kind of related to intents in a way, just sort of say what you want to happen, maybe in natural language, and a bot just goes and figures it out for you, like that kind of thing. That's generally speaking how we think about it.
If I can just add one thing, it's just like the way we look at it, we discuss internally quite a lot about that, and sometimes we see some projects which might use some tokens for incentivizing communities and everything, and then we came up with this idea that we need to find this symbiotic relationship between AI and crypto, really to be an AI decentralized crypto project. Otherwise, it's an AI project with some tokenized economics. And we feel, in the line that Tim said, that if the first question is, can this AI project be done without the blockchain, or can this blockchain be done without AI? Normally the answer is yes. But if we feel that that specific project actually is able to become more efficient or to do it better using the two technologies, that's where we like. I think we saw as well when we talk about AI agents and Gatelink, what they are doing for the security side is an application, of those two together. We see as well when we are using AI for, of course, data empowerment as a very strong application. So just summarize this, that we internally use this word with symbiotic combination when you look at the project.
I mean, both Web3 and AI are very much developer or engineer-led industries. So what kind of talent do you look for in a founding team of a Web3 AI startup?
Yeah.
Who wants to go first? Don't talk all at once.
Well,
I mean, I can start. I think something that we always discuss in our IC is whether the founders are first-time or second-time founders, and especially in such a space like AI, crypto, it's emerging technology. I think being a founder who already built at least like a company before, I think that's very it's a strong argument for us to put a high score on the founder in the memo. And secondly, I think I chat a lot with GUI about this. We are trying to support more universities, and I think we see a lot of good founders coming out of Oxford, for instance, or Cambridge. So we try to be connected to these universities and support talent early onwards, because especially, I mean, I come from Europe, and I think here generally like in university, you don't have such entrepreneurial education than in the US. So that's something that I'm really excited that you guys are supporting, for instance, in Oxford, that these technical talents also get entrepreneurial education so they can successfully launch businesses.
And just for me to add on this, just to give some background, what we have been doing in the last couple of years. We creating Oxford, actually created by Josh. He's not here, but Ato is part of the community. We create this kind of hacker house where if you're really smart PhD or post-PhD student and you want a hacker house like the ETH Denver or any other project, you can live in the house for free for a year. Then you have the chance to meet co-founders, and you have the chance to, we don't have obligation to do a business, but if you decide to do a business, we are also there to support. And this has been super cool because it's taking a little bit of time, but now we have great projects like Gatling is from there, Exo is from there, Flock has also a heart in Oxford. So we started with one house and now we have 5 houses, and we have one house, half a house, we're just building a house, not building, like renting a place in Cambridge and in London. And that's kind of how our approach to this. We had, even with our CTOs and everything, we found it very difficult to get, to challenge enough founders for Web3, because transition from Web2 to Web3 is possible, but the real innovative project are Web3 native. So this talent is because they have not thought differently before. They have not thought as Web2. And this is very powerful. And for you to be, even if you have 2 or 3 CTOs, to challenge those guys is very hard. So what we do, we use the house, let's say we have the British champion of maths living in the house, 2 GB Olympic team champions for computer science live in the house. So if you go there and say, oh, I want to do this, I'm very good in math, okay, no problem. Just talk to the other guys here in the community and see how they can help out. So for us, that has been a big bet. We believe that Web3 in the beginning was more token and everything, and then we had the DeFi, was more meme coins and everything. But we believe that the future is actually, like you can see with AI, is deep tech. In many, many areas of deep tech. Robotics, we have some projects that are coming in robotics and Web3. We have other areas coming that we believe this is the future. So that's our bet. We are the smallest of all you guys. We are kind of university-based. We're quite small there, but we are part of the local community, and that's what we're trying to do.
I guess I'll piggyback off the previous answers. This intersection is so nascent that it's quite rare to find founders who have previously built and exited a Web3 AI project. That's unlikely to be the case, right? But we look for expertise in either one of those, or failing that, I think staying close to the sort of emerging ecosystems around some of the major sort of universities and what's going on in academia. I think that can provide a pretty sort of fertile breeding ground for some of the latest ideas to start to be incubated and start to take shape. So we spend a lot of time there.
The rubric for me, aside from these all these points, is that I think this is starting to become really apparent, maybe slightly controversial, is that I start to look at the founder and figure out if they can build a cult. And I mean that in the most genuine way possible, because I think that's necessary in crypto. And the second thing I look for is, what are their earned secrets, right? What's the X factor? Like when I talk to them, Ato is a great example. I've been talking to him for quite some time, and every time I talk to him, I think I learned something new from him, and that's really refreshing for me. And I feel like I pick something new up, and those kind of earned secrets only come from domain expertise, spending time and really understanding the problem and giving it everything you got. So I think that's the second one. And third, I actually do look for talent outside of crypto a lot, and mostly because I worked at Microsoft for a long time. I've built companies that hit scale in Web2, and the kind of shit that we've seen is like very different from the kind of stuff we see in crypto. For the kind of DAUs, MAUs that we've hit and have Web2 petabytes of data, it's unparalleled, right? So trying to bring that level of expertise into crypto is hard, and I'd love to do more of that. So from a funnel perspective, I look for those people, but then once you enter the funnel, there's a couple of the things I look for, like trying to be a cult leader.
Sounds great. So none of you really mentioned product market fit. What does product market fit look like for this space?
I can start, and I think this is an easy non-answer for me because it's very tongue-in-cheek, but in my rubric, like 5 points in there, but team is just like paramount. It just overweighs everything else for me. And so, but it's easy for me to do that, just being a very early stage investor. So yeah, I try to focus on that a lot. And I almost feel like it's incumbent for us as investors maybe to work with the team to get there to product market fit, and hope that's the expertise that we can help bring to the table. And not by being too overbearing, but just, if we can help them get there, that's great. But so I'll go first and say I don't have an answer for you. I just try to go in really early and with some pre-seed options.
I don't think we've seen it yet, but I think we have an idea of what it might look like a better, more private version of ChatGPT, for example, right? You can provide it your health information, your financial information, and not have to worry about what OpenAI is doing with it, because you can actually see what the model is doing. You're able to sort of peer inside that black box, and maybe the data that the model is being trained on, being inferred on, is staying private to yourself, and so you have an assurance that it's not being sort of leaked to the broader world. I think if there were a product like that, that could appeal to a pretty large segment of people. I don't think we've seen that yet. I think that's one of the things that we might see. 100 million users in 6 months if things go really well, but obviously it hasn't happened yet. I think it will.
What are some of the blockers? Because I think the end state that you just described would be fantastic, but there are many obstacles that, are going against these people building towards that solution. So what are some of the key obstacles that people are running against?
I think one thing to add here is, which also applies for many crypto projects, that incentive alignments are too short-termist, and especially in the AI space is so early. So we would love to see more long-term incentives. So when it comes to designing the tokenomics and looking at the network effects, and I'm asking these founders who are telling me that, yeah, we are going to launch token end of this year, and then we ask, okay, how does the value accrue? How do you think about incentivization? And they haven't really talked about it too much. So we would love to see that founders are, especially that they are not doing liquidity events before finding product market fit, but really think about long term. and we don't mind investing at such early stage that maybe not going to launch token this cycle, but rather next cycle, but then really find product market fit.
Just to add, first, I need to confess that most of our investments don't have a clear product market fit. I need to confess that. But what we like to see is the commercial ambition from the founder of sharing with you 2 or 3 potential market fit that they are super excited about. Might not be the end game, but you feel that they are going to get somewhere. So sometimes we don't have most of our investments we don't have very clear, because of the tech is quite new.
So what kind of tech and AI are you guys looking for? Be specific, and how do you diligence that?
Who wants to start that?
Sorry?
Who wants to start?
I mean, I can go. I'll just give one example. Again, just sort of doubling down on this idea of verifiability of model training and model inference. There's a few ways to do that. You can do that in a more sort of specific way where you're focused on circuits that actually represent some of the actions that you commonly see in machine learning. So there are a bunch of ZKML projects out there, some of which we've heard from today. And I think the benefit of that specialization can be speed improvements and performance improvements over, say, something that is more general purpose. And that's, what does that look like? That looks like a more general purpose zero knowledge virtual machine where you can prove any sort of code has been run correctly, and that could include machine learning models. Problems with those approaches are they're quite slow today. They'll get faster, but there is a massive sort of engineering lift that is required to get there. But yeah, there are some teams that we think do a very good job of that. One that we invested in, as did the main Lightspeed fund, is Nexus, but there are others. So that's one vertical, and I'll allow this to talk
Very
about more.
upstream.
I'm happy to add another one. So We invested recently in a company, Oxford as well, C3, which they use cryptography to identify whether an image is AI generated or not. And that could be quite interesting. And it's a good combination for the symbiosis between blockchain, cryptography technology with AI. The other one is quite interesting. It's not from Oxford, it's Cambridge. It's fine. It started initially trying to find a way to reduce costs for mining and other energy kind of intensive applications. And now they are developing a near zero energy chip that can be applied to anything that use silicon chip. And I can explain to you if you guys want another drink how this works, but pretty much you can do mining without energy, you can do any computing without energy from Cambridge.
I think we have looked at different parts of the AI crypto stack, and I think on the data layer there is still a lot to unpack. How you source quality data, diverse data sets, how you verify data labeling. So I think generally, if I would need to choose one JK, that would be the data part. Yeah, how do you think about it, Anand?
Yeah, it's these are very. I mean, these are all great. I'd say that like I don't know if you folks read this thing by Leopold Aschenbrenner, which is he wrote this thing about situational awareness. He's one of the researchers at OpenAI. It's a very, very long read, followed by I think a 6-hour podcast or something with Dwarkesh. So do it at your own time or when you're on a long haul flight back home. But the summary, there was something he mentioned, which was we're currently doubling in terms of compute usage, in terms of algorithmic efficiency and data unhobbling or data unbundling in models by 1 order of magnitude every 2 years. And so maybe it's a clear, I don't know, the line is getting even more clear that we'll have AGI, I don't know, some in the next 4 to 5 years. Definition of AGI is TBD, by the way. But if that's the case, right, like there are 2 things that are like really top of mind for me. One of them is on UBI, universal basic income, or you can interchange income for internet because maybe just getting money for free isn't the right answer for purposeful work for humans. So I know this sounds it sounds too futuristic or science fiction, but it's something I've been thinking a lot about because it's getting more real, and maybe I'm just drinking the San Francisco Kool-Aid too much, too many underground parties. But UBI is one, and then, yeah, just another area that I feel is going to be imminent in the near future is as we start, like Ilya's been talking about user-owned models, or the fact that we're empowering models to do a lot of work on our behalf, that agents will do a lot of work. I believe there's going to be a new paradigm that needs to evolve for agents to be able to communicate with one another, right? Like this concept of like programmatic interfaces and endpoints that, as we know them today, that developers use, are not how agents are going to communicate. The way they request, respond, and how they consume information, how they transact is going to look largely different. So this concept that we're seeing today that's going to look like agentic infrastructure is going to evolve very drastically, and it's going to be pretty monumental. And I think I tied this back to how we just need an open, auditable, verifiable way to do this, which is why blockchain primitives exist, which is beautiful. And at some point, this is going to look like really high transaction velocity for blockchains, which is why I'm long-term bullish. So I would summarize as like, I think they're great points made, but like for me, if I'm looking out 2 to 3 years, I feel like these are interesting problems to unpack and may sound like science fiction, but it's going to become fact, I think, sooner than we think.
What are some of the assumptions that need to hold true for that future to be realized? Because it is pretty futuristic.
Yeah.
And it is very San Francisco Kool-Aid.
Yeah, very much so. I mean, it's talent. It's talent, it's focus, it's research, it's depth, conviction. There was, and I was saying this yesterday on another panel, so I apologize for anyone, this sounds like it's repetitive, but Mark Andreessen once, I remember like I had the opportunity to pitch him, and he said something that always sticks with me, which is, he said, the best founders have this way of convincing everyone that their perception is reality. You're kind of living in this version of a future with them. And in some ways, maybe I'm doing this here right now to you folks, projecting. So I think it's a matter of yeah, trying to draw this line between where we are and where we'll get to, but just keeping up with how quickly technology is advancing and finding people who can kind of like help us shape the future. So yeah, I don't know if that was a direct answer to your question, but I feel like it's just, for me, it's about people and talent.
And so on that, a lot of the talent concentration in the AI space, machine learning space, is in Web2 centralized, sphere. And they don't really think about the Web3 side at all. What do you say to those naysayers to get them on board?
I'm happy to say on that, because I have quite a strong view about this. I'm going to say something maybe polemic, but I don't think AI has a future outside Web3. And I say this for two reasons. First of all, is regulators. I don't think regulators, now they're already worried about, but in 10, 20 years' time, I don't think they are going to allow data and power to be in the hands of 3 or 4 companies. So they need to think about this. The first reaction is going to be, we need to have license, or every single company in AI needs to have some kind of servers within the government. I don't know, they're going to come out with something very centralized. But then they realize this is not going to work. So the only way for you really to be able to have some governance around data and not have a concentration of power, because data is oil and all this thing, is through a decentralized way. The second one, which is probably more important, is that future generations, and I'm an old guy already, and you can see the new generation is coming, they are not going to accept this idea that we have accepted, that our data can be used or misappropriated by others. And similar that in the past, we accept somehow slavery at some point, but then in 19th century we said no. We will say no to this. So I think AI without a decentralized Web3, is not going to really exist. Maybe it's too polemic, but.
Yeah, I mean, it sort of touches on what everyone's been saying, but I think people who are spending a lot of time in Web2 AI, I mean, there's different camps, but there's a large contingent of people who've expressed a great deal of concern about the centralization of increasing amounts of power, to effect change in the world, however you want to sort of define power. These systems are becoming more and more capable. And so I think it will come as music to a lot of people's ears that there is a way to bring visibility, to decentralize that power, and to put sort of other guardrails in place. And I think that's what Web3 can allow for.
Anything to add, Anna? Otherwise, I'll ask.
I mean, these are all great points. I just hope that in terms of timeline, we are going to get there sooner than later, because, I just ask always Giaho, like, he has a lot of Web2 AI friends and other like ML engineers, and they just say that all my friends in Web2, they just don't want to go and build in crypto. So I think we are still very, very early. And that's why also founders who come from Web2 ML are very lucky now fundraising in crypto, because they have very high interest from us VCs. But hopefully soon we are going to see more and more Web2 ML talent actually think how they can build in decentralized way.
Great. Thank you so much. I'm sure we're all here because we're interested in this topic. So how can we follow your thinking, your latest news and stuff like that?
Well, for us, on our side, we have a daily bite. I think some of you receive. We publish like 5 bullet points that you receive your email. If you want, you can unsubscribe. But we have this called Tags Bites. So if you go to our website, you can subscribe.
BYTS or BI?
Yeah, BYTS. And so it's 5 bullet points of what's going on in crypto. And of course, you can reach out to us on X or other platforms.
Yeah, I think the best channel for me is via Twitter. I'm just AI on Twitter.
The best handle.
Mm-hmm.
I think for us, you can have multiple touch points with DCG, either through us investment team or through our subsidiaries. Also, Foundry has an in-house team of 10 ML engineers. So just reach out to us, and I'm sure like someone will reply, and you can get in touch with us.
So on X, we're at FactionVC, and if you want to DM me, I'm at Tim_Corey on X. Yeah.
Thank you so much.
Thank you.
That's it.
Thank you, JK.
Nice work.
Thank you. Yes. Thank you.
Thank you. Thanks for coming. Cheers. That's great. Thanks everyone for having this full day with us, and well, especially for those who stayed up until now. And we have the venue for the rest of the afternoon, of course. And there are beers, there are snacks, little sweets. So yeah, if you want, feel free to hang around in this venue place. And thanks for coming. And hopefully, we will have more events in next following big events in crypto. Thank you all. Cheers. Thank you.
inspired. Can't